A very warm welcome to ES 2023. I'm honored to be your anchor for this remarkable event where we have gathered together to delve into transformer technologies, new and next. Before we start with the day proceedings, I'd like to share with you a little about ETES 2023. Organized by Electrical Mirror Tree Sub Media Private Limited. Today we embark on a journey of knowledge sharing, collaboration and innovation as we bring together some of the brightest minds and industry leaders in electrical systems from around the country. This conference serves as a platform to explore groundbreaking ideas, engage in insightful discussions, and foster meaningful connections that will shape the future of electrical industry. So without any further delay, let's give a head start to the program. Ladies and gentlemen, it's my utmost privilege and pleasure to extend a warm welcome to our esteemed guest who graces our presence today, Mr. P.K. Patnaik, Mr. Subhash Chandra, Ms. Monica and Ms. Neha. I would like to call you all on stage. They are a true embodiment of excellence and accomplishment in their respective field. And we are truly honored to have them here with us on this momentous occasion. With this, I would like to call on stage all of you. I'm sorry, am I required? Can we have a huge round of applause for these brilliant minds? Thank you. Now, as we have our honored guests on stage, I would also like to call Mr. A.K. Kaul on stage, please. Can we have a huge round of applause again for him? I would also like to call Mr. Rajesh Arora on stage, please. I would like to call on stage Mr. Bomik, sir. Could you please come on stage? Now, as we have our honored guests on stage, I would request them to lighten the lamp, please. I would request you all to please stand up and lighten the lamp. Thank you.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि
Can we have a huge round of applause as they lighten up the lamp?
गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे
Now, as we are done lighting up the lamp, I would request Miss Neha ma'am and Subhash Chandra sir to please offer the bouquet of flowers through which we express our heartfelt felicitations. Can we have a huge round of applause again, please? Come on. Now I would request Mr. Patnaik sir to please offer the bouquet to Subhash Chandra sir. Now, ladies and gentlemen, it's time for national anthem, and I would request you all to please rise up and join me in honoring our nation.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Now that the Almighty has blessed us, I would like to welcome Miss Monica Chahar to please deliver the welcome address. Could we have a round of applause for Miss Monica Chahar?
Greetings for the day. A very heartily morning to everyone joining us today. I, Monica Chahar, welcome you all to the first edition of Emerging Technologies on Electrical System, ETS, organized by Electrical Mirror magazine. Before we start the conference, I would like to express my gratitude towards you all who sincerely contributed to this event in order to make it a successful. This wouldn't be possible without the support of each and everyone present here. Firstly, I would like to thank the experts for taking their precious time out and making to this event. Secondly, I would like to thank my audiences for being there for today. Before we begin with today's session, please allow me to deliver a short speech in order to warm up everyone regarding today's agenda and brief description of the theme of the conference. ETS 2023 provides a platform to discuss the experiences, knowledge, and technical advancement and ongoing trends in electrical and power industry among various manufacturers, power industry players, and utilities. This event could be the pathway to meet the challenges and evolve new strategies for techno-economic development in the field of generation, transmission, and distribution. The theme for the conference is Transformer Technologies Now and Next. The transformer industry in India is experiencing a range of transformative trends that are shaping its future. The Indian power sector is one of the most diversified in the world, considering that we are capable of generating power from both conventional and non-conventional sources. India is in fact the third largest producer and second largest consumer of electricity worldwide. India's economy has been soaring at an impressive pace, positioning itself to become the third largest economy by 2030. The country's power infrastructure has been expanding by leaps and bounds, leading to a surge in demand for electricity and power generation, as transformers play a crucial role in the growth of power grid. Furthermore, the transformer industry plays a vital role in power sector, and the industry has been experiencing a range of trends that are shaping its future. The Indian electrical and power industry is at the forefront of the transformation and is undergoing massive changes and redesigns across the entire value chain of power generation, transmission, and distribution. To ensure that industry keeps pace with the fast-changing, exciting developments in the industry, ETS 2023 aims to provide a unique platform for experts from around the globe to present technical papers, case studies, discuss and deliberate upon key topics such as innovative materials, diagnostics, and upcoming technologies. This clubbed with panel discussions from leaders in the industry who will provide valuable insights to different stakeholders and will help create new pathways in the transformer segments of the industry. India has begun to carve a path towards an enabling environment by establishing an ecosystem. Join us in being the catalyst for promoting this growth. I assure you that this conference will prove to be fruitful and informative for all the members participating in this conference. Also, it gives me immense pleasure to announce that we are celebrating the 12th golden anniversary issue of our magazine next month. A big thank you to all of you who have not only helped in running this magazine for 12 years, but also making it a huge success. Now, our honorable guests and experts speakers will share their knowledge with us. It would really help us delve deeper into the subject and understand the concepts of technology more deeply. I would also request my audiences to remain seated and listen to our experts, as thereafter they shall be liable to raise their doubts and questions. These doubts and questions then will be taken by our panel of experts. This event will also include numerous interactive and fun activities as well. And I feel delighted to tell you that this conference will end with an award show where all the candidates will be rewarded with certificates and prizes for being the linchpin of the conference. 1,000 miles journey always starts from a single step. Today we have just stepped our first step to reach much ahead in this endeavor. We seek your blessings with great hope and admiration to serve the best up to your expectations. Let's join hands for the best of all individuals and as a whole for our nation. Thank you so much for being a part of this conference, and I wish you all a learning experience. Thank you so much.
Well, thank you, Monica ma'am. मंजिलें उनको मिलती हैं जिन्हें खुद का रास्ता बनाने की चाहत होती है. So thank you very much, ma'am. It was indeed an insightful, warm and engaging welcome address. Since we have the distinguished presence of our special guests, I would like to call our esteemed guest of honor, Mr. P.K. Patnaik sir, Admin Spark Group on stage, and would request him to address our beautiful audience. Once again,
Namaskar. Jai Jagannath. While addressing this Jai Jagannath, I bit excited because I am from the state Odisha, where our Lord is right now not in the temple. He has just come out. So he will be there with all the public. So you are also part of that. So with this auspicious moment, this program we are going to start, definitely it will be exciting us, enlightening us, and also add some of the things which it will be helping us to go with flying colors. I'll be talking a bit related to this. I won't take time. I will be talking about the theme of this total session today. So my theme presentation will be there. With this, the theme of the paper is transformer technology, now and next. So you can go ahead, next one, or you can give me the that. Okay. So if you think about the transformer technology, first of all, in one angle I can say, it was then when we are emphasizing over the robust design. We are not thinking about the things, the cutting edge principle. Then the situation came to go with techno-economical design, the cutting edge kind of things, where we will be exactly thinking about all the part of the transformers. So that is the quality conscious kind of things. Then right now if you go, that is the emphasis upon how like the transformer will be talking to you. That means the digital world. Every equipment need to be available at your palm top, or will be at your wherever you need to have all those informations. So that is the next what it will be there. And also we have already entered to that. If I take the human all these things, I can say the situation was of linear and local. The knowledge was of linear and local. The day was there whenever the Homo sapien kind of things were there. If I come to the next one now it is not linear. It is actually in a global mode. You are right now getting connected in the global mode and also in an exponential way. Every technology is going in exponential way. So what would be the next? Next it will be not only with globe, it will be with of universe. Means you will be talking with Mars. You will be talking with of Jupiter. So the kind of concept will be in super exponential. So this technology, if I go considered under with this 6D managerial mode or management mode, In this 6D management mode, I'm talking one example relating to the digital kind of things, talking about your mobile set, what you have. Initial days, the people, those who are having the mobile set, they were being considered as the poor person and also the having of a rich person and all. But right now, you feel where it is available to everywhere. So it is a question of a democratization. The mobile technology is now in the form of a democratization, getting available to your maid, getting available to the rickshaw puller and everywhere. And what not, it is also getting of a demonetized. All the things, your radio was there, television was there, even if your Netflix, whatever the things what you have, that has been clubbed up in your mobile. So this is the one how it is going for. But initial time, it was in the deceptive mode. Then now it is in the disruptive mode. And finally, it has come to the point which you call the democratized. Everywhere it is available. So this is the how the technology is going on. So in one line, I can say the technology is changing that fast, we can't believe also. Now, if I go for the concept of ETS, how is the concept been framed? ETS, the emerging technology on electrical system. It is of actually delegates-based conference, means delegates will be speaking to us, we will be addressing them. Authors response-based conference, means some of the sessions we have framed in which authors will be speaking, you also will be in that, so it will be the interactive session. Final session will be the concluding part, where actually we are not going to take, we will be clubbing up everything, and also we will be publicizing one sort of concluding paper. Basically what happens in general conferences, the concluding paper not get published, and it gets that conference get closed without having any kind of takeaway. But in this, we will be preparing one concluding paper, which will be available also with you in form of one magazine, that the electrical mirror. Now, session number 1, we have got 9 speakers. Session number 2, invited speakers we have, the experts of, the eminent experts of nation. Then in session number 3, we are having invited and also the well-wishers, our sponsors and all. Session number 4 will be the panel discussion. And finally, the session which of concluding session, there we are having also the special attraction for the lucky delegates. They will be there. Those who are available during that time, definitely they will be getting also the attractive gifts. So that is also we have kept here. Then, what basically we think about our transformer? If I consider about the transformer, the basic link between the generation, transmission and distribution, if I call the generation, transmission and distribution, that comes under the mythology Brahma, Vishnu and Mahesh. So if Brahma, Vishnu, Mahesh, you are going to unite, then you need one tool. That tool is of a transformer in this way. If transformer I am taking out in the power system, then definitely nothing will be there of available and they cannot show their show. So this is the one how like the transformer we must have to fill, and today's session also you must have to be thinking in that way. So you will be knowing to get maximum important things, the emerging kind of things. So those are right now listening in physical mode, definitely it will be one kind of advantage. So the wish list, if I go, every engineer or every power professional sitting over here must be thinking the transformer to burn with a healthy baby. So whenever you plan for a baby, what exactly you have to do? You must have to go for the proper inception, proper GTP, proper bidding documents should be there, proper technical specifications should be there. If it has been finalized, automatically the baby will be of a healthy baby to come out. Then second, whenever you are planning to have everything freezed and it is going to the manufacturing site, then at the manufacturing site they will plan accordingly because already been taken in terms of GTP and all. And that time you will be having to get the embryonic stage. In that embryonic stage, there will be manufacturing stage, inspection, dispatch, so and so. Then you will be giving birth the child or the transformer. Then transformer will be getting adopted at the site. So this is the second stage. If I talk to the all these things, then I can say the concept comes under, okay, just born healthy. Now, the second one, the infancy. Whenever transformer gets coming to the site, getting energized or commissioned, then it is the infancy stage. Infancy stage, we have to be bit cautious. Thereafter, it will be the young dynamic stage. But don't think that dynamic stage also will not have anything. Recently, the corona came. It did not listen about anyone. Even from the infancy, even from the old age, even from the anyone. So such kind of corona may also happen to be there for the transformer. So that is whatever the young dynamic it is there, you have to be cautious and you have to go for the condition monitoring and all. Thereafter, it will be the old age. Every old age, we need of care. So that care kind of things today, the people those are sitting over here, they are all our experts. So they are the doctors. Right now, so many doctors are there. electrical ductors are there. So to them, we'll be listening also about the old days, how to take care. So if I come, right now, I can say it is to live healthy. The transformer must have to be living healthy. Then finally what? Finally is of graceful death. If a transformer is there, we need the transformer to be dying also healthy. Transformer dying healthy, what does it mean? It is called a nirban. So we all need our transformer to go with the nirban. So that particular one, how to go for? With a proper repair, replacement, thereafter we go for the RCA, root cause analysis. Suppose one transformer dies, we need to have root cause analysis, diagnostic, so that finally we can get to know that what to do in the next way to get better kind of transformer. So this is called the nirban. Now, if I come to all these category discussions today, the doctors, those who are sitting over there, sitting over here, they will be talking about these categories today. So first category comes under the TDC, transformer design connectivity. We'll be having some design papers and all, like TCHI, transformer condition monitoring, health indexing, TPD, TA, and TPM. So if I come to this TDC part, we are having actually 5 papers on the TDC part, where actually Mr. Tukaram will be talking about the cutting edge kind of things, where this CRGO to be compared in terms of amorphous, what the advanced technology amorphous has come, it will be compared, and finally how it is managing this, so that also he will be speaking, so which needs of the way to, and you will be listening to him also as the first paper. If I go for the Dr. Hariom Gupta, okay, he is the professor also, so he will be talking about the joint, and then finally if I go for the Srinivas Shripadji, he will be talking about the real kind of things, the kind of clamp connector and all. So that is the part which comes under the Srinivas Sripat Singh. So innovative practical connection hardware on the distribution transformer and also the power transformer. Then Tanvir Adilji will be talking about the cost-effective quality control in the in-house transformer repairing conditions, how the all transformers have come, how to take prioritization of taking the repair. That will be the address by the Tanvirji. Then if I go for the last one, the paper, the Anil Khopkar Sahab, he will be talking about the recent technology and considering of one hotspot. It's a very good technique, the one which he will be presenting to you. Hotspot kind of things also will be managing of every transformer, and you will be getting your transformer in better way if you control the hotspot and all. Then to this TCHI, we are having a very good paper, and also the invited speakers we have. In this, Yogesh Sood will be talking about ODS, online drawing system. And MVPD, the one which will be taken by the G.K. Gupta, Mr. G.K. Gupta will be there. And that method will be considering that need not to take your transformer, the particular MVPD will be coming to your transformer. So you will be managing the transformer, how to make as good as a new one. That is the concept he will be talking about. Then Manjusha ma'am will be talking about the all kind of interpretation relating to the digital gas analysis. And those things will be how it is taken in the ERDA. She will be talking about. Then health indexing part will be taken care by our respected Bhomik Saab. He's having a very good long experience in this regard. So the one will be considered, and how he has developed some of the few concepts, the software and all, that also he'll be talking about. Then Dr. Rajesh Arora, the eminent speaker of Indian sector. So he will be talking about the DZA, how the evolution has been considered with some sort of case studies and all. Now, the presentation relating to the TPD, transformer protection technology, I mean how the transformer is to be protected, that will be taken care by the Navrun Banerjee, who will be talking about the water mist, the one you might have heard the water spray kind of things are there, but he will be talking about things how water mist is helping in place of a water spray and all. Then arc casing, one of the new concept been taken by the Ishan MR group, and they will be talking about how arc sensing, means from the day itself whenever the arc sensed, it will be just to be monitored, and it will be starting action. So that is the new concept they will be talking about. Then at the last part, transformer allied subjects we have taken 2 allied subjects because it is the promising kind of things where need of the way to listen integration of RE. So in that integration of RE, how it is also getting affecting to the transformer, that will be taken care by Baldevji. And finally, Rajesh Bansal Sahab, of course, so he will, because of some reason he is not going to join, but still if he will be coming, then talking about the things, how those issues are there in the distribution sector. So if I consider all these things, TPM, the few papers are there, which basically our measurement groups have come. In first one, the decoding, it is a very good way how the safety comes into picture. I mean to say the NEC, National Electricity Code has come, 2023, but some of the few points which were not there in the measurement one, now it is being considered, basically fault loop impedance and the safety kind of things. So that will be taken by our Mr. Sam Ravindran. So better operation and live by analytics, the transformer IoT. This is a very good concept been developed by the CRIPS, and in that way you will be getting to know all your transformers parameters also in your handheld. All these kind of things will be there in the desktop, and you will be getting to have control your transformers and all. So that is the kind of better operation. Then GIS monitoring and health assessment. This is also one of the very good concept they have considered. Basically the partial discharge, how the partial discharge, we get to know that we are not emphasizing the in India sector as per the partial discharge as one of the factor. Of course it is there, technology wise there, but in a practical sense the partial discharge, how it is managing, it will be taken care and it will be addressed by the team Altanova. And if I say all these papers, then definitely you will be excited, and I hope also, I sincerely request each and everyone to be here. It will be totally interactive session, and very good way, very good speakers are there, eminent speakers are there, and finally, most important is there, it will be concluded, collated, and finally will be taken in the way across the nation. So that is the beauty, if you will be consider those things. Our rapporteur, they will be listening your voices, and finally they will make a kind of concluding paper which will be reaching to each and every person across the country. And at the end I can say the takeaway is that one. To sum up all the discussion for concluding paper, and in this, of course, don't forget, because this is our key point we can say, don't forget, special attraction is there for lucky delegates draw from 5 p.m. to 6 p.m. with attractive gifts. So before to conclude, I say, as far my introduction is concerned, I am P.K. Patnaik, and I am the admin of a Spark group. Right now, that is my introduction. And Spark group basically it has been just going to across the nation, and around 7,000 engineers are there with us. And because of that 7,000 engineers, we are going to get a lot of technology, new concepts. So this particular one is totally suitable for our nation at present. What technology we have, what should be the next. With this, I extend my sincere thanks each and everyone, and wish this particular session should have to go in a promising note, and the doctors sitting over here must have to prescribe also correct kind of things. So thank you all. Namaskar. Again, Jai Jagannath.
Thank you, sir, for sharing all the insights and the overview of the conference. Well, moving on, we have another special guest with us. Ladies and gentlemen, please join me in giving a warm welcome to our another esteemed guest of honor, Mr. Sanjeev Singh, Director of CBI. I would request, sir, to please address the crowd.
Yeah, good morning, everyone. Dignitaries on the dais, off the dais, participants, a warm welcome to all of you. It's my honor and privilege to be here today at International Conference of Emerging Technologies on Electrical System, ETS 2023. It is a pleasure for me to be talking with you today on this very exciting occasion. I am delighted to have opportunity to address such talented gathering of power professionals across the country. ETS, as you know, is providing forum platform to discuss and disseminate the experiences, knowledge of technical know-how, and present status and ongoing trends of electric system among various manufacturers, entrepreneurs, power industry players, and utilities as well. Today's theme is very important: transformer technologies now and next. The event could be a pathway to meet challenges being faced in existing transformer reactors and involve new strategies and techno-economic development in the field of transmission distribution, especially transformers and reactors. I am happy that this platform will cover different topics on transformer like transformer health monitoring, health indexing, arc sensing, better operation of lice analytics, IoTs, transformer fault, failure cause, and preventions. All of you know that sector is witnessing buoyant growth. At the time of independence, we were just 1362 megawatt. Today, it has already crossed 4,050. In March, it was 4,15,400 megawatt, and the plan is to make it 8,000 very shortly. And with greater penetration of renewable energies, the challenge with grid management are going to be difficult day by day. Especially the transformer has to experience many different kind of situations which they have not experienced in such large journeys so far. So the complexity of electricity grid is increasing rapidly. And with non-linear loads like electric vehicle, charging, and other kind of loads will pose more challenges to us. And there is a need to make our grid versatile and intelligent. In this intelligent grid, the transformers also will require to have work smartly, and we need smart, intelligent transformers in future. Some of the areas which we can consider from this house is how do transformer help in voltage sag corrections, compensation. Then how do we isolate harmonics from the system so that transformer is not getting affected? And how quickly we can isolate the faults from the system. These are key areas which I understand that experts here will deliberate and like to address these kind of issues. And I am short of time, so I will not take much of your time. Sector, as you know, is growing very fast, and it is integrated. One country, one grid is posing more challenges to all of us. Earlier, in larger system, a small area was getting affected, but now that it is also risking all India collapse of grid. In case one line, as you know, Vishnath-Cheriali carries 8,000 megawatt. Whether our grid, if a tower collapses in Vishnath-Cheriali transmission line, whether grid can sustain in those conditions, that is a challenge. So, I hope that this platform will prove a revolutionary step in growth of industry and creating consciousness driven by growth orientation stage in emerging technology in electrical system, India and beyond. I wish Electrical Mirror all the best and have a fruitful year ahead. I am confident that this kind of platform will provide strength and spread motivation to write information with accuracy to all. And at the end, I will thank Patnaik ji for wonderful in organizing this kind of conference for the betterment of sector. Thank you all.
Thank you, sir, for enlightening our audience, and it was thought-provoking and inspiring for all of us. Well, now I would like to call on stage a true visionary and our chief guest for today, Mr. A.K. Rajput, the Chief Engineer of CEA. Is he present? No, okay. So he'll be joining us in a short. Can we have a huge round of applause for Mr. Sanjeev, sir? Thank you, sir, for gracing us. Now, as we move towards the end of this beautiful inauguration ceremony, well, now to present the vote of thanks, ladies and gentlemen, I would like to call on stage Mr. Subhash Chandra, sir, from Electrical Mirror. Can we have a huge round of applause for Mr. Subhash Chandra?
Yeah, thank you, Hardeep. Good morning, everyone. First of all, I would like to thank all our guests, speakers, sponsors, and exhibitors for joining us today at ATAS 2023 conference. Today I stand before you on behalf of staff and the board of members to express our heartfelt gratitude and extend our sincere thanks. It is with immense pleasure and deep appreciation that we acknowledge the remarkable contributions of our wonderful speakers and our esteemed sponsors and exhibitors. Without their unwavering support, this conference would not have been possible. Their presence and dedication have been invaluable, and there is no doubt that they played a pivotal role in making this event a resounding success. In addition, a special thanks to Mr. P.K. Patnaik from Spark Group and Mr. A.K. Kaul from ITMA and Dr. Rajesh Arora from Delhi Transco. Their unwavering commitment and dedication have transformed our vision into a reality, ensuring that this conference became a platform for learning, networking, and inspiration. Once again, I express my deepest gratitude to all our esteemed speakers, sponsors, and exhibitors, and all incredible individuals who have contributed to the success of this conference. Thank you all for being a part of this incredible journey.
Information is the power, and we are committed to deliver you all our jam-packed full of information on the latest happenings of the industry. Electrical Mirror, an outlook of the electrical and power equipment industry, is a monthly magazine, which was established in 2011. It has maintained the trust of its readers and clients for 13 years. Electrical Mirror is the highest read electrical and power industry magazine in India, and it enjoys the maximum readership than any other electrical magazine. Electrical Mirror magazine's circulation is 3 lakhs plus over various platforms. The magazine covers the spectrum of trends and technology, policies, project funding, equipment, engineering with an objective of spreading right information. The magazine not only provides you good content but also wins the trust of our intelligent people. Electrical Mirror is reaching various industries and helping them in creating goodwill in the market with its unique media coverage to achieve their goals. It covers multiple topics like power transformer, T&D, testing and measuring instruments, automation gensets, thermal cameras, UPS batteries, electric vehicles, and many more. Electrical Mirror's research-driven features, timely news reports, e-newsletter, business insights and market updates, Indian and international projects, government policies, interviews with top executives of successful companies who share their best practices and views on important issues of industry backed by scrupulous themes and vibrant design. Our mission is to provide the latest and up-to-date information on the happenings in the industry along with technology development, information on new product launch, growth opportunities and emerging trends for the different sectors of the electrical power industry in providing an excellent and accurate information, accurate platform for advertising and branding building.
Till now, I hope we have gathered ample amount of information. Now let's proceed the event and delve into a technical session. For that, I would request Mr. Patnaik to come forward. Mr. Patnaik, sir, please come forward.
Okay. So once again, it is actually, I think, a good morning. So we are 15 minutes, by the way, getting late because for 15 minutes we started late. That's why 15 minutes. We are going to close this inaugural session very quick. And our session number 1 will come. For the session number 1, I'll invite Seshadri sir to.
हेलो
Okay, we are sorry for this technical glitch, extremely sorry. We beg pardon for it because everything should not go in the correct way. If everything goes in correct way, then your presence also not required. The doctors, those who are sitting over here, their presence is not required. Basically, anything happens to be wrong, means all that is sudden, everyone is rushing here. And same thing also happens. Whenever in the electrical sector, anything goes means a different way, definitely everyone to rush over there and to get to know that what exactly the reason. But if I come in this manner, there is a reason of a very small. Electrical engineers are intelligent engineers in the world, you know or not? Because electrical faults are either it will be of open circuit or short circuit. But if I consider about the mechanical engineer in vis-a-vis, then automatically you will be finding mechanical engineer already know it is a gear, वहाँ फंस गया है, वो gear arrangement को संभालने के लिए they may take of around 2-3 hours. But for electrical engineer, the one to know about that open circuit where happens or short circuit where it happens, they will go on developing the vector analysis, waveform, digital, logic, blah, blah, blah. Finally get to know that one screwdriver to bring it and get it connected and circuit is okay. So in this regard, we do not want to put our chief guest, sorry, our chairman to just stand with us. We will be joining, we will be attending. So I request, please just be on the dais. So we'll start the session. So to start the session, I will take up in this way. Yeah. The session will be going in this manner. That will be of technical session number 1. So right now I will ask Mr. Tukaram and all the speakers to come to the dais, like 8 speakers we have. So all these 8 speakers from the session number 1, because I cannot exactly remember one and all. That's why all these 8 speakers, please come to the dais. Dais. Hello, hello. Yeah, session number 1. So our session number 1, Mr. Tukaram K is there? Please. Dr. Hariom Gupta, sir is there. Okay. So Mr. Tanvir Adil. Oh, great. Fine. So Srinivas Sripat sir. Oh, great. Please. Mr. Yogesh Sood. Mr. Yogesh will be joining. Mr. G.K. Gupta, sir is there. Then Mabrun Banerjee. Yeah, please. Manjusha ma'am is there. Okay. And Mr. B.B. Behra. B.B. Behra, I think, is not there. So, Nabrun Banerjee, I think Nabrun Banerjee, please come to the dais. Okay. I think as you are all from this electrical fraternity, so it will be well enough to address you as friends. So all my friends, my dear friends, today all few doctors, they are on the dais and few other doctors are off the dais, but all doctors are of the doctors of electrical system. And to start, I am having some home housekeeping rules. Housekeeping rules basically to go of every engineer will be allowed for 12 minutes right now because it was of 11 minutes. Now we'll be giving up 12 minutes because one author is absent. So we are going to give 12 minutes for to complete their kind of session, and they will be just putting the important slides because a lot of things are there which we will be discussing. So let me to tell you all the speakers, please look at the screen in which you can find some of the few queries I have framed. And these queries are to be asked to the speakers during the time of question answer session, but these will be the secondary query. We do not want to put these queries because just for developing the session and interactive kind of things, we are keeping these queries, but first priority will be given from you. That means the audience will be raising those questions. On the basis of those questions, the speaker will be answering, the author will be answering. If in case there is no questions, then automatically the questions will be coming under what been displayed over here. And in this question you can find one of the question is been of a red mark. The concept of giving that red mark is that that questions definitely has to be answered. I will be requesting, not definitely to answer, we will be requesting the author to answer that question. Other questions will be followed if time permits, posit of time we may not go for, but all these answers, again I am just repeating, once again I am repeating, all these answers you will be getting in the electrical mirror. Right now you may not get, but in the electrical in subsequent monthly publications you will be finding answers of all these things, what possible because of posit of time we will be proceeding for. So I am not taking much time. Right now we will go for the session number 1. Tukaram sir, please come here. Please address your session. Tukaram sir's ka paper.
एक मिनट में देगा मेरे कुछ बोल के देगा So good morning. Yeah. So I'm audible? Yeah. So good morning, honorable dignitaries, esteemed technical experts, distinguished panel members, and respected electrical mirror team. Thanks for giving this opportunity to Tutorial India to present this paper. This is a crucial topic in present days because our material contributing towards net carbon zero emission. And I would like to express heartfelt thanks to organizers to select this paper and give us the opportunity in this forum. In this paper, I would like to explain about how this material is useful in meeting the net carbon zero emissions and potential of this material, the properties of this material, and we will be discussing more about amorphous metals. And this session is not one-sided, it is open-ended. You can ask any questions at any point of time. Thank you. difficult to manage.
No, we don't.
No, no. I think it's laptop will be here. We can control better. It's not possible. Yeah. So before stepping into my presentation, I would like to give attention for 1 minute here. Volume. Volume नहीं होता है. Volume. Video है actually. Can I go there and give the presentation? Because manage.
We release 55 gigatons of greenhouse gases into the air every year. To stop global warming, we have to get our greenhouse gas emissions down to zero. But for every country to immediately shut down all greenhouse gas releasing activities would be an enormous challenge, especially since some countries have built up an economic head start with no restrictions. So instead, we can use an approach called net zero. Net zero means that for every molecule of greenhouse gas we put into the air, we also take one out, making our net emissions zero. Net zero requires us to make big changes today, use less, more efficiently, and even bigger technological changes for the future, like replacing all greenhouse gas emitting activities with clean ones. We'll also have to capture greenhouse gases from the air and store them permanently. And yet, net zero is our best chance for a sustainable future.
I hope this 1 minute video giving enough background why we need to think about net zero emissions and what is the importance. So let us have a look like what is the trend across the global between 1970 to 2018. Are we increasing the greenhouse gas emissions or what is the trend? If you look at the China, it is as a percentage of global, it is 27.8. United States of America, it is 12.7. We are standing at third place, 7.3. So if you look at the trend is increasing actually. It's not decreasing. Some countries are going down or some countries are sustaining. But in India, the trend is increasing. So what we need out of this? So use less, more efficiently, and advanced technology we need to meet the requirements of the global environment or this carbon net zero emission program. So use less could be anything, like for example, plastic, you can use less to contribute towards the sustainable society. Like that, you can use the less material instead of using more material. More efficiently, you can increase the efficiency of the materials and by using the advanced technologies. So amorphous is one kind of technology where we are using the advanced technology in this to produce this material. This is a small background. Considering the time limitation, I am not going into detail. But this is a very sophisticated technology where it is a costing process. The amorphous name is given based on the material structure is because it's not randomly spread over atoms. So that's the reason the name itself is amorphous metal. So we are like, it is from the allied signal to Honeywell to Hitachi, now it's a Protrial. So we have various grades. I'll explain the advantage of the grades now. So if you look at the snapshot of the development area, what we have done in the last 30 years, if you look at that, here I'm not comparing, like the comparison is there with the CRGO, but I'm not degrading any material. I'm just saying there is a better material to reduce the losses. And if you look at our grades here, 26057, it's maybe 30 years back. 2605 HB1 is maybe 15 years back. Now the present, the latest technology is MADC. It's a magnetic domain controlled ferrous-based amorphous material, where in comparison to, for example, if you look at the 20p80, the material at 1.4 Tesla, if it is around 1.5 watts per kg, we can go as low as 0.06 watts per kg. So this is a kind of developments happening, or we are working on towards that kind of material to reduce the losses, to make the transformer size less, and to improve the efficiency in the distribution network. So improvisation material happens over the last 30 years. We have improved, like people used to think like the amorphous material is limited to the 80% lamp factor. It's not like, we have reached to 90%, which is very, very close to 93 or 94% of this 0.17 or 0.18 material, which is coming in the CRG also. So we have also reduced the watts per kg and VA per kg, and people used to think that the material brittleness, we have improved the parameter on the brittleness. Also the noise reduction because of the low losses and low VA per kg, and now the material can be designed at 1.45 Tesla, which was limited to 1.4 Tesla previously. And people used to think that the material has no standard, but we have contributed. We are member of IEC, ASTM as well as in the BIS. So the material standards are available both in the IEC, ASTM and BIS committees also. And you can see the references of the international standards. As I said, like we are more conscious about this material, like what we are doing after the repair, or whether this material is recyclable or not. We have, unlike the other CRGO companies, we have our own recycling plant where you can recycle it from the core to, again, you can manufacture the raw material as it is. PDF. Now I just give example of this amorphous losses, how you, like, what is the difference between the traditional conventional cold rolled grain oriented steel and amorphous metal. The percent of reduction you can see. I have considered the level 2 of the BE present levels. So this is about paper. You can, I think, electrical mirror will publish this paper later. You can, yeah. So if you look at the advantage of S7, like the amorphous metal against CRGO, I have given example. These are most populated ratings in the India. You consider any DISCOM, 16 to 200 kV is the most populated rating. So approximately with the 30 years old R grade can give the reduction of in the node loss approximately 65 to 60 to 70% in comparison to the present ZDKH or PH100. But the new MADC material, if you look at the right side, from the 16 kV to 200 kV, it can go up to 70 or 75%. So this using this MADC material, so this MADC material is a laser script technology we have used. We are trying to align the domains. It's a very critical technology, align to domains in a way what we wanted, like what the CRG guys are doing, to improve the efficiency of the material and to reduce the watt per kg. So we are able to achieve approximately 25% reduction in comparison to our existing SA1. So this is a huge development happened recently, and this material is very, very useful to reduce the losses or to reduce the size of the transformer, to achieve the efficiency what world needs now. So I think I have completed my time. So any question and answers? Across 2 minutes, sir. Sorry. Yeah. Sorry, sir. Sorry. So coming to question and answer. So question and answer will go for at the end. Okay.
So one point is that if any question answer is there, actually we'll be declaring a name. Monica ma'am is there. Just she was addressing also. If anyone is having any kind of questions, those things, you please write on the paper and you just pass it to us. And accordingly, your questions will be taken at first. If no questions are coming, then our questions are already ready. So that we will be taking at the end. Next, we will be asking for Dr. Hariom Gupta. Please come to the dais. I think already loaded. You can directly go with this. Just 1 minute, sir. I am checking. You can just you can go.
Next. Good morning to everybody, and thanks to the organizer for giving an opportunity to present certain findings, study done at IIT Roorkee. I was associated with IIT Roorkee. Presently, so retired long back, about 10 years back, and then served JIIT Noida. So we basically talking about the reliability testing of the binding joints in distribution transformers. So now this is the summary. Need not to explain much on this, but I would like to concentrate on the item, the problems, the cold load pickup problem that is specific to our country. And this problem is like this, that the power goes for half an hour or 1 hour, then it is coming back. In that case, all the geyser or all the ACs get switched on. When all the geyser and ACs get switched on, depending on the season, your transformer is overloaded. When it is overloaded, first is inrush current, and second part is the overloading of the transformer for few minutes. And that causing not many problem, not only overloading, but also the other problem on the terminals. Frequent switching, it means you have more inrush current. And inrush current you can think of many a time, it could be equivalent to a short circuit. So let us say you are having 20 inrush current, you can expect 1 or 2 equivalent to a short circuit. Then you have got a hot spot formation, and hot spot formation could be at the terminals, could be at the joints. So these are the main area where we will be concentrating on this particular lecture. Okay. If you think of the failures which is analyzed in a study in 2019 reported, and we are finding insulation, winding, bushing and others. There is a lot of contusion of joints and hot spots. Now we will talking of the joints, connections and terminations, and estimated around 50% failures are because of the termination and joints. Okay. And that is, this problem is more severe when we are having joints or termination with aluminum. Why it is there? It is because of the poor creep behavior that we are discussing over here, and it may create, it is going to increase the contact resistance, that is going to create the hot spot, and that hot spot going to damage the transformer. Now what it does is specific to the joints, from termination to joints, that oxidation will be there. When aluminum gets oxidized, in that particular case, there will be layer of Al2O3. And this layer is hard. and no doubt it is semiconductor type of layer, and therefore your conductivity become poor and may cause more contact resistance. I can give a simple example why you are not using aluminum wire for house wiring. Why we stop? Reason is the creepage, no other reason. Now, overheating, no doubt, and local carbonization, increase creep rate of binding due to higher temperature and if there is stress. Okay, so that is going to create the problem. We are discussing studies, joints that we are using mostly in the distribution transformer, crimping, and Western Union spice. This, if joint generates sparking, contact resistance increase, it means hot spot and failure of the transformer core equipment. Okay. So what we require it, that a joint is there, then the current, whatever it is, it must pass smoothly without causing much resistance. And it should have a longer life. Now, what are the forces they are coming on this equipment? Short circuits, yes, cold load pickup problem that I discussed, overloading, inrush current, including switching on, and I say certain inrush current could be equivalent to a short circuit. Then you have got a radial, axial, and compression forces in overloading or during short circuit or inrush current. Now you think of this, is important to note that creep temperature, creep limit temperature for copper it is 135, for aluminum it is only 7 degrees centigrade. 7 degrees centigrade means its elongation will be there even at the room temperature. What to talk about the higher temperature. And lead, if you are using lead is used in the solder, okay, that is also. Sometimes you have a cold soldering problem. It may not be cold soldering. It may be certain forces are coming on the soldering, it gets open automatically. Then steel has got to 70, so this is the reason for, then other reason is the fatigue. Okay, if fatigue is appearing, if there is stress is coming on the wire or on the stiff. And in this case, stress, if it is more than the endurance limit of the material, and which is about 40% of the tensile strength. In case of aluminum, it is only 33 MPa. Now, these are the joints that is appearing in the winding. That is joints within the coil, could be there, if there is material short, then we just connect, so that is joint. And then connecting coil to coil, there is joints. Then you are making delta forming or star forming, they are the joints, then you are terminating. So these are the joints. Now here what we studied is that WUS joint, Western Union joint, without solder, just you twist the wire, normally used in the binding, it is short, you take another wire, you just twist, okay, and proceed. Then you introduce them with soldering, that you can do the solder over here, and then you can use the crimp, which is prescribed by many utilities. So you have the two crimp points, or you can have the 3 crimp points. Okay. Butt joints, which is really used in distribution transformer. Lab joints may be using LTs, not use ST. Now, type of transformer, we have described the joint over here, aluminum wound, copper wound. So you have the joints within the coil and series coiling, coil to coil joining. That is aluminum, in case aluminum to aluminum joint, in case copper, it is a copper to copper joint. Joints between the binding and leads of the delta formation, that is aluminum to aluminum. Sometimes it is prescribed to terminate with the copper, then you have aluminum and copper joint. And in case of copper, you have copper to copper joint. Now, these are the characteristic of binding joints, that if you take the parameter, 4 joints are over here, WUS, crimp, butt and lap joints. So WUS, it is simple, quick, very easy, all right. Take less space, okay. It can be used up to a diameter of 2.5 mm, and then location of within the coil, mostly it is used. In case of the crimp joint, yes, it is also very simple. Only you require very specific equipment for the purpose. Okay. So you can read. There are a few more slides in the in this. It is already PPT is already with them. You can see that. Okay. Then you can testing is done within the lab, and it is observed that our aluminum joints are very pure. Also, we have investigated in case of the field data collected about seen about 900 failed ST coils, and we have the observations 70% failure is in the middle, and that is indicative of creep problem in aluminum binding. So with this, we will say, I also said earlier that aluminum to aluminum joints are poor and could be the reason of failures. So thank you very much. You can go through the paper and you can always contact with me if you have any question. Thank you very much.
Show kind attention, all the authors, speakers, and also experts. Please just a kind attention to me. You have been added in the group ETES 2023 technical paper group, TP group. Please go through that. There is one instruction to you. Kind instruction is there. We have kept our query-based session slides. We have kept there, and there also your queries are there. So in advance, you just go through those queries, and we do not need actually our gathering to be getting the queries on extempore base. Because queries are in advance, we have kept in that group. You go through those queries, prepared also your answer, how it will be also focused kind of answer. Because what happens in many of the conferences we have seen, whenever queries to come from the public or from the dais, sometimes also to manage the kind of time, they used to give some extempore answer. So that's why we have given those answer in your query-based session number 1, session number 2, session number 3. So all those sessions, already queries are there, you prepare. And one of the query is of a red mark. So that red mark is quite relevant. That's why that has to be answered. If in case others could not be, then automatically it will be published in the corresponding electrical mirror. I'm sorry, I'm just in between, just go for. Here also is there. Please go through your mobile in that group, and accordingly you prepare your answers. So I think next author, please come to the dais, and you proceed. Mr. Tanvil Adil. Tanvil Adil. Otherwise, you take this. Actually, this is next is. You have already. You just proceed. Yeah. Next, he will come.
Good morning. My name is Srinivas Shripad. I represent a company, Shripad Tech Innovation. Our today's topic is a better connectivity in transformers, whether it's a distribution or power transformer. We have seen the terminal connections have to be a very better technologies, and as conference says, then, now and next. This is one of the most ignored part, and we would like to touch upon with our energy efficient connection systems as well as the applicable technologies which we have brought in our products. So why reliable connector is required? Just now in earlier presentation we have seen almost 50% of failures are due to connections, and that too main you want to connect aluminum and copper things. So millions of transformers are under service and new transformers are coming. Revenue losses due to frequent failures are there, which is one of the major concern as far as AT&C losses are concerned. 24/7 power, quality power is one of the objective and which is requirement to have a consistent growth in the industry. High ampacity energy efficient connections are required, which is definitely to take care of the overload conditions. Connectors are weak links of electrical network and cannot be ignored if you want to have a long-term reliability. Overheating at connections is one of the major issue, and that needs to be addressed by putting the right connections in place so that accident should not happen. A safety can be at most very difficult level if you don't use the right connections. How? I'll just take one video here. Sound.
भैया जल्दी से बंद कर लो, यहाँ आग लग गई है.
How the current utilities are handling. I'm not going to take a name, but this is one of the worst conditions, and we are facing this kind of issues throughout India. One of the main reasons by using conventional connectors. This is unsafe condition. If transformer is getting burned, that means definitely there is a revenue losses. And to address this, one of the reasons to have a better energy efficient connections. These are the existing connection methods which are available. So the video which you have seen, it has having a crimp connection and binding over it. So there are other type of connections are also there. So we call it as a conventional connectors, and we would like to impress upon the new technologies which are available right now. So current practices, some photos, multiple cables handling in the industry, binding, crimp plugs, overheating issues. Actual photo, you can see there is a thermal photo, more than 150 degrees centigrade temperature in distribution transformer. One more photo of power transformer, you can see a temperature is more than 100 degrees centigrade. So these conditions are once attained, it cannot be restored back. It will go once again further deteriorating. Pain areas are mainly hotspot, water ingress, dust, safety issues. A deterioration of oil seals can lead to oil leakages. Why oil seals are deteriorating? Because of heating at the metal parts. Connector quality and its selection, installation tool are one of the constraint there. Issues associated with bimetallic connection. It needs to be addressed properly. And finally, awareness of technology. People are not aware that new technology connectors are there in the market. Root cause, overloading, of course, there is there. We need to stay with it by giving the right connections. Connector design quality, advanced manufacturing technologies has to be there. Wrong practices to be addressed. Loose connections. We'll show you the small video wherein a universal connector, how it can take all the things. And finally, a training has to be given to the user while addressing or while introducing the new connectors. Components. Bushing has a copper and brass. Connectors are brass, copper and bimetallic. And cables are copper and aluminum. Mainly in utility, we use aluminum outside. So solution is a Tusker terminal. A different kind of connection based on applications can be given here. You name an application, we can able to design whatever may be the range, whatever may be the application, whatever may be the ampacity. A proven system can be given by us. Before versus after. You can see There is a overloading also there and hotspot. And then we have replaced with a small, smart, compact connectors. Some of the snapshots of our connectors. You can see these connectors at our stall also. This is the value proposition. When we say value proposition, I square R losses, if you can minimize that by using a right connection, then definitely there is a drastic reduction in contact resistances. That will definitely keep your connections cooler. And if I put ROI, definitely it is less than 1 year. We have done this case study with MP board. MPMK VVCL is the utility. It has been proven. So some of the benefits, like this is a truly universal connector. You will not going to have any overheating, that's guarantee. And low loss power saving is one of the concepts which we are moving ahead. Enhancement of transformers and cables life. If you don't have overheating, I think definitely efficiency and efficacy of the equipments and cables will go up. And finally, revenue will increase if there is no failures and no maintenance, no shutdowns. You can think transformers working where with a fit and forget kind of a technologies. So these all benefits we are going to get with a reduction in AT&C loss reductions. A small video. This shows how this is universal. These connectors are. This is one of the unique designs. It can accommodate copper, aluminum, and any type of conductor, any shape. Proven shear bolted technology, no crimping required, no binding, nothing. For smaller cables, you need to use the inserts, and it can accommodate small cables also with the same connector. A maximum range 95 to 300, that means total 6 cable sizes can be covered in a single connector. Threaded rings, this is one of the examples. So M20 ring, same connector can be clamped over this. A connection is done. This is removable connection. For a different sizes, the same connector can be used. Only ring has to be replaced. A plain stud, simple installation. If you want to use a smaller plain ring, a plain stud, a smaller ring has to be used. So total, almost 5 to 6 studs and 5 to 6 cable sizes can be covered here with a single connector. This is truly universal. Copper, aluminum, any type of connectors, conductors can be taken care. Our credentials, it has been proven majority of utilities. This is gaining popularity. Please do get aware yourself, and this can be used at any point of time in any type of connections. So final conclusion is, the connectors are definitely a weak link, and it needs to be addressed to get a proper health of a complete distribution network. Nonetheless, technical loss reduction, enhancement of equipment and cables performance, reduction in O&M cost, frequent failures of the equipment, mainly transformers, which is the heart of a system. A retrofittable solution has to be there. This is a retrofittable solution. We need not ask you anything. And finally, payback period.
Sripadji, actually, we are a bit tired.
Okay, thank you.
Okay. So it is a really very good kind of paper, and we can ask him as actually the surgery doctor.
Yeah.
Yes or no?
Thanks a lot.
The surgeon actually, you are the, surgery doctor. Whenever anything happens, you have shown also. Before surgery, how like it looks, and after surgery, how it looks, and what is the benefit out of it.
Normally, body also shows that we are getting sick. So normally we do overeating check.
Yes.
Same thing it is with transformers also.
Yeah. So Tanvir, you can take this one.
Good morning, everyone. I'm Tanveer Adil. I'm from Tata Power Delhi Distribution Limited. What I'll be speaking about is cost-effective and quality control during in-house repairing and the various strategies that we've put in to come to the point that we are in terms of distribution transformer failure. So a brief about Tata Power Delhi. It's a joint venture between Tata Power Mumbai and Delhi government. It's 49% distribution. This is the journey that I'll be talking about, where when at inception in 2002, the transformer failure stood at about 11%. And today it has been below 1% levels for the past 7 or 8 years. So this is a journey in itself, and I'll be giving a brief snapshot about how we have achieved this. Another testimony where the age of transformers at failure stood somewhere in the band of 6 to 10 years. Roughly half of our transformers were failing at this stage, and currently we've caused an age shift to the 16 to 20 and the 21 to 24 years age band. So how we've achieved this, I'll be giving a brief on this. So before going into the journey of what are the methods that we've taken, what are the steps that we've taken, we need to understand what was causing our failures. And like Patnaik Sahab was saying, giving the transformer its graceful death, understanding how transformers are failing, what is the cause of these failures, and how we can create the remedial actions for this. So in our case, primarily interturn insulation failure and water ingress has been the general norm. And this is the norm across the industry as such. When we assessed these transformers further deeply, we tried to, we saw that these transformers were having a significant amount of less oil level. Pressure test results on these failed transformers revealed that they were not withstanding those pressures. That means that there's a direct reason for water ingress and interaction of other atmospheric components with the transformer, and the silica gel breather conditions at site have not been very adequate. The methodology of assessing our DT failure, whenever a transformer fails, we cause a trigger of preliminary report from the area concerned to understand what was the condition at failure, what was the protection status, what was the kind of load that it was feeding, what was the loading condition during failure. Then this transformer is received at workshop. We understand the detailed analysis of how was the condition at the time of failure. We check for the appearance, if there are any dents, there are any external damages. Electrical parameters, we are checking the insulation resistance. We are doing the pressure test of the DT to understand whether it was completely sealed and working as it ought to be at site, or there have been interactions from the atmospheric air and the transformer, apart from the natural course of breathing that the transformer has to undergo. Further investigation of the transformer, we are checking the oil condition, we are doing the oil BDV of the transformer, the oil quantity, whether the quantity was apt, discharge, and the rust and metal tracks to assess whether there have been moisture ingress in the transformer. Further disassembling the winding and checking what has been the cause of failure. Disassembling the bushings to see what was the extent of moisture penetration in the transformer. And a detailed report is prepared for each of the transformers, and that is shared to the management with corrective actions on such kind of failures. I'll be sharing a few case studies and the depths that we go to understand the failures that are caused in the field. So this is one transformer. When we disassembled it, we saw there was water ingress in the primary bushings and there was short circuit between the windings. So primarily, winding insulation failure. What caused the winding insulation failure? It was water ingress. What led to the water ingress? It was airtight failures at HV bushings, which was caused by poor quality. There were three reasons for this: poor quality of gasket, poor cable terminations, and loose nuts. Poor quality of gasket is a material defect. Poor cable terminations is a maintenance defect or installation defect. And loose nuts is the repairing or maintenance defects. Another case study, a similar kind. Winding insulation failure, water ingress, airtight failure, conservator cap and sockets. Poor quality of welding. Loose cap, improper threading and poor quality of the washers. So workmanship defect, maintenance defect, material defect and another material defect. And another single phase transformer, water intrusion from secondary bushings, short circuit of winding turns and damage to the secondary bushings. So speaking about a few steps that we've taken in line with these results that we've got from our transformer failure studies. The first primary understanding was that when the pressure test is failing, there is a mismanagement of torque at the transformers, be it at the manufacturer level, be it at the maintenance level, be it at the repairer's level. There is something that we are not detecting. So we understood this and we devised a uniform torque implementation for all the threaded, or for all the nut bolted joints or the gasketed joints, and preparation of a uniform torque chart as per the conditions, torque implementation by the team after repairing at our in-house workshop, and implementation of torque measurement becoming a part of the GTP such that all the manufacturers are now obliged to give their respective torques of each section, be it the top cover, be it the conservator cap, and what are the associated torques with which it is supposed to be tightened. Air pressure test kit at site. So when we are doing a maintenance at site, what is the best case validation that we've done everything correctly and thoroughly? We've probably done our cleaning of all the bushings, we've done the oil filling and everything. But what is the validation that we've done everything correctly and now that can be left for operation for another 2 years, 3 years, 5 years, 10 years untouched? Probably none. Unless we are doing a pressure test to ascertain that the transformer currently running at site is, so just 2 more slides, 2, 3 more slides. Currently is in its intended form. So the validation is through the air pressure testing at site. These are a few photographs. I'll just skip this. The initiative, just a snapshot. Torque tightening made a part of the quality assurance plan from the manufacturer's end. Using of ester oil transformers for overloading conditions as it has heat dissipation capacities. In-house oil lab being developed so that it assists our maintenance strategy. I think, yeah, that's all. Thank you.
I have just a small...
yeah, sure, sir.
It is generally said in the distribution fraternity, the people who are handling the distribution transformers, that lesser is the communication between the inside and outside of the transformer. Lesser is your failure and lesser is the deterioration.
Definitely, sir.
एक पुरानी कहावत है ये जो चलती है. The thing is that many times while tightening, you mentioned about the torque. Many times when we are tightening the transformer, the difference in the torque that is applied at a different bolt also gives rise to leakage.
Yes, yes.
So how do you address this?
Definitely, sir. And very well said, sir, that while the intention is to tighten it, the more you tighten it, the better. What happens is that the uneven tightening causes the uneven placement of the gaskets, which further causes the leakage. Yes. So essentially, more tightening is not the way. Rather, apt tightening to the torque is the way. That's number one. Number two is the manner in which we are tightening the torques. So if what we are doing is we are starting from one nut and tightening it, let's say if it's 30 Newton meter, first, second, third, fourth, fifth, we've already caused an unbalance in the tightening at the first level, so that when we are moving to the other end, it's already uneven. There's not much what we can do. The best way to do it is going in a diagonal fashion. So 1, 2, 3, 4, 5, 6, 7, 8. So such that the entire sphere is completed. Welcome, sir.
Yeah, very good morning, everyone. My name is Yogesh Sood, and I'll be briefly touching on moisture in the transformers and how online transformer dry-out systems can be a future for unattended substations with IEC 61850 and IRP integration. This slide is generally the total moisture content, how it is distributed in the transformer. Here you can see paper is approximately 10% of the total transformer. 90% is liquid insulation, that is oil. Okay, here in this slide you can see 90% is oil and 10% is paper, and how this water distribution is in this liquid and solid insulation is only 1% is the moisture in the oil and rest 99% is in the paper. So this is further seen from the manufacturing and from the tensile strength of the transformer paper that we call as DP value, that is degree of polymerization. And generally, we test the moisture in the lab by the BDV test or ppm value test. But the latest thing is RS value, which we call relative saturation of moisture in oil. Here you can see this relative saturation is actually the amount of moisture which is measured as per the temperature during that specific time. So if I talk of percentage RS value, here is with one example. At 60 degree, if it is 11 ppm, then at 11 ppm and 60 degree, the maximum solubility which can hold the moisture in the oil is 242 ppm, and therefore the RS value is 4.5%. And this RS value actually correlates with the insulation moisture and the total healthiness of the transformer also. If we keep it throughout the life less than 5% RS, that means we are maintaining a very good life of a transformer. And this RS is directly related to BDV. If we have high RS, that means low BDV. If we have low RS value, that means we are having high BDV. And soon this RS sensor are there in the moisture drying systems. But soon this BDV also can be displayed online, and it can be seen on our hands that what is the BD of any transformer. Now, what are the sources from where this moisture can get inside? Here you can see different locations, from gaskets, from other plugs. These are the sources from where moisture can generally get inside. But other than this, the oxidation due to paper deterioration, that itself is a source of moisture generation within the transformer. So, but that happens with some aging of a transformer, that is minimum after 10 years of life of a transformer. So this is how we can, from here we can see that how moisture ingress can take place and how these things has to be controlled actually. Now, online dry out systems, what I'm going to explain you is that why is this need of a online transformer dry out system. Here if you see in this graph, here is the percentage moisture per dry weight of insulation on the x-axis, and here is the life expectancy of a transformer. If we keep it less than 1% throughout the life, which is not very possible, but between 1.5 2% here, then definitely we'll get a very good life of a transformer. Okay, now it is explained here in such a way that when a new transformer is there, generally the DP value is 1200, which means the tensile strength is approximately 17,000 PSI. And after this is manufactured in the transformer unit, manufacturing unit, this generally comes out to be around 14,200 PSI, which is 1000 DP. And this 1000 DP is taken as a standard during the whole life of a transformer. And once this DP comes to 200 DP, that is approximately 75% loss of the tensile strength of the paper, that comes to 3400 PSI, then we can say this transformer is not at all reliable to be used in the circuit. So it is very dangerous to use this. So here it is correlated that how this percentage moisture can reduce the DP, and if this goes to 4.5%, then there is a chance that at 90 degrees centigrade, there can be a chance of flashover. This can be explained by these sorption curves also. Actually, this has to be very carefully, this curve is visible, I think little bit. Here I just wanted to explain you that wrong assessments can happen if we don't take care of the temperature. Here in this chart, here is the percentage moisture and here is the ppm level. Here if you see, this is 76 ppm at 70 degrees. And at 30 degrees, this is only 13 ppm, and both are giving 3.9% moisture. This both had 13 ppm at 30 degrees and 76 ppm at 70 degrees are giving a 3.9% moisture value. This is very important that you take care of moisture, temperature also when you are assessing it, and this is taken care with the total solubility level, which is there, charts are there, that at what degree temperature, what will be the solubility of the moisture which can withstand in the oil. So, for assessing it, IEEE did one experiment in which they put two press boards, one with 0.5% moisture and one with 4.5% moisture. I'll just complete in 1 minute, sir. So here it is seen that the moisture from lower at 80 degrees, it was transferred to the other press board, which gives this faith and this trust that if you use some system which can remove the moisture from the oil through insulation. So for that reason, such system was used, which is used as a kidney loop system. It is placed from the lower bottom of the transformer oil, and when the moisture is there in the paper at loaded condition, it will be removed from the oil, and the total ppm values inlet and outlet can also be seen. Then a lot of case studies were done, insulation 10 delta value, IRPI values before and after, to ascertain that how it is being removed. So I can take questions and then I can, thank you so much.
Yeah, actually question answer session will be after completion of all. And one more thing, actually all the esteemed delegates sitting over here, don't worry, each and every paper, in paper wise will be also published in the electrical mirror magazine, so that you can get all those papers in detail. So don't feel that we are not giving justice, because many number of distinguished authors are there, so you must have to give them the chance. That's why we are making up all cuts out sometimes. So right now next we can ask for Mr. G.K. Gupta sir, please. All those questions you get ready and just put it with us, so that at the session we will ask those questions.
I need to use it. Hello, can you hear me? Yeah. I hope you have combined part 1 and part 2 both. Part 2, both. First show part 1. So in the meantime, when the presentation is being loaded, I just share with you some of the knowledge in the field which we have got. Now, as my predecessor says, a transformer has many problems, and one of the bigger problem is the moisture. And out of moisture, it can be because of two reasons. Previously, my predecessor has said about the loose connections, loose boards, loose nuts, gasket failure. So it's an external ingress of water. Other is that, transformer basically consists of the cellulose, insulation cellulose. And as my predecessor has said, that TP value is 1200. 1200 is nothing but the joints between the carbon, hydrogen, and oxygen. As the time grows, as the temperature grows, these joints start disintegrating. And when this is disintegrate, it becomes HNO. So it becomes water. So it has been, now let's go one by one. Can you go to next slide? Where? Where is the? Which one is to be done? Can you help me? For what is this? Okay. So as the predecessor already said, that only 1% is in oil and 99% remains in the solid insulation. And unfortunately, at site, all testing is being done on this 1%. Whether we do ppm, whether we do anything, we are only trying to, and from this 1%, we are trying to estimate what could be the moisture. Now, just for example, what I am talking is more valid for power transformer. Now, power transformer, 315 MVA, 400 kV, will have around 14 ton of insulation. Now, 14 ton insulation, 1% means 140 liters of water. So, in this case, all our tests, all our methods, all our site procedures are only for 1%. There is nothing for 99%. Now, there is, and they tell indicate indirectly the health of 99%. Now, there is a direct method by which we can do this, which is called domain frequency response analysis, which takes the direct measurement of the moisture in the solid insulation. And that we must do. And it becomes must after 10 years. As my predecessor already said, that the rate of water increases. And if you are not able to open the transformer, if you are not able to do DP test, then please do the oil for iron test, which is a direct correlation with DP and also with the life of transformer. So, can you help me? It is not moving. Sorry. So, when we get insulation in the factory, it is around 6 to 8% of water insulation, water content. And when we dry in the factory, it becomes less than 1%. But when it goes to service, it keep on increasing. Various causes, external or internal, but rate increases 1 to 2%. Up to 2% is a tolerable limit we can afford. But 2 to 3% is yellow card. You are in a danger zone. And more than 3% is wet. You are critical. You are in ICU. Transformer can fail. Now, when we say 3% or 2%, they are the average value of moisture. They are not the peak value of moisture. So 2%, somewhere it can be 5% also, somewhere it can be 0% also. So there are pretty chances that the weakest point will fail and we'll know what has happened. So now this is some of the reasons, decomposition which I have explained. And if everything goes right, no external, even then the study shows it will, or the water will generate around 0.2% every year. So it means for 10 years, for 15 years, everything is right, you will have more than 2% water. And then you are in a critical zone. So now issue comes. So this is one of the very large transformer. This is a DC voltage. This test has been done, and it has a 3.8% water. Well maintained, HVDC, 500 MVA, 800 kV. This is the state of this transformer. Now, point is this: you have found the transformer. There is a water. What to do? Whole issue is this: site people are not. They know what is the transformer. They know what is the moisture, but fact remains what to do. So now they can hot oil circulation, nitrogen purging, LFH. So they start doing this. Now let's say if you have 315 MV transformer with 3% moisture content, means 400 liters. Now if I say, this interesting study has been done. So very interesting study has been done. If you use molecule sieve and all those things, you are only removing 0.1 liter water per day from the system. You have 400 liters, you are removing 0.1. So you can go for ages. And then if you go for higher methods like oil filtration, vacuum and all these kind, you are able to remove only 1 liter per day. So 400 liter, one day, 400 दिन लगेगा. पानी पूरा नहीं निकालना है, but whatever we have to do, it will taking long time. Even if you go for LFH, which is the latest method, you can only remove 10 liters. Now the ideal method which has come, so other method that you have to send this transformer back to factory. But 315 MVA का transformer, factory जाने का time 6 महीना, factory से आने का time 6 महीना, और factory में 6 महीना. So it is a huge amount of cost and huge amount of energy lost. Okay. So what we have done, that we are bringing the factory system to the site. Factory BPT is coming to site, and from 3%, we can reduce this moisture content to less than 1%. And this happens in less than 3 weeks' time. So transformer is back to service in less than 3 weeks and brandly new. And other thing which happens, because of moisture, because of slackening moisture and removal of moisture, slackening happen of the insulation. So we are also do service transformer. We remove the gaskets, we tighten the coils, so transformer becomes as new. So more details, okay, my time is over, but more details we can share in this thing. And this will make a transformer as good as done in the factory without going to the factory. That is all which I wanted to say. Thank you very much.
Thank you, sir. Thank you, sir. It is actually quite an insight. As I told you, during my address also I was talking about. It is doctors are there also to bring. Doctors are basically to call for, but right now, patients is there. Doctors will be reaching to present. So next comes Navrun Banerjee, sir. Please. And he is also going to give another kind of new setup.
Best results were in a 500 MV transformer, 0.3%, 0.45%, from 3%.
distinguished guests, am I audible? Yeah. So I am Nabarun Banerjee, and I am basically going to talk about water mist systems, and I am coming from a company called Vimal Fire, which is from Mumbai. So our earlier presenters have presented on moisture ingress, problems regarding that, and I'm going to talk to you about charging a lot of water on a transformer. So it may sound a little bit contrary to whatever we are hearing, but we have some context on that. So let me bring to you, that is the technology that I'm going to talk to you about today is a low pressure water mist technology, which is going to be used as an alternate to the technology that is already in vogue for protection of transformers from fire. So the current codal references that we have for protection of transformers from fire is IS 15325. Now this particular codal reference is in the Indian context, and its US context will be the NFPA 15. Now both of these codal references talk about using a spray system. So in my discussion, two terms will be coming. One will be a spray and one will be a mist. So what I am going to propose to you is a mist as against the spray. So when we talk to you about spray, what is a water spray system? So there are two kinds of water spray systems which you have already heard about, because this is quite an old technology. And water spray systems comprise basically of two systems, which is a high velocity water spray system and a medium velocity water spray system. Both of these systems are used in, already used for protection of transformers in different locations. Now, in these cases, what happens is that if we see that why there are two systems, then if we go to the details of IS 15325, we will find that medium velocity water spray systems are being proposed for the fires which are happening on transformers which are having insulating oils whose flash points are less than 65 degrees Celsius. And HVWS systems, that is the high velocity water spray systems, are normally being proposed for the transformers where you have the insulating oil whose flash points are above 65 degrees Celsius temperature. Why is this happening? I'll come to you later. But against this, what we have found, I have moved a few slides before. So what we have found is that water generally concerned is not at all a good medium to fight fire on oil. It is one of the best mediums to fight fire, but when there is burning hydrocarbon oil, what happens is that the burning hydrocarbon oil, it floats on the water. Even the oil which is not burning on the same premise floats on the water, and it contaminates a lot of area on which the water flows. So the basic idea has been to reduce the amount of water. Now in reducing the amount of water, the technology that has worked over here is sort of an atomization. So in MVWS and HVWS, the technology of dispensation of the water through the nozzle is increasing the pressure in the pipe and thereby coarsely breaking the water into droplets which are in the area of diameters of, say, 1 mm. What in case of the water mist systems, what we are doing is we are within a pressure range of 3 to 5 bars. We are keeping the approximately 90% of the spray that we are generating. This spray will contain of water droplets which will have diameters less than 100 microns. Some, 10% will be above 100 microns, but not exceeding 150 microns. So when I say this, what happens is that the droplets of the water are so small that the same volume of water gives a much larger area of exposure of the water to the fire. So thereby what happens is that the water very quickly can absorb the heat from the fire. So the cooling effect is one of the major things why the water mist system is gradually getting accepted, not only for the present case that we are talking about, but in in all the places where water has been used and the hazard has been classified to be high or medium. So just to elaborate on the point, 1 liter of water can cover 16 square meter of surface area. So let us now see what this low pressure water mist system brings to you. So in case of transformers, especially transformers which are located in remote areas, what we find is that if you are using a water spray system of any kind, you approximately require 165 KL to more than that kind of water, which normally having a reservoir of that kind at every place where you are having a transformer becomes difficult. Also, you have to have larger pumps. In case of the water mist, as because the water required will be 20 times or even lesser than that, I could have put numbers to that, but the time is very limited. So we can basically achieve protection of a transformer using cylinders, and these cylinders will be charged cylinders with nitrogen pressurization inside. So as soon as there is going to be a fire, what will happen is that there will be a detection system which is normally going to be there in the place of HVWS systems also. The same system gives a signal to a panel that we will be having, and that panel will basically open a solenoid valve, and that solenoid valve will let the water go in, and there are specialized specialized nozzles which will generate the water mist by the method of atomization. Now, so here I would just like to make a small point, that is the water mist that I'm talking about. This water mist attacks the fire which is happening on the external surface of the transformers, not on the inside. So Vimal Fire, the company that I come from, that also has the nitrogen injection systems which we usually propose for the fires that are happening inside the transformers. I will, before going anywhere, let me show you this video. This is basically a video in which we are testing the efficacy of the water mist system. This is our own R&D facility in Baroda. So I would just like you to see that the fire is reaching its blaze state, and this is actually transformer oil which is burning. This is where the water mist has started. Now please keep in mind, this is water which is fighting oil fire. It's gone. So it is actually that fast. So let me bring you to one slide. This is actually a transformer being burnt, and on that water is being charged. The same system that I'm going to show you. So you can see that, the water that is coming in, this is hardly a 3/4 inch dia pipe. So the water requirement is very, very less. So let me begin this video. This is an actual video.
What is the rating of this transformer?
That I need to check, sir. This is something, we have got from our OEMs here.
It's a distribution transformer or a power transformer?
Both kinds. So what I wanted to emphasize over here is that in the current scenario, the codal requirements talk about a 60-minute discharge of the water spray at a very high water demand capacity. In this case, as you can see, a 1 minute to 2 minute discharge is enough to not only suppress or cool, but to kill the fire. So that will be all. I think my time is up. So I leave it there. Thank you so much.
Thank you. Actually, now we are going to the last session, and always everything must have to pay due respect, because ma'am is coming. She is the first to speak and read out the paper. I mean, all aware of opposite sex. Right now, ma'am will be there. So that's why I just give due respect and asking for to please just address the house. DG. We are listening about the utilities and manufacturer. Right now, the testing group, those are there the way to go and check everyone. So the testing department right now is there on the dais. After this, actually, we'll be having the question answer session. So those who have already taken some few questions, please hand over to us. So accordingly, we'll be addressing first. Thereafter, our questions will be read out. So volunteers from Electrical Mirror, you please just go into the house and collect the questions.
A very good afternoon to all of you, one and all present here, all the eminent doctors of transformers. My name is Manjusha Nambiar and I am representing ERDA. And today's technical paper is based on transformer health monitoring using dissolved gas analysis. The main contents involves transformer oil, faults in transformer, mechanism of gas formation, dissolved gas analysis, different fault identification methods, and case study. Transformer, as we all know, one of the most important and expensive equipment in power transmission and distribution system, and safe operation of transformer is very important for the uninterrupted power supply. The main components of transformer are core, windings, and transformer oil, which is the liquid dielectric. The main functions of transformer oil, as we know, is as a liquid insulator. The transformer oil circulates throughout all parts of the transformer and fills the space between the solid insulation layers. And it circulates, since it circulates throughout all parts, it absorbs the heat from the core and winding and transmits it to the outer surface of the transformer. And apart from this function, it also carries as function as an information carrier. That is, from the analysis of the oil of a working transformer on regular basis, different properties indicates the condition, actual health condition of the transformer. As we know, for decades, petroleum-based mineral insulating oil is getting used as the transformer oil, which is again categorized as paraffinic, naphthenic, or aromatic oil. But nowadays, because of depleting petroleum resources and also environmental concerns, ester-based oils such as natural ester oil and synthetic ester oil is also getting used. The different types of faults within the transformer: high energy electrical discharges, low energy partial discharges, and also thermal faults. Transformer conditions such as overload, excessive conductor resistance, and magnetic flux leakage. These faults cause decomposition of the solid or the liquid dielectrics and produces gases, which can be detected through DGA. The main mechanism for the gas formation is as we know, mineral insulating oil is a long chain hydrocarbon containing carbon-hydrogen chain, and the scission of some of the CC bonds or CH bonds causes the formation of the gases. The low energy faults, such as partial discharges, favor the scission of CH bonds and formation of gases such as methane, and more energy or higher temperature causes the formation of CC bonds and formation of higher fault indicating gases such as ethylene, acetylene, etc. Then the analysis of these gases is known as dissolved gas analysis, which is one of the most widely used and important method for the transformer health monitoring. The different gases analyzed are hydrogen, hydrocarbons, carbon oxide, and also atmospheric gases. Decomposition of oil produces these hydrocarbons, whereas the decomposition of cellulosic paper produces carbon oxides. This is the overall DGA process where the transformer oil is the origin of the gases and the cause of gas generation is different faults, and these are the different gases which are getting generated. And by using gas chromatography, we can find out the gases using TCD or FID detectors. Then again columns and methanizer is there for the detection purpose. This is a headspace GC which contains a headspace sampler, injection loop, transfer lines, columns and detectors. Then the columns which are generally getting used are molecular sieve 5A or carboxyl plot column. TCD detects hydrogen, oxygen, nitrogen, and FID detects the hydrocarbons. And the purpose of this methanator is to convert carbon oxides to methane and to get it detected. Catalytic converter containing powdered nickel is installed between TCD and FID for the conversion of these carbon oxides to methane. This is the overall process. Sampling is most important in the case of dissolved gas analysis. Then after sampling, extraction of the dissolved gases from the oil, identification of different gases, and also the interpretation of faults is one of the as much important as that of the detection of the gases. These are different fault identification methods. Key gas method, which involves the actual concentration of the gases, whereas in the case of Rogers ratio method or IEC 60599 gas ratio method or Donberg's ratio method, the different ratios are getting used and the different types of faults are as indicated. Also, one of the method is the dual triangle method, where the different faults are defined within the triangle. Then this is the IEC ratio method and also the graphical method, which is as per the standards. Now coming to the case study, this is of a 15 MVA 66 by 11 kV transformer, and the sample that we received was after Bucos tripping of the transformer, and this is the actual key gas data of the transformer. And after applying this data into all these different methods of interpretation, first the different ratios are calculated, and after coming that different interpretation methods, first the Donberg's method, Rogers method, IEC method, we can see that in this particular case, all the different methods shows the same fault indication, that is arcing or high energy electrical discharges. This is the IEC graphical method where the fault shows as D1. And again in dual triangle also, it shows that it is high energy electrical discharge. It's the dual pentagon method. There also the fault is indicating as D2. Now consolidating all these different methods, key gas method, Donberg's method, Rogers method, IEC 60599 gas method, dual triangle method and pentagon methods, you can see that all the faults, all these different methods indicates the same high energy electrical discharges, and later the utility person after opening the transformer also confirmed that the obtained fault was arcing only. Summarizing, DGA, as we know, one of the efficient and proven technique for the transformer fault detection, and DGA is based on the gas chromatographic principle. Different standard methods are for DGA analysis and also for interpretation, and each method of interpretation is having its own importance and also advantages. But along with these different methods, transformer history also needed to be considered before reaching a final conclusion regarding the fault of the transformer. That's all. I hope.
Thank you, ma'am.
Thank
Actually,
you
you
very
could about to complete within the time. 1 minute actually was there also about to speak, but she could able to complete before 1 minute. Thank you, ma'am.
Thank you.
Many thanks. So by this, we are concluding of session number 1, but before conclusion of session number 1, we will be now entering to the question answer session. So I will request the, please put that session number 1 slide over there. So I think questions already, any questions you have, please just hand it over to us. Please collect the questions. There from any question is there? Okay, no problem. So our technical session number 1, already we have extended these questions in pre-hand to all the authors. Any questions is there from your side? Otherwise, we will take up. Yeah.
Sir, myself Sanjeev Yadav, I am from DMRC. Is there any RDSO approval for your connectors, especially from the representatives of Sripat?
At this moment, we have done a type testing as per IS 5561. We have not applied for a specific RDSO approvals, but as far as substation connectors and TND connectors are concerned, like equipment connectors, we are definitely have all type test requirements. And basically we customize also as per the requirements of clients. That also can be taken care. The best part is we have our in-house test lab, completely fully facilitated for all the connectors qualification test. So normally we rely on that. Sometimes customer try to visit also our factory and witness the test. So that's the reason. At this moment, RDSO approval is not done. Thank you.
Yes. So please. Person Saab.
Yeah. From Mr. Sood, please. Actually, there are too many transformers at site. So suppose there is moisture more than 500 ppm, then what is the way?
Sir, you please come to the dash.
Then what is the way?
Arrange one chair.
It was very interesting topic of
Okay,
high
no problem,
moisture.
no problem.
So first thing, how to measure the percentage level of moisture at site, and if it is more than 500 ppm, how to remove it possibly at the site itself.
Thank you for the question, sir. So generally, for assessing the percentage moisture in the transformer, we use Uman's curves generally. RS or AWP versus percentage moisture at specific temperature. From there, we can have an indication of what is the percentage moisture. But 500 ppm is too high. Even the saturation levels that I told, the solubility levels that are very, very high, 500 is very, very high for that. If that is the level, that time this dissolved moisture will turn to free water and come down at that level. But moisture definitely it will be removed with the method whatsoever we are using for removal of moisture. It will definitely remove whatsoever be the inlet moisture. It is if it is passed through that molecular sieves or cartridges where simultaneously two things are happening together. One is dissolved moisture is being removed. Second thing is 1 micron contamination or conductive contaminants also are removed. So dry and clean oil go back to the transformer. So it will be continuously done, and it will be continuously, for example, 500 ppm is too high, but I'll take an example of suppose there is a ppm of suppose 50 ppm. 50 ppm inlet and outlet ppm will be definitely 1 ppm or 0 ppm even.
ppm is allowable.
Not allowed. That is the solubility level at that specific temperature. There, that example was the ppm was 11 ppm, but when we calculate the RS value, that will be 11 ppm by 220 ppm, 242 ppm. That comes to be 4.5%. That is the solubility level at 60 degree at which the moisture can be there within the oil. If it goes beyond 242 ppm, it will come down as a free water. It will not remain as dissolved water. I hope I clarify. Thank you so much.
Sir, please be seated there, sir. Just be seated there. Okay.
Next,
Please, sir.
one question. Myself, Umesh. One question to Madam Manjusa. Nowadays, people are talking about the online DGA. So, do you have any suggestions that up to what capacity we should go for the DGA, online DGA, or offline DGA? And what should be the frequency, especially for the distribution transformers up to 50 MVA? Dr. Rajesh is also there. He may also add to it.
Yeah, Manjusa ma'am, please.
Thank you, sir. Thank you for the question. Nowadays, so many places there are online DJs. It is installed there. But DGA, as we look into that, it is a very stringent environmental condition it needs actually. So to get the exact value, if you wanted to know the exact fault of once in a year, we need to submit the sample at the laboratory itself for the dissolved gas analysis. Online DGA can indicate that if there is any rate of rise or if there is any drastic increase in gases, but to get the actual fault condition, we need to submit at the laboratory itself.
On online DGA on distribution power transformers in distribution sector. Say up to 50 MVA.
Right. In higher category, online DGA it is there.
That is there.
Right. But it is best to submit the sample at the laboratory only, rather than maintaining and monitoring that DGA system at online level in small transformers. I think Dr. Arora can.
First of all, thanks a lot for a very valid question on DGA. I can answer you based on the relevant IS and IC. The prominent IC applicable for that DGA is IEEE C57-104. Again, it has two parts. One is 2008 and second is 2019. In Indian context, if we talk about that IEC is 10593 and samples are based on IS 9434. When you talk about the frequency of samples, these two standards clearly mentioned in their note that depends on the assets management techniques of particular utility, because when you have to increase the frequency and you have to take decision on online or offline DGA, it has direct impact on three things that is called a tariff. You have to get permission from your regulator to get it implemented. It is a policy matter, and that also depends on the frequency of failure in your systems. It's a call of utility people to talk on that, to take a decision. There is no mention about the frequency. It talks about the frequency of sampling based on the DGA status 1, status 2, and status 3. This is the actual thing we have to take care. Thank you.
Actually, sir, the frequency is decided by the actual concentration of the gases which we are obtaining. On the basis of that. For a normal working transformer, if everything is okay, once in a 6 months, it's okay. Otherwise, we need to go for frequent DGA monitoring to find out the condition of the transformer.
Yeah, please.
I just want to add to what Madam and Dr. Saab in the Bhumik. Actually, the online monitoring, if you consider a utility who do not have their own lab and all, for them it is better to go for the 8-gas online monitoring system. It will give a very good, nowadays they are very accurate. But if you are having a laboratory and all, then you have to be selectively, you have to choose the online monitoring of where you are going to put. especially in a distribution transformer below 50 MVA, probably you have to see the cost of that and the transformer cost, whether it will be really worth putting it, that we have to consider. It's a matter of policy, matter of study. But online monitoring definitely helps in certain cases, like they give you continuous assessment of the gases, and then suddenly one fine morning, like Madam told, suddenly the gas has increased. And then you need to know what is the problem. Normally, if you take 6 monthly sample, you will not get that. But in the online monitoring, you will be getting that indication. You may not be getting an accurate gas value, but you will be getting a certain rise, and you can take a sample and send it to the laboratory and see what is the problem. Sometimes there is a false alarm also. So that way it has got its own utility. So online monitoring, yes, a lot of utilities are now going for, like Power Grid has gone for all 800 kV, and all the HVDC, they have got the online monitoring system. But just one word of caution, if you are putting so much of online monitoring and all, you should have a system in place to monitor those gases also. Just like that, putting will not help. In Power Grid, we had developed a system from where, because all the data we are getting to the NTMC, and from that data, there was a dashboard. In that dashboard, it was giving region-wise, it was giving red, yellow, green, and all those indications. So the operator is to see if there is some red portion, he will click there and see which transformer there is a problem. Unless you have a similar system, it is actually not going to help you much. It will be left to the operator who is at the site. That's all. Thank you.
With permission, I would like to add more point here. Your point is valid. We must have some online gas monitoring system. But having that data is not sufficient, as very well said by Bhumik sir. You have to interpret it. You have to find the fault after that. Merely noting and getting the data of a particular transformer is not the solution. If you don't know how to interpret it, how to identify the fault, what is going on in that transformer, it is of no use. We must have a good setup for interpretation of the data we are collecting. Only then it will help.
Yeah, actually it is a very good kind of interaction, and yeah, please.
Regarding the on-site measurement of the moisture, we have used one portable kit made by SS Engineering Noida, which gives the percentage of the moisture available in any oil, whether gear oil or transformer oil, which you can just carry in hand, and it has got 3 types of tests: 10 test, TVM test, viscosity, and moisture test. So this is easy to carry and not very costly. We have used long back, so just I remember now. Thank you.
Yeah, actually during the way, whenever ma'am will be having her answer session, we will not be asking any query to ma'am, because already her questions been answered. So now we are coming to Tukaram sir. So Tukaram sir, actually one question, there are 5 questions we have, and with these 5 questions, Ishan, Mr. Ishan is also there. If he plans also can supplement. Only one question will be taking over here. What is the break-even point whenever we go for amorphous and CRG, or the conventional CRG we have, and whenever we are going for the amorphous, definitely all the way people will be thinking about its acceptability and also the reliability and where it is been used, like that, credential kind of things. So you have to answer in the tune of like workmanship, because that is also one of the factors. Second way, the cost factor, size and dimension, and cooling process and loadability. So it's up to you if Ishan or as like. Okay. One aspect I can say, you just make it cut short, because those queries it will be, because we will be concentrating upon number 2 only. Others are there, that will be, you can answer later.
I'll just give a quick brief about the amorphous transformer. Right now, amorphous transformer. I'm audible. See, amorphous transformer future, when you are particularly talking about, let me tell you, it is now a old technology. It's not something which is very new. A lot of members here would be, we will be feeling happy to know that more than 12 utilities now, DISCOMs, are buying AMDTs. Okay, they have equal opportunity for this spec inclusion in present all the discoms of Punjab, Haryana, MP, Andhra Pradesh, Telangana, Chhattisgarh. So it's something which is coming up in a very big way. So when we were talking about energy efficiency and when we were talking about, when Tukaram San was talking about carbon neutrality, not only that part, now the best part which is coming into the picture of AMDTs, now it's very cost competitive also when you talk about conventional technology. So just before 5 years before, the scenario has completely changed. That is the future of AMDT till into the distribution transformers. Related to the workmanship and cost factor, Tukaram San will be giving the answer.
Okay. Thank you, Vishan San adding up. So I would like to add all 5 questions in a very specified time. So instead of saying it's a future is good or bad, I can give just numbers. In 2016, India used to import amorphous metal approximately 1,000 metric ton per month. Now it is approximately 4,500 metric ton month. 4,500 metric ton per month. And in 2016, there were only one manufacturer, Hitachi. Now it is approximately 5 to 6 manufacturers, like major from the China. And still our share is not great. It's only 25, 30, maybe 20, 25%. So the major share is of the China. Coming to question number 2. So the workmanship, the same workmanship, if you visit any manufacturer who is doing amorphous and CRGO metal transformers, the same workmanship can be allotted for the CRGO as well as the amorphous. The only is the process is different. They need to know how to lace and unlace. The cost factor in coming to the present scenario, if you look at the pre-COVID and after COVID, the price level, pre-COVID level, the maybe PH100, the price CRGO would be approximately 145 rupees. Now it is costing approximately 320, 325. It was gone up to even 400 levels also. So almost 2.5 times price has gone in the CRGO. While in amorphous we have also increased because of the raw material, but we have not capitalized the situation. We have increased approximately 45 to 50% of the amorphous cost. So there you can assume like what is the effect on the cost factor. Size and dimension, of course, the construction is different, is the shell type and the core type. However, we can meet the volume of the CRGO transformers, what we have. The cooling process, again, it is the same. It's about the tank, how much heat dissipation. Already losses are defined in the BE table. We cannot cross the BE table, the losses, so we are within the limits. The cooling provided according to the losses. So cooling is always about the oil and how you design the tank. Loadability also designed, and short circuit test already done on the transformers. So there is no question of any fault or any lesser load applicable for the amorphous transformer. And moreover, load is always taken by the winding rather than the core. And coming to the mandatory to use fire rating.
Sir, we'll go for those questions. You just give it and we'll be publicizing those.
Sir, one conclusion comment from my side. Just for the utility people sitting here, if you consider 100 kVA transformer with a conventional CRGO transformer, amorphous is right now 4 to 5% commercially cheaper than the conventional transformer. This is the future particularly. You take any rating up to 500 kVA, this is the difference you're going to find in amorphous transformers.
Yeah, so our second author here, Dr. Hariom Gupta, Professor Sir, please you just go for this number 2. Already, sir, there it is there, sir. So you can read out also there.
About the first picture.
Sir, number 2 we'll be discussing. Yeah.
Okay. So this is regarding the free behavior and economic reasons. Economic reasons, we know that aluminum is cheaper and prices are mostly stable. So we prefer aluminum. But
sir, I'm just reading out the question so that you can get it into well into that question. It is of aluminum, copper, aluminum, copper. So winding has been considered on mechanical strength, basically in this regard. Creep life, contact resistance, parameters. In your paper, you have mentioned all these things.
Yeah.
Please explain these parameters with a techno-economical context.
Yes, well, in that context, because of the poor behavior of the aluminum, the creep behavior is poor means it gets deformed with time. It gets deformed means it is loosening. If it is loosening, contact resistance will be more and there will be hot spot and it will be a failure of the transformer. That you can see from the data that we have gone from earlier aluminum mount transformer, now we are having level 1, level 2, level 3. Still failure rate are not coming down. What we have to do in that particular case, we have to emphasize on the maintenance of aluminum mount transformer. We have to regularly check their joints. Regularly they have to be checked. Only then it will be possible that we will be able to manage the failures. And if you don't want to do that regular maintenance means that every season, after every season, the joints has to be checked. Means after winter, after summer, has to be checked, and they have to be tightened. Then there is no problem. That is what you have seen. House wiring, you replace aluminum wiring from the copper wiring, because wherever you are complaining about the plugs are burning. Whenever you put a heater or something wrong with the plug. Nothing wrong with the plug. It was wrong with the aluminum conductor cable joining, terminating at the plug. That was the problem. Okay. So same
sir.
is,
So actually,
same is the problem here.
Yeah. So it's a very good way just explained, because every day we are finding the plug pin and all. In that particularly example, will be well into and everyone can understand. Now we'll be coming to the Tanvir Adil. Sir, one thing, how you are deciding the repair and replacement, because what happens whenever any kind of transformer goes out of the way, so we need to either go for repair or replacement. So you have to take some idea of our utility members to go for with the repair and replacement. Any technical methods you are adopting for this?
Right, sir. As far as understanding the concept of repair and replacement is concerned, audible? Yeah, okay. So as far as understanding repair or replacement is considered, once a transformer is out of service, we need to understand whether it needs overhauling or servicing or rewinding, or we need to scrap and take it completely out of service. So the first parameter to understand whether the existing windings can work is through Furan analysis, whether the insulation of the windings is apt and adequate for further service. So carrying out Furan analysis gives us a detailed understanding of whether the current windings is sufficient to go ahead with. If the Furan analysis is not apt and not adequate, the next step that we are taking is to understand whether the economic cost of repairing of that transformer is viable or not. If, let's say, the current existing cost of a new transformer and the repair cost is 40% of that transformer, and we are able to repair it within the 40% limits, then we are going for repairs. Otherwise, we are scrapping it and taking it ahead with a new transformer.
Oh, great. Actually, that is the things actually you have to make use. Otherwise, what happens now, by the way of just considering the repair, then you will be in trouble. And next question, whenever I go for Srinivas sir, basically the number 3 is not going to put it here because that is under patent. They have applied, so need not to make it of deliberation. So that's why I am coming to the number 2, which will be of a greater interest of all house members here. Basically, what happens? Some of the what is comes as the wedge connector. That is called something like no bolt or boltless connector like that. So that is available in the market, and manufacturers, they say such connector is something like what called fit it and forget it. So why your unit is not attempting such? Or if it is attempting, then I think we did not understand your presentation. Beg pardon for that.
Basically, when we talk about transformer connectors, it is a equipment connector. And wedge connectors which are available in market, that is mainly for conductor to conductor connections. That is one biggest difference which is there. Second important thing, when wedge connectors we are trying to install, it requires a special tool. And here, by considering the skill sets at our utilities, it is always better to give installation by using a normal tools. Like R connectors, you can install a simple spanners also. And third important factor is a verification of the correct installation, whether it has been done or not. So in case of shear bolted technology, after breaking a shear head, you can able to visually confirm that yes, it has been installed correctly. So no need to further tightening. So these three reasons, that's the reason we have not attempted for a wedge connectors and the existing application designs already also have been filed for a patent.
Yeah, I think OS connector is also easy in your basket.
It is in our basket, but right now our complete focus is into a substation connectors and transformer connectors.
Okay. So next we'll come to the Yogesh Sahab, basically the question number 3. Percentage moisture content of oil samples indicate about the moisture in the oil, but not in the solid insulation, which was clearly getting.
My answer is actually question is that whether the moisture is really removed from the transformer, whether we have done some tests like IR value, PI value or insulation tan delta tests that we have done or not. So we have correlated that what were the before IR PI value and tan delta results and after IR PI value and tan delta result.
But one thing very important, I just want to link that with this, that contamination removal along with moisture removal is very, very important, and for which one empirical formula is there, which is internationally used, that is called the power factor of the press board. That is the power factor of the press board, in which we take the insulation tan delta value of paper and power factor value of the oil as well. No, my presentation. One slide I want to show it to you. Okay, this one is okay.
Okay.
Can you enlarge this? Yeah, here we did it with Megger IDEX in frequency domain, and this is one power grid reactor on which these tests were conducted.
Can see insulation tan delta was 0.62, which was reduced to 0.4, and also the oil tan delta value got improved. And this is one power factor for press board test, which says that CHL into. Can you open slide, please?
It's a bit difficult for them to correlate. But anyway, you just answer.
Okay. Actually, in this power factor of press board, it is in the paper. I think presentation also will be discussed. That formula and the results both are there. In that, what I want to convey to you is that tan delta of paper and power factor of oil both were taken in that formula, and there is an interpretation for that power factor of press board that if that power factor of press board is less than 0.5%, that means the percentage moisture is also less than 0.5%. And if that power factor of press board is 0.7, that means your percentage moisture might be around 2%. So idea is that if the oil is clean, it is very important, oil should always be clean. If oil is clean and free of contaminants, with no moisture, it will definitely give very good IRPI and tan delta values. And that was cross-checked. What was the question? And it was related that moisture was removed. It was done at numerous places in various state utilities and as well as with the power grid corporation.
Yes, sir. Yes, sir.
FDS. I'm talking about FDS specifically.
It was done,
not
sir,
the tan delta and all.
FDS was not done. Dyrana kit was not used. Only Megger was used. In frequency domain, we checked the tan delta value.
Yeah, frequency domain. The same thing. I'm asking the same thing. So what was the result of that? Because they give interpretation.
It gave both capacitance and this. It was 0.6 before we started it, and after that the complete process it was 0.4.
Okay, 0.4%.
Yeah. And in US utilities, it was from 3.3%, it has reduced to 0.7%.
So it was validated to the FDS?
Yeah, yes, sir.
Okay.
Yes.
Thank you.
That was.
Okay, so we'll come to next Gupta sir. Basically, there is two questions for Gupta sir. Question number 4, basically this is offline method as exactly you narrated to the house, and job need to be taken for prolonged shutdown. So how do you say it is a techno-economical method?
Yeah.
Sir, just be seated and
Yeah.
Okay.
The economics works out with the size of transformers. Suppose a 315 MV transformer has to be shut down for 9 months to 1 year. And suppose it has to be shut down with this method only for 3 weeks.
Oh.
So you can understand what is economics.
Exactly.
And when you take a transformer from factory, say 1100 kilometers from Odisha to all the manufacturers in the west of the country, so it travels 1500 kilometers. What will happen to transformer? Can you imagine?
Yeah. There is a lot of
risk of transportation is extremely high.
Yeah.
So it is always better to bring the equipment to the site and do it. And then it is guaranteed that the moisture content will be less than 1%, guaranteed.
Yeah,
No
thank you.
issues.
Thank
No
you.
questions
Actually,
asked.
another question also, provide correlated study on RLA based on DP and Furan analysis and decision towards MPPD.
Yeah. Now this is, see, I don't want to recommend heart surgery to where you are 90% is closed, because you may spend few lakhs and after that you may not survive. Same thing happened with transformer. If we are able to do DP test means you have to open the transformer and take out the insulation and the test. But if that is not possible, then Furan analysis to be done. Now there is a correlation between Furan analysis, DP and the aging of the insulation. So I have given a chart in my paper. So even if the life expectancy of transformer is more than 60%, then only we recommend to do this. Otherwise,
great.
Test will die.
Great. Actually, very correlated.
I don't want to spend money on the transformer, which is
obvious.
Chances of survival is only 40% or 30%.
No, actually, I just take it in lighter vein.
Yeah.
Basically, what happens sometimes whenever we go for our relatives to go with a kind of heart surgery or blockage of the things, it is a question of sentiment attached there.
It is sentiment, but in case we are talking of the pure facts.
Yeah.
So, but in large transformer, having a breakdown of 500 MVA or 315 MVA or 200 MVA is much more serious consequence than anything else. Apart from the technical, it is a political consequence also. Few states will be out of power.
Yes.
Few states. So it is to be done. That is the reason it has to be done.
Moreover, actually, it is basically economical if you go for a higher rating.
It is economical, and we are trying. We have done this in for Maharashtra. At least we have done at 12 places. We have done this transformer, this process in Alstom, Fatehbad 500 MV transformer, which was up in 3 weeks' time. It had insulation.
Because of we are getting very interesting kind of interaction, but paucity of time not allowing for to go in depth. So that's why one concept is there. We are having one magazine in which will be all these kind of interaction you will be reading out. So we are lucky enough.
Otherwise, taking 500 MVA to factory and coming back is a 1 year affair.
Sure. Next we will come to Navran Banerjee sir. Basically, this is a question relating to somewhat. Of course, I may be excused on that line. Water mist is something a old age concept. Why do you consider that this comes under emerging technology? Because our theme basically goes with of emerging technology.
So couple of terms. One is water mist. Then what I could not cover in my discourse is that there are two kinds of water mist, which is a high pressure water mist and a low pressure water mist. So firstly, if we consider what is a water mist, it began as a high pressure water mist. Now when I'm talking about high pressure water mist, what does it mean? Is that it is a conventional system, meaning you increase the pressure of the water inside the pipe, and the more the pressure, the harder the water hits the deflector and the smaller the water breaks into. So the diameters are as small as like what I have talked about, like 100 microns. So to achieve what is defined as mist in both the codal references that I have taken, like say 15519 in IAS and
PA750 and all of those. What happens is you have to increase the operational pressure up to something like 35 bars and above, which means a standard working pressure for a high pressure water mist system is 50 bar, often going up to 100 bars. Now, when I'm talking about 50 bar, 100 bar, these are like very, very, very high operating pressures.
It's a very good concept actually. In one angle, I can say we are not making use of a large quantum of water to make water spray kind of things. Here, small water and making use of its pressure. The technique, what you mean to say?
So, yeah. So that is the conventional concept of a high pressure water mist. So when you say it is an age-old concept, this is the technique that we are talking about.
So thank
What we have brought into picture over here is a concept where the same 100 micron size of water droplets are being generated in a operational pressure of 3 to 7 bar.
Oh, great, great.
In place of that 35 to 50 to whatever. So that is why we are able to, we do not use any pumps. We have charged cylinders, and the gas inside the cylinder is enough to propel the water at that particular pressure what is required by the nozzle. And so this is basically new in the transformer industry, hence this is an emerging technology. That's how we take it.
So actually we are not going to take any question with Manjusha ma'am because already number of questions been gone. So with this we are concluding for session number 1, and before to conclude the session, the felicitation award we will be taking up. So please.
It was indeed a very good discussion. And before I move forward, could you please give a resounding applause for all our respected speakers? Ladies and gentlemen, it is now time for a special segment of our event where we will be honoring our esteemed speakers with well-deserved awards. Without further ado, let us proceed with the presentation of the awards to our distinguished speakers. And I would request the chairman of the session to please come forward and present the awards.
Ma'am, you start from Manjusha ma'am. Ladies first.
I would like Manisha ma'am to please step forward and present the award. Can we have a huge round of applause for her?
Manjusha ma'am. No, you just for Manjusha ma'am. सर के लिए पहले ओ मंजू का मैम अच्छा एक एक करके देते हैं ओके Shud Saab, please. It was really interesting. This particular was a bit lively, but sorry for taking extra time of yours. Sir, Gupta sir. Always very lively, giving up a very live example, sir. This moment. Sir, please, one photograph, please. Sir. Gupta, sir. Hari Om. All speakers were very confident upon their subject, well into the subject.
Now I would request Mr. Patnaik sir to present the award to sir.
Chairman. Sure. Thank you, sir. So we can have one photograph, sir. Please, sir, please be here. Just we can have photograph. Please. Subhash Jajay. Sure. Next, we will have the session number 2, and we are having very limited. Only 3 speakers are there. Okay, thank you. Okay, sir. Nice of conducting this session.
Thank you.
Yeah. Sir, actually, because of this paucity of time, we are going to reduce one speaker, so 2 speakers will be there, and one more speaker will be going to this next session. Because next session already we are not having of 2 speakers, so the timing could be managed. So in this session only we will be having of 2 speakers. Sir, please come to the dais, sir. Okay, sir. Okay. So now I will ask Anil Sinha sir, please come and chair the dais. I think we have 2 speakers. Anil Kopkar sir, please come to the dais, sir. Anil Kopkar sir, please. Sir, please. राजेश जी का चला गया उधर है, मुझे टाइम नहीं हुआ, लंच का प्रॉब्लम खत्म कर लेंगे. अनिल सर एंड भौमिक सर. राजेश जी आफ्टर लंच. अभी अनिल. So actually our session number 1, we need only 2 feedbacks from your side. So basically Prakash sir is there, so you must be listening from him. He is actually one of the enthusiasm every way. So how do you feel, sir, basically the session number 1? In 1 or 2 lines in clubbing manner.
All papers are very practical oriented. That is what I like. In some of the points, even with my experience, some of them was new to me. So quite a learning experience, sir. Thank you very much for that.
Yeah. Actually, one basic problem we are finding, and it is the observations we found, as it is the first time and the electrical mirror, they were not having those kind of experience. So there are some technical glitch and all these things, and moreover also the timing we are, but the situation were becoming so interesting, we are not. And another most beautiful concept we have, all these things again will be landing to you in through the all, because we are not exactly leaving this conclusion here that ATES 2023 got concluded. No, ATES 2003 just started. We will be concluded by the way of all the things what you are feeling, even if some of the extempore way our speakers they answered, but there are real focused kind of things in the written form will be coming and will be presented. So during that time they will be giving the real things what you basically to learn from them. So already our speaker Bhomik sir already there. So we took time, sir. We took time for 2-3 minutes because you are absent. So that's why we will be starting right now. Yeah. So with due permission of the total session, with permission of Anil Sinha sir, sure, we will be starting because everyone is just waiting for the lunch. So we have to make it at the best way possible. With Khopkar sir, we will proceed. Sir, please. खोपकर सर का स्लाइड दे दीजिए. दिशा नाम दीजिए. पॉइंटर ये सर.
Yes, sir. आपका.
So, good afternoon, everyone. My topic is on the recent technology on the transformer, which is recently we have developed on the to monitor the hotspot temperature of the transformer. Since morning we are discussing about the health monitoring of the transformer, and as in the opening session, Patnaik have also told that we should all the stages like our human beings he has described. So hotspot monitoring is little bit like a fever, detecting a fever in our body. So similar way, in the so similarly, we have to also monitor the hotspot temperature of the inside the transformer. And if we monitor the hotspot temperature of the transformer, based on that we can monitor the further life assessment of the transformer, and that is the importance of the hotspot monitoring. Just one slide or two slide we have I have put over here. This is regarding the ERDA. As I am representing the ERDA, that is Electrical Research and Development Association. We provide our services in three verticals like in-house testing, field testing, and research and development and expert services. This ERDA was established in 1974. So just we have entered in the 50th year of the services. So we have provided 5 decades. We are providing our services since last 5 decades. Coming to the topic, that the rate of failure of the distribution transformer is almost in our country 12 to 15%, whereas the other country it is almost 2 to 3%. Why it is so? Because we need to take care of the transformer, or somehow we are overloading the transformer, or we are not taking much care of the transformers. Here I have mentioned the failures, various reasons of the failure of the distribution transformer, where you can see the insulation failure, which is due to the hotspot heating of the insulation, that is 92 transformers. The total data is almost 360 transformers which we have collected. Then manufacturing defects was almost 22 transformers we found. Then overloading of the transformer, it was due to the 30 numbers of transformer failed due to the overloading of the transformer. Then line surges almost 70. Then improper maintenance of the transformer. Such failures we noticed around 19. And due to the lightning stroke, the transformer failed of almost 14 numbers of transformer. Then sabotage 2, moisture content it was 21, and oil contamination we found almost 20. Few other reasons that 58. So these are the data of the transformer. Here we can see the maximum failure occurred due to the insulation failure in the transformer. Life of the transformer and life of the winding and insulation and oil condition. Basically, it is due to the thermal stresses. Now, thermal stresses, if it is there, then life of the winding and insulation get degraded due to the prolonged heating due to the overload conditions. Transformer health assessment, that is the maximum temperature rise inside the transformer. So, if we detect the hot spot in the transformer, then we can find out the remaining life of the transformer. Why hotspot measurement is needed? That hotspot temperature, that from that permissible overload of the transformer we can find out. Then evolution of the thermal properties of the transformer and life expectancies. So these are 3 advantages are there to monitor the hotspot. Then key benefits are the additional loading margin can be provided by monitoring the hotspot temperature. Loss of the life incurred due to the operating at high temperature can be also avoided. We have this direct measurement technique, which are the conventional, that we put the fiber optic inside the fiber optic sensor inside the winding. That is the direct measurement technique. But in this case, we require too many sensors we'll have to put inside the winding, as well as cost is very high. So what we have developed, this is the ERDA has developed this technology, that smart sensing solution which will detect the hotspot in the transformer. In this, we are using the current sensor and the temperature sensor. Based on that, the hotspot detector embedded with the algorithm, there is a IEEE guideline is given. In that, there is an algorithm is given. Based on that algorithm, we detect the hotspot bottom oil temperature as well as the top oil temperature, and that these two things we have correlate with the IEEE algorithm. The information, the product information, the current sensor, and as I told you, the transformer load at LV side calculate as per the unit load. Then temperature sensor senses the temperature of the transformer oil, bottom oil, and the ambient temperature for the hot spot calculation. Then current measurement range is 0 to 30, which we have developed, that is up to 30 ampere range, but it can be extended as per the requirement. Then temperature sensor range is -5 degree to -55 degree to 145 degree centigrade. The advantage of this device is retrofit type, so we can just fit on the transformer and then remotely we can monitor the temperature. Then scalable to fit of any of the transformer, we can design for any of the rating of the transformer. Then rigid in handling, it is not much expensive and less sensors are required in this case. This is a graph where we validate our results with the IEEE given in the IEEE. You can see it is exactly matching as per the IEEE algorithm. And this is the rate, our result, which we have done the experiment of the 16 kVA transformer, and then we have fit on our, we have one substation, there we have 1.6 MVA power distribution transformer, where we have fitted this device and we are getting the output such a way in our laptops at our substation. So that's all from my side, and these are the references which I have taken from for these technologies. Thank you.
Yeah. Actually, good way presented the kind of things, and only one point is that it was very impressive of talking about whenever anything happens to our body, we take the temperature, just to know about what exactly happening internally. So he has just taken that concept, because God's concept actually you took, and God has given also that kind of things that anything happens to the body, means first of all you have to check the temperature of the person.
Yeah.
So it's a good idea. With this, actually, we'll be coming to the question answer session also.
Yes.
Sure, please.
Only thing, sir, algorithm I have not mentioned over due to the limitations of time, and these things we have patented. So further detail, much detail we have not incorporated.
Sir, you can write also with electrical mirror,
yeah,
so that it will be reaching to all persons. Okay. So now, sir, Bhomik sir, please. We'll be listening to Bhomik sir.
Good afternoon, esteemed guests and the esteemed delegates of ETS 23. And actually, the Spark, first time I am attending a Spark conference. So this is my first, and thanks to Mr. Patnaik. He's given so much of, through the Spark, so much of knowledge has been spread throughout India. It's great. I cannot say it in words. And the same thing goes to Dr. Rajesh also. So without taking much time, my topic today is health indexing of power transformer. I'll give a small overview within this short time. So if we go to the background, basically the transformers are, all of critical components in power system that require regular monitoring to ensure their reliable and efficient operations. And basic objective is that this presentation, it will highlight the significance of the transformer health monitoring and discuss various techniques used for assessing the health condition of the power transformer. Now, what is the importance of transformer health monitoring? All of you know it, but I'll just remind you. A transformer failure can cause a big power outage. They can be very expensive to replace. And a power outage can cause a lot of loss of business for the industry. Transformer health monitoring plays a very crucial role to ensure the reliability and longevity of the power transformers. So by monitoring the health of the transformers, utility operators can proactively identify the potential issues and take preventive measures to avoid costly failures. Now, most of us are from the utilities. Now, utilities manage a very large fleet of transformers. Like in power grid, there are got 7,000 to 8,000 transformers, that too in the high voltage segment. So similarly, in all other utilities, they having that much of numbers along with the distribution transformer, much more than that. So a large number of data is being generated by your maintenance testing. It is many of the places, locally it is being stored. And then it becomes a challenge for the utilities to interpret this data manually. Not everywhere will have experts. Experts are mostly located in the central place. But somebody has done a test, he got the test results. If he does not report, and then probably there is something very serious happening and he doesn't know, it remains there. And basically, that is why many a time the fleet managers, they're missing the warning signals for one or more transformers when this huge data is managed manually. If you try to manage manually, you will definitely miss some of the red signals. So fleet managers basically involves the monitoring and managing a fleet of transformers with a utilities network. So they have to devise a method to manage it. So it will enable the utility operators to gain a holistic view of the health and performance of their transformers. So that will facilitate informed decision making. Then effective fleet management will also ensure optimized maintenance schedule, resource allocation, risk mitigation. Now, what are the basic usefulness of the health monitoring? First was the early detection of the potential failures. That everybody wants that the potential failure we should be able to early detect and then take care. Then increase the reliability. By regular monitoring, it will help ensure the transformer operates in optimal conditions, reducing the risk of unexpected failures. Cost saving, of course, cost saving is a major issue for the management, and the improved asset management. The health monitoring data that will aid in optimizing the maintenance strategies, extending the lifespan of the transformers, and maximize return on the investment. Now, these are all known to you. They are the typical, some of the diagnostics generally run on the transformers. Dissolved gas analysis, you will learn it more from Dr. Saab, then I think next session. Then bushing tan delta, capacitance, winding tan delta, oil parameters, Furan analysis, OLTC BDB, polarization index, core insulation test, SFRA, and that is also SOS test, LV test, and the PD test. The list is not really exhaustive, and you can have more number of tests to add. But for the health monitoring, probably few of the tests only will give you a very good idea about that. And before I go to the next slide, because there are a lot of discussions took place in the Furan, I'll just give you one word of caution about the Furan measurements. Furan is having a correlation with the DP, but sometimes the localized hotspots, they can also suddenly, there will be rise in Furan, and it will suddenly, you may feel that winding is gone. It is not so. We have seen it in the HVDC transformers, sudden Furan increase, but later when the transformer was taken to the factory and all for some other reason, the paper was showing the DP value of 900 to 1000. So there is no problem with the paper, but the Furan was suddenly high because there was a localized fault. Because of that it came. So you should be careful about that when you are interpreting with the Furan. Now, what is health indexing of the large power transformers? Basically, health indexing is providing a quantitative assessment of your transformer condition. It will assign a numerical value of an index to the transformer. The higher value may be good and the lower value may be right. Somebody may just reverse it. Some people, 1 may be good or say 1 may be good and 10 may be bad. So it all depends on the utilities how they do it. And then by using health index, they can prioritize the maintenance, actions, allocate the resources efficiently based on the criticality. The index is based on some of the routine maintenance test results of the transformers. We have devised certain tests which you have taken for the health indexing. Some utility may not like that. They may take some other test for the health indexing. It all depends on their experience. But numeric health index, there is a risk also. It can mask the actual criticality. Like say if you have a test of say you are having a score of 8, but then the transformer is having a high acetylene or the bushing condition is bad, even then maybe because of the calculation it is coming a very good result. So you should know that health indexing should be able to identify that. It should unmask that actual criticality. And then most of the applications nowadays, they can identify such critical conditions even if the numeric scores are good. Now, what is the objective? The objective is to provide a system and method that determines the current health status of the equipment by means of a hybrid health indexing scheme and to diagnose the abnormalities. When the hybrid health index helps in ranking of the transformers and reactors fleet and optimizing the scheduling of the maintenance activities. It provides a system and method that incorporates a diagnostic feature such as DGA, trend analysis, and worst case analysis. DGA is a major component of a health indexing. Then that addresses, and the system and method that addresses the challenges related to the centralized monitoring, diagnostics, maintenance planning activities for a large fleet of transformers and reactors, line and bus reactors by assessing their health. And that is a simple in design, easy to use, handle, and economical. You don't believe that, you will not believe that after Power Grid has started this health indexing and all throughout this thing, they have got a very good results, and their management it is a very good thing for the management, top management, they have a console in front of them and they can see which transformers in what condition, what is the ranking of the transformer, and they can sometimes, they will call the people why it is going low, why it is going up, the scores. So they will know the exception points. You need not go through all the results. That is the advantage. Now, this is a bit theoretical. Those who have read the brochure 761, the transformer health monitoring, transformer health monitoring of the CGRA brochure, they have at length described the different type of indices, and I can say that I was a part of that brochure. From India, I was the member of that. So there are several health index they have mentioned. One is the reliability and health index, which is generally all of us are using. We don't go beyond that. That is to rank the transformer based on the likelihood of failure and expected time of failure, and those that have degraded from the original condition. This is what we are doing. Rest of the things, generally it is not done, but some of the advanced utilities, they may be now gradually going into that. The replacement index, this is used to identify the transformer that most need replaced. So that is another type of index. Then repair index, again it will rank for the benefit to know how much, whether the repair, how much repair, which transformer requires repair first, which transformer requires second, that way it will rank. A refurbishment index, again the same thing. The transformers which require refurbishment, in that manner you can also have a refurbishment index. There will be the index values and the inputs will be different for each of them. Then the composite index, it will combine the outcome of the replacement and the refurbishment repair requirements. So it will include a technical assessment and a general financial considerations to allow it to decide the best solution, considering the maintainability of the failure modes in a transformer. Like suppose a transformer has already reached the end of the life, so 25 years or so in India. So once the 25 years are gone and then it is not behaving in a manner, then probably CRC will allow you to replace it. So better to replace it. That is a financial consideration also. So that also, so then you have to see that. So there will be some pointer for that index. Then mitigation index or score. That the approach that can be adapted to assess the technical feasibility of a refurbishment or repair. Whether you should go for repair, whether you go for repair, or you should replace it. So that is a mitigation index score. So they are basically different type of index. I am not saying that you do, if you can do the first one, that itself will give you 90% results. Now, this is also from the brochure 761. I have just written it here. The basic steps to develop a transformer index is that determine the purpose of the transformer assessment score. Like the previous slide I have shown the different purposes. Identify the failure modes to be included in the TI. That is very important. What are the different failure modes which we want to identify in the assessment index. Then determine how much failure mode will be assessed. Then design a calibrated system and calculate a TIA score. And some of the, if you have a small fleet and all, the fifth you may not require also. You can go up to 4, and then for the case-to-case basis on the individual transformers, we can assess that way. But if you have a large fleet, the step 5 may be required. So if you have a health index, then you have to make, so you see the data source. There will be several data sources. One is field, and there is laboratory data, and there is the online data. So I'll just take 2 minutes, okay? That the data is not in ERP, then it will come directly to the AHI server. There will be a server. If it is ERP, it is better to come via ERP. And similarly, laboratory data, the online data. And then it will go to the AHI application, and then it will go to AHI dashboard. That is the basic structuring. Why it is not going? So that is the data visualization part. Like you can have a dashboard like this, and you can see the different regions, and then region 3. So I'll just go to the next slide, because I have got actual visualization from of an application I'll show you. So these are the features of the AHI, which I have already told you, so I need not repeat that. But in this, the last point, you please note the severity analysis using normalized energy intensity, NEI, of oil and paper, that is IEEE C57104-2019, page number 81 to 83 if you read, that gives about NEI oil and NEI paper. So I suggest you people read that and use that for the severity analysis of the transformers. So that will give a very good insight. And you use it with the other parameters so that you know which is more severe. So numeric and non-numeric is scored. I mean, there are several ways of doing it. So you can read from this thing. It is not, I'll go into that. And then you can combine this with some the numeric code with the color code and also with some numbers. You can do that. So this is actually, I want to show you, this is actual visualization of a particular software, where it is showing the overall picture of the transformers with all C's auto transformer, shunt converter, and different regions together. On the next screen, if you can go to the list of the transformers, where it is listing about all the transformers with their test scores and the health index and some other details of the transformers. And then if you click one of them, and then you get this kind of this thing. So see, the health index score is 8.58, showing red, because here the DGA is more than C2H2. That kind of a thing you will get. And then if we, these are some of the parameters for the health indexing. You can see the test procedure is also given. That is, I should thank Mr. Patnaik, he gave me the suggestion. So we have put that test procedure also in that. You click test, you will get the complete test procedure of all this. So then the next slide for the other this thing, it could not come in one screen. So then the DGA analysis report, you will get the complete comprehensive. You can see that NEI oil and NEI paper is also given there, and all other methods are displayed in this. And then you can see the graphic analysis, just given you one example, the dual triangle, it will have dual triangle 4, 5, and the dual pentagon, everything is there here. And then it can also generate a kind of a DGA analysis report for the transformer. And then I have come to the end of my slides. This is the transformer health monitoring, the fleet management, health indexing, the use of diagnostic techniques are essential. It is essential for utility operators to ensure the reliability and optimal performance of the power transformer. The proactive monitoring enables early fault detection, cost saving, and improved asset management. By leveraging the techniques such as DGA, bushing, winding, tan delta, and capacitance and other tests, it can give valuable insights in the health condition of the power transformers, and you should utilize them for the index purpose. And implementing a robust health monitoring practice, it is crucial for the efficient operation of the power grids and maintaining a reliable power supply. So that's all from my side. If you have any question, I can answer.
Yeah, actually it was a very good in-depth kind of discussion, but paucity of time always making us to interrupt in between. We are extremely sorry, sir. Because this is the part of the way to make also other. Now it is open to the house. So if any questions are there, then we can take up. Otherwise, our ready recon question is there. Yeah. One stalwart to another stalwart, I think so.
First of all, thank you, sir. Thank you for this insightful, wonderful presentation on your part. Thanks for that. Indexing is important, but my question is, to make any index, you have to test, you have to conduct so many tests, and you have to give weightage of each test you conduct. Secondly, you don't get shut down every time to conduct that test for transformer. That means your health index is going to same until some new test is carried out. In between, some problems happens. How to take care of that one?
I got your point. See, in between problem, if it is something happening, you have DGA and all with the online monitoring and all, that will do. But health indexing essentially uses the last major test. So in this, if we have, every utility has a schedule of testing. Some tests will be done in 4 years, some will be done 6 months, some will be 1 year. Now, in this system, the screenshot what I have shown, which I have not told you because of paucity of time, those tests, when I click to a transformer and it shows all the data, all the results, in that it will also indicate the how old is data, the data whether it is within the your maintenance schedule, or if it has gone to beyond maintenance schedule, how much beyond. So 3 type of category I have made in that. So one is the which is within the schedule, which is another within the 30 to 30% of the schedule. I mean beyond 30%, and beyond that I have made it pink. If you see, if you can just get me that slides back, can you just? It is very interesting. Acha. So from the data, from the date we will find date is colored, either pink or white. You can see from the it is in my slide. If you see when you go to the particular page and for a particular transformer, the date of testing, if you see the date of testing is pink, that means it is very old. If it is white, it is new. So that is one thing. Yes, if there is something happens in between, see it is sudden failures, you really cannot help. Even you are doing DGA and all, still our windings are failing. So for that, online monitoring may give some kind of data. That's all. I mean, you can say.
Thank you, sir. Mind blowing. Hats off. Thank you. Thank you very much.
Yeah, please. Umesh sir, yeah, this young chap first of all, sir. Because they are the boarding engineers, bona fide engineers of nation.
Good afternoon, sir. I have a question to Khopkar, sir. In FOTS, we generally use 8 channel. So for a core, top oil, for 3 for HV, 3 for LV. So in this smart sensing sensor, how many sensor minimum we are required, and what is the exact location, optimum location to sense the direct hotspot? In FOTS, we are getting a direct hotspot. So in smart sensing, I have a question, what is optimum location for sensing hotspot?
In this, we require at least 4 locations, that top oil, bottom oil, and middle of the transformer.
Yeah, Umesh ji, please.
Yes.
Data points are there for a transformer testing, and different types of tests are there.
Right.
Then how do you upload all these data points to this?
No, you are talking about 400 types of data on a transformer?
No, I am saying that you do so many tests. You
Yes,
have listed.
that's what I
So
showed
all
you.
these tests, I think, having few hundred data points. Say, even if you go for a winding resistance test, it may be having, say, more than 51 data points. Then uploading all these data points to the system, how do you do that?
See, actually, I'll tell you what Power Grid has done. Okay, Power Grid also having the such system.
Because we are also working to develop this kind of
I'll tell you
indexing.
what they have done. One thing is that if you have a ERP, so whenever the site test is done, goes to the ERP. They upload to the ERP. So from ERP, we have developed a system for interface where the AHI server will take the data every night from night 10 o'clock to morning 4 o'clock. Whatever data is there, it will get acquire and put it. If you don't have a ERP, then there has to be a method to get those data from the site to the AHI server, which is bit cumbersome. So initially, what will happen? Lot of data. Who will going to enter the data and all? So provided if the old data, if people are able to enter, then once it is populated, then every time you make a test, if you are having a system of the connection with the main AHI server location or wherever it is, then we will make a system to upload the data. Moment he enters the data goes to the AHI server. But if we have to use the historic data, then somebody has to make effort to take the historic data. Okay, but the good thing about this health indexing is that we generally use the last tested data for the health index. Okay, so what we can do, the last tested data we can populate immediately, and then gradually the previous historical data can be entered. So then gradually history will be developed. So that is how it can be done. That is a big problem in Power Grid also. It took quite some time for us to solve that problem. But we were lucky, fortunate that we had ERP system. So through ERP we could get the data.
Yeah, actually it was very interesting, and we can say, and people must have to go for that one. I think same thing if you consider about the human body. Sometimes also, whenever to take any kind of diagnosis, some at present some sensors are always getting fitted to the human body, and they are allowed for to be there to their house. Let it be of like heart kind of things. Then next day they bring those and get monitor how it is functioning and all. Anyway, with this I think we can conclude because please we take to microphone to him.
Sir, I want to just know about, throw some light on frequency domain spectroscopy of transformer, which was not covered in your presentation. So I want to know how it is done and how it is help for transformer indexing.
Actually, you see, so far, before FDS and all are developed, to know how much moisture is there in the transformer, it was a big challenge. What we used to do, previously Domino was developed by Doble and on the Vaishala sensor. So there they had given a calculations that if the this thing percent saturation, I mean what is it called, that water saturation is this much, then with some data of the transformer it will tell you how much is the percentage of moisture actually within the transformer winding. But it is all matter of calculation. But FDS actually what it does, it is also kind of an empirical formula. So at different frequency, right from the very, very low frequency, say at say 0.1 millihertz, let us say 0.1 millihertz to some 300 kilohertz. Let us see this range. It's a megahertz, up to megahertz. Each frequency you carry out the tan delta, and then you get a curve like this. And from that curve, they have a standard curve for the transformers. So from that curve they will fit, and they say if there is a dry transformer, so with 0.5%, it is this much. So from that curve, by going up or below that curve, it will assess the how much moisture percentage is there in the winding. So FDS or the Dirana, FDS is by the Mega and Dirana by the Omicron. So both of them do the same thing. So they basically give you the actual moisture content inside the transformer. I mean, we have to believe that, that's all, whatever they give.
Yeah, actually, by this we are going to conclude, and the question which is over here to Anil ji, already it has been answered because the gentleman asked the same question, and it was my question also, so I'm not going to take up this. And the second question actually to Bhomik sir, of course number of questions are there, just for reading out those questions, that will be quite helpful for to make it answer. Sir, my sincere request, please just go through these things, and not now, take your own time, comfortable time, and you just revert the answer, so that we will be publicizing those things to everyone, and it will be just getting circulated to all across nation. Only one question is there, very simple, and already answered also in that line. How do you optimize health indexing for fleet management? Can we integrate a CBM technique, condition-based maintenance technique, for this method? Your answer is already been, you have answered.
I mean, they're all condition-based technique, I mean, measurements
just only he has answered. So with this we are concluding. So please, sir, take your seat, and we will be going for a felicitation award. So please.
One question, please. One question, sir.
Yeah, is there still? Okay, please.
Sir, in DGA, presence of any gas, say acetylene, C2H2, by 10 ppm is considered same in 1000 kVA and 100 MVA transformer, but they are different. The time duration of spark is different. Why it is not differentiated by our standards?
It is not different because it is in ppm, parts per million.
But to create 10 ppm in 100 MVA will take longer time
you are right.
for the spark.
You are right. generally, if it is a smaller transformer, a small spark can create a very large amount of acetylene because it will measure that ppm value will be more. But for a large transformer, it could be very less, even if there is a sparking. That is why
the sparks are different.
That is why the standard has said that if it is more than 2 ppm, then it is a cause of concern. It is because precisely the reason that is why they have done. They have not given 10 ppm or 12. You see, it is 2 ppm. More than 2 ppm, now is the IEEE latest standards and conditions one. They are given a very low value. And IEEE, they are given the different categorization, O2 by N2 ratio. Depending on that, they have given different conditions. So you have to go through the IEEE C57.10-2019, you will get a lot of insights for that. And regarding DGA, if you want to have more insight, there is one SIGRE brochure, I don't remember the number, but it was a very good 771. So that gives a very good interpretation of the DGA and all different gas concentration, very good discussions. So if you go through that, you will get the answers to a lot of your questions.
Thanks.
Yeah, actually, we are basically standing in between your launch, but it is very interesting. So over to Hardeep. Please proceed.
I hope everyone got their answers. So one more question.
Can you take it in the lunch session?
Please allow one question you can allow.
Sir, regarding Dirana test, the shape is like a shape, but when we are taking the frequency at 0.1 millihertz, or when we time is increasing, 27 minutes to it goes to up to higher side.
Yes.
Whether we can take lower side millihertz or higher side, because the shape of the Dirana curve is like as S. When we take at higher side, then it is not coming properly.
When you are going for the higher side, means the
frequency range is at higher side, then S shape is not getting properly.
The frequency you are not getting, but it is basically Dirana is a device where you connect and it will do the test on its own and then give you a curve, right? As far as I know. Is it that manually it did not do, na?
No, it is a totally computerized based related data.
Yeah.
But shape is S-type shape. When we put frequency at lower side 0.1 millihertz, then it will take correct shape. When we take at higher side, more than 10 millihertz or 100 millihertz, it will require...
Don't mind, we can take it point to point during launch.
But are you not getting a curve like there is you see, like this kind of a curve is coming. S curve coming,
yes.
it is coming a curve. So that is what is, it will be definitely of that type with a different frequency. It will be of that only.
But it is necessary whether curve should be S or it will be just before S. Second, just like as it stopped earlier.
Drooping, a sudden drooping.
Yes.
I mean, then you have to see why it is coming. Like for that transformer, you have to see. For a particular transformer, if you are saying, you have to investigate it. But generally, we have seen for the transformers, it is generally a smooth curve comes. Okay, so you have to see for that particular transformer, and also you can use Dirana and these things for the bushing also. You know, and that is just for an additional thing, that you can also use the bushing monitoring through that.
Second question is, sir, apart from after doing dehydration, all things.
We are extremely sorry. Please take it point to point because we are already crossed something 30-40 minutes. Okay. So over to Hardeep, please.
It's really good to see such engaging audience. Well, can we have a round of applause for all our respected speakers, please? Now, ladies and gentlemen, I am thrilled to share some exciting news. But already, I think Patnaik sir has shared something about that. But right now, we will be conducting a lucky draw. And for that, our volunteers will be distributing some slips over which some certain numbers would be mentioned. So what you have to do is you have to keep that slip with you. And once we are at the conclusion of the conference, we will be giving 5 participants who have attended the event a chance to win. So it would be exciting and a fun too. So yeah, I hope everyone is looking forward to it.
Keep your lucky coupon with you. Otherwise, it may be missed out, means you may be also not getting that into the competition. Okay, anyway, so Hadi, please.
We'll be having lunch after this. What? Okay. So right now we'll be having felicitations for our respected speakers. I would request Mr. Patnaik sir to please present the award to sir. And now I request sir to please forward the present. Okay. अभी अनाउंस कर दिया लकी ड्रॉ का हो गया दिन लंच बोल दे Make sure you keep these slips with you safe. So we'll be reconvening after the networking lunch to continue this engaging conference.
Anyone not getting that lucky coupon, please don't move. Other those who have already got can join for the launch. In between also, I do say that how was the session number 2? It was absolutely okay, but question is that again the same thing of a paucity of time. Whenever it happens to be the kind of session goes in a very correct manner, because the two stalwarts were there here and addressing the house, and we were actually interrupting them. We were feeling very sorry note, but still the situation demands for to make a halt to them. But still it was of really interesting. And I will just make another announcement. After the lunch, you will be again finding the other national repute figures on the dais. So please join for that. It will be really interesting. Today's day, you please extend to us. Your day is for us. So that actually I can simply to say. So definitely, I believe the all few Spark members are there. So those Spark members definitely do feel the way we address you. So please join for the networking launch. Thank you. It is 2:05, so 2:50 we will be assembled here. 2:50.
So at 2:50 we'll be assembling here again.
No, sorry. Yes, 2:50. 2:50. We will be meeting here at 2:50.
also to know, and you cannot remember also. You get it. First of all, session chair is Kanti Prasad. मेरा नाम तो खुदा करते हैं, तो कांति प्रसाद. Session chair is Kanti Prasad. Session number 3.
Session number 3 will also be there.
Session number 2. Session number 2 done. Session number 3 done.
Session number 3 is not mentioned here.
There, no?
जो भी बोल रहा है नहीं बोल रहा है. हेलो हेलो
फोन करो सबको.
Hello, hello, check, check, hello, 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 hello. Hello, hello, check, 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 1, 2, 3. Hello, 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 check, check, hello, hello. Hello, check, check, 1, 2, 3. Hello, 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 check, check, hello. Hello, 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 check, check, hello. Hello, check. Hello, hello, hello. Hello, hello, check, check, hello. Hello, 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 check, 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 1, 2, 3. Hello, 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 check, check, check. Hello, 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 check, check, hello. hello, 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 check, check, hello, hello.
अबे तेरी कसम तू यहाँ चेक करवा रहा है और
Hello, 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 hello. Hello, 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 check, 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 hello, 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 check, 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 hello, 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 check, check, hello, hello.
हाँ तो रही आवाज हैं
वहीं डाल दे, दो कॉर्डलेस में लगा दे, ये कॉर्डलेस करा दो, बंद कर, उसे बंद कर। ये बंद है, जब भी फ्रीक्वेंसी दिखा रहा है, 770 अब ये बंद है, ये भी बंद है और ये भी बंद है, पर तब भी दिखा रहा है ये फ्रीक्वेंसी। वायर वाला डाल दे, वायर वाला एक और डाल दे, वायर नहीं है, नहीं है भाई, वायर क्या करेगा, माइक म्यूट नहीं कर रखे। हेलो हेलो।
Let's start. बोला मैंने. Can we start? So let us wait for 2 more minutes. Kanti Prasad sir is here? Okay. I hope everyone relished their lunch and has returned with renewed vigor and enthusiasm. So I would like to call on stage Sir Kanti Prasad for taking over. Can we have a huge round of applause for Kanti Prasad sir? As we are continuing the conference, so I would like to call on stage Dr. Rajesh Arora sir. I would request Mr. Shyam Ravindran, Sonal Instruments India Private Limited, to please come over on the stage. Okay. I would request Mr. Pranay to please come over on the stage. So do I have to announce these also? Team Eason. I would request Team Eason and MR to please join us on the stage. Now I would like to request Team Altanova to please join us on stage. That's all. Now I would request Mr. Patnaik sir to please take over.
Okay, so good afternoon. It was a nice arrangement. Delicious lunch was there, and without delicious lunch and managing the after lunch session was a bit difficult. But the way you have expressed your interest for the last two sessions we conducted, I think it will not be difficult for us to proceed ahead. At this point of time, all are the stalwarts there on the dais. They are of all national repute. So you will be listening them. It will be really again the kind of interesting session. So with this, we'll proceed. First of all, the first paper to be read out by Dr. Rajesh Arora. He is well-known national repute. So please on the dais.
Yes, text it. Should I start? Good afternoon. I am here to talk about very important topic of DGA. Everyone know in the utility it is very important topic to discuss. It is important, it is related to transformer. Even you talk in your life, DJ is quite important. Decide what you want to do, set your goal, just go and achieve. That is the DG of your life. Now time to talk about the DG of transformer. In the present era, no utility can afford downtime, non-availability, loss of reliability, loss of assets, and above all the safety aspects. To take care of all these aspects I have already explained, you have to perform a test that is called DGA, Dissolved Gas Analysis. I am here to discuss the important significance, implementation, identification of fault with that. It is identification, measurement, and interpretation of the gases generated during the faults in the transformer. Because the transformer has mineral oil that is basically composed of chain of CH, carbon, hydrogen, CH, CH2, CH3. When the session, the breakage of that chain happens, there is the generations of some gases like CO, CO2, methane, ethane, ethylene, acetylene. And out of these gases we have to interpret. How well we interpret, that depends. Because the final action to be taken after interpretation depends on the quality of interpretation you have already made. DGA is nothing but it is SADI QAI. It starts with a sample. Then you have to do the extractions, you have to do detection, identification, quantification. You have to do the analysis of the data you have. You have to interpret it. You have to identify the gases, identify the fault, and finally you have to take action. That is the actual meaning of TGA. These are the gases I already explained, generated during faults in the transformer. How these gases are generated? There are 4 regions because of that gases are generated in the transformer. It may be the decomposition of oil insulation, decomposition of cellulosic insulation, stray gassing of oil and other sources. Other sources means some gases are generated during the manufacturing process due to welding and other activity of manufacturing. What are the basic purpose of DGA I am talking about? Includes basic risk assessment. You have to check the deterioration and monitoring of abnormality. You have to detect it. Quality assurance matrix. You have to identify the fault type, and you have to do the in-service tripping analysis of your system. To do that thing, the first and foremost thing you require is the sample of that DGA. We are worried about our health, and health checkup start with blood sample. When it comes to testings of your transformer, it comes with a sampling of oil from your transformer. These are very basic steps towards getting the knowledge about the incipient fault within your system. Because no utility can avoid outage, failure of this big transformer of paramount importance. This is the AIDQMI of gases from the sample. Extraction, identification, detection, measurement and quantification that we are doing at lab. Apart from whatever I have discussed in the lab, online monitoring of gases is also done by utility to get the information about the gases generated on real-time basis. This is about generations of gases, and now I am coming to the important point. What we interpret, what my IS, IEEE, IEC says, we have to focus on these 6 types of fault. Very first fault is PD, then D1, D2, T1, T2 and T3. PD means partial discharge of very low intensity. T1 thermal fault, T2 the thermal fault, T3 the thermal fault more than 700 degree, and D1 the discharge of low energy, and D2 the discharge of high energy. We have category where we have given 2 categories of fault in the transformer, thermal and electrical. When it is thermal, it is denoted by T1, T2 and T3. When it is related to electricity, it starts with PD, D1 and D2. These are the basic fundamental things you have to keep in mind when it comes to DGA. These are the main zone described by IEEE C57-104 2019, 2008, IC 60599, IS 10593, and you have to take your sample based on IS 9434 only. Apart from the 6th zone I have already described in the new IEEE C57-104 2019, they have come out with this additional 5 fault classes, that is T3H. H is a basically word taken from French. In French, H means hole, hole means oil. That means thermal fault in oil. DT means mixtures of your thermal and electric fault. ND means not detected. S means stray gassing. C means carbonization because of overheating. And O is the overheating more than 250 degrees Celsius. This picture depicts the various temperature, various fault and associated temperature. whenever there is a session or breakage of the chain of oil because of fault or heating or partial discharge of any reasons, it is associated with temperature. Along with temperature is talk about the fault associated with that temperature emerging with that particular fault. These pictures depict that thing. Second way of getting the knowledge is that pictures, the second alternate pictures I have taken from IEEE C57104. Coming to the different methods of analysis, first method, very popular method, the key gases method, where we talk about the thermal fault, thermal oil and cellulose fault, high energy, arcing, low energy, partial discharge. Then comes the Dorenenberg method. Basically, there are 5 ratios to be used everywhere to get the analysis. Ratio number 1, 2, 3, 4, 5. And out of 5, first 4 ratios are used by Dorenenberg. Then comes your Roger ratio. Roger ratio use 3 ratios only, that is 2, 1 and 5, to give suggestion about the fault we are expecting. Then comes the dual triangle method. In dual triangle, 3 gases are used. There are 3 dual triangle 1, dual triangle 4, dual triangle 5. We have to start with the dual triangle number 1. If we are not getting, we feel that the fault lies in low energy zone, we should adopt dual triangle 4. If we feel that fault is in the higher zone, we have to skip to dual triangle number 5. Then comes dual pentagon method. Again, it has 2 methods, 1 and 2. That if you look at the difference between the 2, the difference is that your main overheating, and I can show that. In this dual triangle number 1, there are 5 gases. We are talking about state D1, D2, D3, D2 and D1. Then the IC ratio methods comes in the picture after that. We are using again 3 ratio. Again, these ratios are 2, ratio number 2, ratio number 1, ratio number 5 of the 5 ratio I have already described. Now come the latest concern. The concern is that we know these methods are to be used. I have seen the reports of many utility. I have seen the reports given by central testing agencies. Still they are using IEEE C57-2008. Some testing agencies are using latest IEC 60599 or IS 10593, but they are giving the quantity of gases being measured. There is no as such interpretation. And the most important thing, the latest IEC 57104-2019 has ruled out, has omitted all the previous methods, and they have come out with these 3 stages: DGA stage 1, DGA stage 2 and DGA stage 3. To understand that thing, they have given one chart. These are not being used by any utility, I am sure about it, because it seems to be complex. This is table number 1 of IC C57-104-2019. Table number 2, 3 and 4 we have to use to come to reach a conclusion. This is double triangle 4, this is double triangle 5, I have already explained. That is again in that 2019 version. If you look at the comparison of double pentagon 1 and 2, T1 has been replaced by O, overheating, and T2 replaced by carbonization, and T3 has been replaced by T3H. That means high energy fault, temperature fault in oil only. My concern I have already explained. We are still using the previous version. That should not be done. Utility have to take a call and come up with the new versions available, and we have to get the new results. And the finally takeaway, transformer being the costliest and important equipment of system needs special monitoring and attention. Utilities should come forward to adopt new tools available to reduce the downtime, We have to unlearn the bad practices. We have to relearn the good practices we have already learned, and we have to learn the new practices available. Last but not the least, let's make India free of fire, failure, and accident. And to do that thing, I always end up my session with a pledge. I request everyone to stand up for a minute and take a pledge with me to make my India, my nation, free of accidents. Please stand up. I take a pledge. I will not neglect any safety rules and regulations, and I will also make people aware about the importance of safety. Whosoever comes in my contact, and I will try my level best, make my India, my nation, my country, this globe, free of failures, accidents, because of negligence of rules and regulations. Thank you, everyone. Thanks a lot with that. Thank you.
Yeah, actually it was again the kind of things, the brush up, because the morning session we had, and it is the extended version of the morning session, Manjusha ma'am, what she told. So right now we'll be coming to Ishan MR. Please just come up the dais and to have the discussion relating your paper. Ishan MR, please.
Okay. Okay. Good afternoon, everyone. This is Nitin from Eason MR Tap Changes Private Limited. So, can we just have a presentation, please? नहीं पेन ड्राइव में तो नहीं है हाँ जी हाँ जी
So again, there was some network glitch, I mean, not getting open. So we'll be asking for the next Shyam sir. Shyam Ravindran, please. Now is Sonal instrument. Next is Sonal instrument, you put it.
Good afternoon, everyone. Hope I'm audible. So today my presentation will be, since there is 11-12 minutes, my presentation will try to touch two main topics. One is related to safety and second is related to power quality and harmonics. I am extremely privileged to have this opportunity to have a presentation about safety in front of Dr. Rajesh Arora, the safety man of India. And I also want to thank Mr. Patnaik before I present my session for considering my paper, and ETS for having this opportunity. So good afternoon, my name is Shyam Ravindran, and my presentation, the agenda of the, as I mentioned, this will be my agenda. In the interest of time, I will start with my preliminary question. I'll touch safety very quickly and I'll get into the power quality topic immediately. The simple question we have is our electrical network safe? We have eminent personalities here where we are working an extremely safe environment on the high voltage and the medium voltage. But when we look into the number of fatalities or the accidents across the country, the majority of the fatalities happens on the low voltage side. Having said that, I manufacture all these electrical testing equipments, and I'm not very proud to say, but there was a fire accident even in the apartments where I reside. So unless and until we make the entire ecosystem safe, I will be, I mean, we can come to a conclusion that it is important to make the entire ecosystem safe. Having with an analogy, is electrical network really safe? Consider an example of an airline industry. When was a recent fire accident or anything related to a fatality that happened in an airline industry? I give that analogy simply for us to come to an understanding that yes, it is possible to apply all the safety regulation in every industry. Now, before we get into the standards, there was one international standard, 60364, and we had two, beautiful Indian standards, 7323043. You can very well look into it. That is, in 2019 itself, there was a fourth revision on related to wiring, and in 2018 there was a second revision related to earthing. In both the standards, this list of testings were mentioned. These are the 10 testings which were mandated over the past 3 decades, that these are the testings that should be mandated. This is also taken into the reference, the recent references of National Electrical Code, which was released in the month of January 2023. So these are the 10 tests. If I get into the, I'll directly get into the test number E, automatic disconnection of supply. Very simply, if there is a fire accident, if there is an electrical short circuit, if there is anything related to an electrical issue, we expect that the protective devices should trip. That is the primary reason. If this is the electrical circuit, if there is a fault current, we expect that in our electrical design, we have some kind of a protective devices. We can call an RCD or an MCB. We have some kind of a protective devices. It must trip. That is the automatic disconnection of supply from the network. So this is the equivalent circuit. We all understand from this simple circuit that yes, this is how the electrical system should work. What we were doing until today was, this was a regulation in India until January 2023. Please mind, until January 2023, the regulation mentioned limit earth resistance sufficiently low. Henceforth, we are maintaining our earth pit value everywhere, starting from a petrol station to 765 kV switchyard locations. We were maintaining the earth resistance value sufficiently low so that the fault current will get into the earth. But actually, recently I was a part of one WhatsApp group. I saw one image into that. They've connected a DG, taken a screwdriver, and took a sand bowl and made a screwdriver into the ground. This is the type of grounding system that has been designed also. It was very funny, it was hard to believe, but that was a fact also in a very important prominent location in Bombay. This is how we have the design network currently. But please note that one point, even if you have a proper grounding, the fault current is not going to disappear into the ground, or it is not going to vanish. Whatever is the network that we have, the fault current is supposed to travel to the neutral. And we have the equivalent circuit here. The protective devices are supposed to trip. So the regulation got updated very recently. Earth fault loop impedance shall be maintained sufficiently low. So the entire network value, you have to measure your earth fault loop impedance to ensure that you have a safe automatic disconnection of supply. And there was another testing which is related to step and touch voltage test. To my knowledge, we are not following this in India. This is one of the 10 tests which is mandated as it must be practiced for the past 3 decades. This is CA regulation update. Last Friday, there was, we are talking about emerging technology, but please note this is a mandate which was released from CA related to safety. Last Friday, on 16th of June, this was released. So 3 points were mentioned about fault loop impedance. It is made as an obligation. So I thought I will emphasize this particular point of earth fault loop impedance. One, yes, you have to maintain earth fault loop impedance. Second, you have to maintain the record of earth fault loop impedance. Third, if you have multiple sources, let's say you have a DG source as well as you have a supply from an electrical service provider, you need to maintain the fault loop impedance value separately. This is how the tabulation works in CA also. Very simple, we all understand. If you know what is the prospective short circuit current of your circuit, you will be able to calculate what is the impedance value because you know the voltage. So the only element what we will be focusing on is what is the prospective short circuit current. This is how the displays are displayed in the testing equipment. Of course, we manufacture this testing equipment and we get the what is the impedance value. So this is in practice with us for almost 3 decades. This is the equipment that we manufacture, which includes all the testings in one single equipment. We call it as a multifunction test kit. This is a very quick update about safety. In the interest of time, I'll get into the next topic very quickly, which is power quality. The reason why I'm touching power quality and safety together is, in the previous presentation, I got a question, okay, what about the harmonic current? How is your tripping devices going to trip in terms of a harmonic current? So I thought, yes, there is a correlation between power quality and electrical safety. So here, this is the definition I've taken from NEC 23 as well as IEEE 519. This is the definition, which is very simple. You have a device which is connected to the network. The power quality means that you have to ground the equipment properly and also ensure that the operation of these devices are as per the intended manner of that particular device. And the reason why I tried to connect these two topics after the question from the previous session was, this is a guideline from CEA. The first point, this is related to the guideline, you can find it from CEA in terms of grid connected supply, wherever you have a grid connected. So this is a screenshot I've taken for EV connected area. The first point is saying the applicant, whoever is applicant on that node, he has to ensure that there is a disconnection of supply. The third point comes out, the monitoring of power quality. So that emphasis is already there given, that first ensure that there is a safety parameter that is followed. Then you have to monitor your power quality parameters. Now power quality itself is, to be very frank, and you all understand, it itself is a 2-day topic. What is power quality and how do we monitor, measure for different type of networks, what is the solution that you can bring it for power quality. But yes, there is an emphasis that you have to go for a continuous monitoring of power quality as per 61004-30. This is a screenshot taken from a CA guideline. This is our online power quality monitoring devices. So the next, the topic is, in the first session today, there was an important point. How do we mitigate the harmonics or harmonic related problems so that the distribution transformer doesn't get affected? So yes, you have to maintain your power quality parameters within the stipulated limits. The stipulated limits is also very well defined in CA, that this is the limit of harmonics, this is the limit of harmonics for voltage, and this is the limit of harmonics for current. Plus, in NEC 23, in section 20, they have given a clear guidelines also. Usually NEC is not a product recommending standard, but here they have recommended that you can consider a passive filter and an active harmonic filter, which is a guideline given from the government itself, that you can consider these two solutions for improvement of power quality. So they have considered multiple solutions. This is a screenshot taken again from NEC 23. The effect of harmonics, among this, active harmonic filter offers a flexible solution. This is the conclusion they have taken in NEC 23 standard itself. So we have worked out in different industries. For example, in injection molding, we identified what was the harmonics, and we have mitigated the harmonics using active harmonic filters. Welding loads, which was very, very tricky. People who understand power quality can understand it is very difficult to bring the power quality parameters within the limit in a welding load. The third case is foundry. This itself is a very interesting example because foundry are working on higher voltage level. When you connect an active harmonic filter directly to the higher voltage level, you need to have a special rating transformer. This transformer will be pumping in the negative harmonic current. So we say that the harmonics are bad to the transformers, but however, in terms of foundry, we have to design a special K-rated transformer so that the negative harmonic current is being pumped in to bring the harmonics as per the CA guideline of less than 5%. In garment industry, and in cold storage. But I didn't get deep into the other two examples is simply because if we have a three-phase load, the solution seems much more simpler than compared to the welding loads as well as higher rated voltage areas. There is a lot of emphasis on PQ and EV charging, but I have a question shared by Patnaik sir about EV charging. So I will answer this PQ and EV charging in my next slides. So finally about my company, we are a manufacturing company with over 3 decades of experience, and we operate in the entire areas of transmission, distribution, as well as from the industrial area. So with this, I thank you all for your time, and if you have any, I'll try to answer the questions. If you have any other questions, I'll be waiting outside to answer. Thank you so much.
Hello everyone, this is Nitin from ESN Tap Changers Private Limited. So I'm here to explain about our NFPS system, and we have 3 major products. OLTC we are manufacturing from past 50 years, self-dehydrating breathers, which are commonly known as maintenance-free breathers, and nitrogen fire protection system. So I'll be taking forward all of you for NFPS system. So first of all, let's understand the reason behind the transformer fires. Not all the faults result into fire, but there are certain cases, means there is a chronological event which eventually results into fire. The first thing is a fault. It may be due to insulation compromise, it may be due to moisture, as all the learned people have made us understand that due to moisture, failure can happen. Due to any manufacturing defect, failure can happen. So fault. Then after that, in electrical system, if there is any fault, it will result into an arc. This is true at our home, and this is true at substation also. Suppose a line met with ground, it will result into an arc. So the second step will be arc. In case of power transformer, the release of energy could go to 15 to 20 megajoules. Then whenever the arc is happening inside the oil-filled transformer, the arc will try to burn the oil, which as we all know, Rajesh sir has also told, it can be found out in the form of DGA, which we call as abnormal DGA. Now, when the oil burns, especially in case of arc, there are 2 nasty gases which used to come up as per dual, triangle and everything, like all the big studies, whatever has happened as of now. That is hydrogen and acetylene. So these 2 nasty gases, what they do is, for the arc to sustain inside the transformer, they used to form a cloud. They used to form a bubble, inside which the arc sustains in the transformer. Then, when the concentration of hydrogen and C2H2, that's why it was said that the concentration, the ratio need to be seen first before continuing the equipment in service. So when the concentration of these gases increases, we have a perfect recipe. We have combustible gases, we have an arc which can become a source of fire, and eventually it results into the tank blast or rupture. So this is the complete, the chronology of having a blast into the transformer or the fire into the transformer. So what we understood that the NFPS should be smart enough to capture at any point of time here. So the arcing is the main, the event. After the fault, the arcing is the very next event. So we introduced our our NFPS with arc sensors. So what it does is that whenever there is a fault inside the transformer, the arc will result into a light, and arc sensor will be sensing that light, and that light once that light comes on the arc sensor, it will trip the transformer. So we have the arc sensor as the primary protection. Now why arc sensor? Because just now the fault has started and arc has happened. So our arc sensors are are calibrable from 100 lux to 1000 lux. We recommend to keep it at 100 lux. The current lighting here is 200 lux. So if a transformer, if you see from inside, if you can imagine the transformer from inside, it is completely dark. And suppose a light comes with 100 lux of intensity, that means it is a fault. Because it is supposed to be dark inside. Even if you say partial discharge, it will be sparks which will not be even visible when you say 100 PC as per the latest IEC guideline. So whenever there is a light of 100 lux inside the transformer, that means, boss, it is a fault. And what arc sensor will do? It will immediately trip the transformer. Now the arc sensor is at par, or I would say better, as per the tested data. It is even better than differential and other relays, because the arc sensor will itself be having a pickup time of 1 millisecond, and the arc relay associated with the arc sensor will be giving the trip command to the master circuit breaker within 15 milliseconds. So 15 to 16 milliseconds you will be having a trip command at your circuit breaker, means your master panel. So the arc sensor will not only give you the protection from the damages, but even it will give you the information from where the fault has actually started. A transformer, suppose a capacity of 315 MVA 400 kV, it will be equipped with 8 different sensors, 8 arc sensors. Every arc sensor will be working in parallel. So whenever there is a fault, arc sensor will get activated. S1 to S8 you can give a nomenclature to it. Suppose S6, which was installed in HV side, say U phase. If it gets activated, immediately your operations guy will give you a call, sir, arc sensor got activated, the arc sensor S1, S7 has got activated. Immediately you will get the idea that the fault has started from the U phase on the HV side. So that is one of the benefit. That still means, like for all the manufacturers who are having 5 years of manufacturing guarantee, warranty, once the transformer is filled, you have to get it repaired at your cost. But suppose it is a costly failure, you need to understand, means the RCA is must. What has resulted into the failure? Suppose it is a design mistake, suppose if it is a manufacturing mistake, it is must to understand and to know what is the reason behind the failure. Suppose the same manufacturer has given you 10 transformers. So within that particular time, if the proper RCA can be done, so this is very essential. Now, why arc sensor is so important? Because in utility boards, for 3 months, they are not, means the period is 3 months to take DGA samples. So it becomes next to impossible to predict what happens, what will happen tomorrow. At any point of time, transformer can fail. So for 3 months, it is a very big time until unless you are having an online DJ monitor, and for which the data is completely continuously monitored. So that's why arc sensor is important, because every now and then we see that sir शाम तक तो सब सही था, अचानक रात में 12 बजे ट्रांसफार्मर फेल हो गया. So that sort of heart attack news, and so we can avoid with arc sensors all those things. Now arc sensor is also when we are isolating the transformer so quickly. So nitrogen purging is not important right now. we don't purge nitrogen. We give it as a chance for transformer to be safeguarded from the fire itself. Suppose if the fire means I'm not allowing transformer to come to the point number 3, point number 4, point number 5. So the point number 5 is somewhere the transformer is going to get blasted or it is going to get catch fire. So I'm just trying to prevent the transformer at the second stage of the process itself. So that's why arc sensor is very important. So this is just like, I'll just skip over to this. 3 stages of protection, what I have told you. The first one is the sense the arc can trip the transformer. That is the best protection what you can have in the electrical system, just to isolate the system. The second one is, if any electrical relay or any mechanical relay operates along with the arc sensor, that means it is a clear-cut indication that there is an arc inside the transformer, and along with that, any electrical relay or any mechanical relay, if it is reflecting the same, like buckles, PRV, if it is getting activated, then it means that something is wrong and you have to cool down the transformer, because at certain place or some place in the transformer, you are having a problem. So initially from the arc sensor, you will get to know the location, and if any, on the other hand, if any other electrical or mechanical relay gets activated, then we will purge the nitrogen. So in the first stage, we are trying to not waste the resources. Why to take out the 10 or 12% oil, which as we recommend, mostly we recommend 12% oil, and why to purge the nitrogen? Then again, you have to refilter the oil, you have to redo everything. So we always try not to waste the resources at the first stage. We try to protect your transformer, valuable transformer, in as it is condition. Second one, when we feel that there could be something wrong because buckles or PRV gets activated or any electrical relay, then we say that okay, we will now purge the nitrogen and we will take down the 10% oil. Now these arc sensors are very important as well for another aspect. The another aspect is bushing fires. We all have heard bushing fires. Bushing got blasted. If you see clarification from any bushing manufacturer, they will say that the turret part, which is the BCT part of the bushing, that is having the least amount of insulation. That is the worst place to have a fault. And that is the most prominent place from where the bushing starts to fail. And when it blasts, suppose if it is a OIP bushing with porcelain and it is getting blasted, then that is a repercussion. What the failure inside has happened in the bushing, that's why we used to use shield during while connecting the transformer leads of winding with that bushing. So this arc sensor also takes care of that bushing failure, so that in the starting itself, when the fault is happening, in the starting itself, it can contain that fault, so that your external fire can be avoided. Suppose if it is not avoided, then we have a resort that we put LHD cable, which is linear heat detector cable, and it is a recommended method of identifying fire as per CEA manual 2010 for all the electrical installations. So we used to have linear heat detector cable which are laid down on the transformer body, and in the event of any external fire resulting from bushing, that gets activated, and in this case also the nitrogen will get purged and 10% oil will be removed. So this is just like a small logic what we give along with we propose, and by default the logic can always be changed. The logic can be made more strict and more if we say the approach part, it can always be changed. So this is how the overview of NFPS when it is installed. We will be having a control box, we will be having a switchyard cubicle, drain wall assembly, and the arc sensors will be installed at the top of the tank, because whenever arc flash will happen, since the transformer is painted inside, with white color, and that is a reflective color. So the total internal reflection, what we used to learn in 10th class, still working for us. And that whenever there will be an arc, so the arc will be scattered and final destination will be the top. So the top is the best place to put arc sensor. However, the arc sensors can be installed at the side of the transformer. If we have, if it is the case of a retrofit, then we can put it on the inspection windows. Then we have a TCIV, that is a transformer conservator valve, because the moment you have drained the oil and you are purging the nitrogen, you don't want that conservator oil should come to the transformer oil, because because this is a case of fire or this is a case of emergency. So you want maximum fluid to be kept away. So the TCIV is a mechanical kind of a valve. It operates on the flow. So the moment that the flow reaches 60 liters per minute, the flap will close and it will close down the oil supply from conservator to transformer. So this is how, like, if any arc happens inside, so this is how the arc sensor will get activated, or suppose your beacons get activated. So this will operate. So this is like auto extinguishing mode when linear heat detector gets activated. So the drain valve will open and shutter valve will close and nitrogen injection will start. This is how the LHD cable looks like. This is how we used to lay down the entire cable on the transformer. Means we used to cover the turret area where the bushings are installed. So, like, we can say a slight difference with the conventional technology and this thing. So we, as I told you, that we have given two-stage protection, three-stage protection basically, two-stage protection for the prevention mode. Secondly, our system is equipped with SmartTech, which is self-monitoring and reporting technique, and it is having an event logger. Because tomorrow you don't want any firefighting system to malfunction, and you must know that your system is healthy. So it is much better that your system will tell you that there is some problem in the system. So that's why we have SmartTech, which will monitor all the sensors, which will monitor all the relays, and it will give you real-time report. If there is any fault in the system, it will enunciate the system that certain relay is having a problem or certain sensor is having a problem. So as I told you that the damage is less because of the arc sensor, so the repair time will be less, the repair cost will be less, downtime will be less. Even for 5 years, it is beneficial for manufacturers, and after 5 years, it is beneficial to OEM, to the end users. So arc sensor is highly reliable. It is certified for 155 degree for 16 hours. We have got it tested. It is tested by Intertech. It is having a tough life of 15 years. The expected life is 15 years. For a sensor, it is good. The testing range, the range is 4.5 meters. It is tested in the factory. We have the required arrangement for that. It is having a complete metal body. So accidentally what happens, that whenever people are standing up on the transformer for routine maintenance, if something delicate is there and accidentally they put foot on that, so it gets damaged. So it is completely metal body. You can stand on it. Nothing will go wrong.
Please sum up.
Yeah. So this is how the arc sensors will be installed. This is a 400 kV 125 MVA reactor. So 5 sensors were there, so that it was completely monitoring the entire active part which was carrying the current. So we have a live arc sensing facility. These are some retrofit installation. This is how we can utilize your existing inspection window in transformers, and we can install the arc sensors. We have installed One of the European utilities there, we have so of 600 MVA transformer, 400 kV, and these are some general approvals. This is just something, rumors are costly. Nowadays, government also says rumors are very costly. So please get in touch for any additional detail, and thank you for the great audience. It was a pleasure to give a presentation like this.
It was a really interesting kind of things, and even everything got concluded before half a minute. So next we will having to go another topic which is really interesting again. Better operation and live by analytics, BOLA. So now transformer will speak to you. BOLA means transformer. अभी बात करेंगे आपके साथ.
Forward, excuse me. Okay, good afternoon everyone. This is Pranay from Crips Power Components Limited, and basically we are part of Crips Group, and today I'm going to discuss you about the development which we have made on the transformer monitoring solution in the name of BOLA device. So it's an abbreviation for Better Operation and Live by Analytics. So basically, like what Sir has told, BOLA means to speak. So after installing this device, your transformer or any electrical machine will speak out in case of any abnormalities comes up. So just to brief you about what Crips is into, like Crips is into electrical and metal handling equipment since last 30 years, and we are the leading manufacturing and core supplying company in India with 50,000 metric tons annually we are producing CR steel lamination. We have total 9 manufacturing factories across India which into manufacturing of transformer core lamination, in manufacturing of power and distribution transformers, transformer tanks, and lifting sling sets. And also we into EPC contracting. Toyota Shushu, which is a part of Toyota Motors, is also a strategic partners. So I'm going to discuss about the topic related to transformer distribution, transformer failure. And basically it's a big challenge for all utilities. And we are going to discuss about how to overcome such big challenges. So there are approximately 1.3 crores distribution transformer installed in pan-India, and approximately overall 11 to 12% of distribution transformer fails every year. And the reason is basically they are not able to maintain the transformer properly because of insufficient manpower, or maybe they are the installation of transformer are in remote areas. And apart from the natural disaster, there are different main reasons for transformer failure, like the overloading of transformer, insufficient cooling, load unbalancing, and low oil level, which are these also basically main reasons for transformer. So the next question comes, how to overcome such failures. So based on this, we visit some of the utilities and private industries who are having multiple transformers, and what we found the main issue was the current monitoring practice. So these are the current monitoring practice which we have identified, and basically like since they are having multiple transformers, they are not able to monitor the transformer regularly because they have been located in remote areas, and also they are doing manual recording of all the parameters as per the schedules, and also they do maintenance of the transformer as per schedules without understanding whether it is required or not. And obviously there are there are demerits for current monitoring practice, like every important parameters cannot be monitored. There is no transparency and accuracy. Maintenance based on real-time on condition of the transformers, and the data which has been collected does not give any corrective actions to be taken. And the right information is not available with the decision makers, which eventually lead us into sudden and catastrophic failure of the transformers. So, considering these demerits, we have made a solution which will eliminate all the problems faced by the with the maintenance team, and thus it will make the transformer smart. And based on that, I will skip this video. So based on that, we have developed a solution in the name of BOLA device. It's a better operational life analytics, which I inform you. Basically, it's an IoT-based low-cost monitoring solution for distribution transformers, and even for it can be installed on any electrical machines and energy meters, which will monitor vital parameters of the transformer. That is, electrical and physical parameters, both. So basically, it's a retrofit device which can be installed on any transformer, any rating of the transformer, or even on any electrical machines or energy meters. And this will help us to monitor the vital parameters from transformers remotely from any location on your mobile as well as on your desktop. And in case of any abnormalities comes up, obviously it will send alert notification and email in the form of email as well as on SMS to the allocated people. And obviously such type of proactive monitoring will change the current schedule-based maintenance into condition-based maintenance of the transformers. So these are the parameters which we are monitoring. Like we are monitoring all the physical parameters of transformers, basically temperature of the transformers, the oil level of the transformers, the tap position indications, and also the electrical parameters, the parameters which are based on the calculation of current, voltage, and power factor. So apart from, we are not only monitoring, we are also doing the analysis part also. And these are the analysis we are doing. We are showing the health index of the transformer based on the parameters which you are monitoring. And we are doing a comparison of load percent of the transformer with respect to the winding temperature, the oil temperature, and also with respect to the ambient temperature of the transformer, which is as per IS 1180 and as IS 2026. We can also show the transformer efficiency analysis, the load unbalancing of the transformers, and also we are showing the relay status, alarm and tripping status of oil temperature indicator, WTI, MOG, Buchholz relay, and PRV. So I would like to show you the architecture basically. So we get the parameters from the sensor which we install on the transformer, and it has been fetched to the cloud server. We are having Amazon server on Amazon through our BOLA device, which is basically a SIM-based and GSM-based model. And we have installed an application and database on the cloud server, by which you will be able to monitor all the vital parameters of the transformer remotely from any location and any time on your mobile as well as on a desktop. So we have installed some of the devices in Pan India, and we have just want to show you some of the case study which we have found in some of the utilities. So this is the case study which we did one of the transformer of rating 750 kVA, which is based in located at Silvassa. So you can see from the snapshot of our dashboard, the voltage between R phase to neutral was showing was indicated 285 volts, which is abnormal condition. And this instantaneous alert was sent to the maintenance team via email and SMS format, and they immediately isolated transformer from the power system. So this transformer was sent to our factory at Silvassa, and we opened the transformer, and what we found that there was a insulation puncture in the R phase, and we did the root cause analysis of the transformer, and we found out some of the possible reasons that could be the hotspot generation in the windings, and also it could have decreased the dielectric strength of the oil, and thus it weakened the insulation property of the transformer under abnormal voltage condition. So this is a snapshot of our dashboard, which shows the voltage is working under normal condition after rectification. And here I want to inform you, like since BOLA device proactively monitored the abnormality, it prevented the further damage on the transformer. Basically, in this case, the customer would have to replace the transformer with a new one, And in doing so process, they could have also attracted more rent on the old transformer to overcome the requirement of power supply. And obviously, we know that the lead time to manufacture transformer is 8 weeks for distribution transformers. The second case study which we did in one of the location in Andhra Pradesh, which we did, we installed a device on a small reading transformer that is 63 kVA. So during in a certain period of time, we informed that the customer that the overloading of transformer was there, and immediately that notification was sent to the maintenance team. And as a validation, we sent them monthly report analysis and suggested them to keep the transformer loading up to 70 to 80%. And this is the snapshot of the dashboard, where before informing them about the abnormalities, you can see that the maximum loading of the transformer went to 158%. And after our notification, they maintained transformer in next month for around 68% loading. So this is the same snapshot of the representative of the Ampere also. Last, I would like to show you one of the case studies which we did in one of the transformer. So this is this case study which we did in one of the wind turbine application transformer, where we found that during as soon as the transformer, the winding temperature of the transformer reaches threshold value, as soon as the transformer loading goes above 80%, and as soon as it comes to below 80%, the loading the winding temperature comes to normal condition. You can see it from the snapshot of the boiler dashboard. And these were the observation we sent them as a validation service. We sent them a monthly report analysis, and these were the observation which we sent them. Like the transformer winding temperature went to 92 degrees Celsius. Correspondingly, the oil temperature was 57 degrees Celsius. Loading of the transformer was 87%, and this abnormality, and with the ambient temperature of 34 degrees Celsius. So we send them the monthly report analysis showing these abnormalities, and accordingly the customer took the preventive measures and saved the transformer from premature failure. So obviously this condition, like we can judge there was the underrating of transformer. So these are the installation which we have done on some of the transformers. Like it is a plug and play type installation of a device. It can be installed by any semi-skilled technician. It can be installed on the plinth of the transformer, nearby transformer, or nearby panel room also. Thank you.
या एक्चुअली अभी ट्रांसफार्मर ने बोल लिया, आप लोग सुन लिए, है कि नहीं? So actually there is a great announcement I can say. As per the session number 1, we have already listened 8 speakers. So out of those 8 speakers, there will be 2 best paper award. So kindly just be with us at the time of award winning session. We will be just rewarding them in that best paper award kind of things. It has already been selected. We will declare also accordingly. And as per the second session and invited session, we have invited speakers and sponsors. We are having also similar kind of 2 awards are there. Kind of best presentation awards are there. Along with galaxy of awards are there also, because the award winning sessions. And every delegates, those are here also, please kindly whether check your that coupon is there with you or not, because that also will be helpful for during the time of a lucky draw and all. So with this, there is a small change in the presentation. Actually, one of our author, he will be speaking on BC. So after that, we will be concluding these sessions. So on BC paper will be read out. I think Mr. Baldev Raj Narang, he will be speaking, and his paper will be something very well informative paper, but not related to the transformer, slightly related. That is actually transformer allied subject. So let's listen to Baldev ji Raj Narang. Please arrange.
Recording in progress. Okay, good. I'm switching on my camera also. Is that good? Okay. Okay. So I can start now. हाँ नहीं PPT नहीं मैं शेयर करूँ. I'll just talk only. Okay. Thank you. Hello.
Baldev ji, you are audible. Please continue.
Yes, sir. Yes, sir. I'll take 1 minute. Yes, sir. Okay, so I'm there now. Good afternoon, everyone. In fact, I was initially required to speak, but later on I found that this platform was mainly for transformers. And I had written my article on a different subject altogether. And that was concerning, in fact, normally I write technical articles, but they are mostly on the subjects which are relevant in the market today, for some reason or the other. So my topic was the grid integration of renewable energy generation plants, because there are problems being faced by these people in the grid integration, and there are certain norms being made for that. So I'll talk about that also. But first, I will congratulate Electrical Mirror and this platform ETES for organizing such a beautiful, you can say, physical event. And I'm not able to participate physically. I was always thinking of coming, but due to some other engagements, I had to cancel that physical visit. So I am talking to you from here, and I thank you for this opportunity being given to me. So as regards transformers, I'll just say a few words about the transformers, because this event is mainly for the transformers. So it will not be good if I don't talk about the transformers. So, and we don't deal with regular or standard transformers as such. Our involvement with the transformers is in some different ways. We are into reactive power and power quality management. And we give solutions for harmonic mitigation, for power factor correction, because these days there are tariff structure changes taking place, and this subject has become very, very relevant. And almost all bulk consumers of electricity, they need these systems to have the optimum billing. The billing is based on now power factor basically. It is changed over to kVAH billing. Earlier there used to be incentives on power factor, but now it is straight away on kVAH. So power factor is inherently built into that tariff structure. So everybody is having these solutions. Nobody can afford to run their plant without these systems. So that is one thing. And then regarding the transformers I was talking, the effect of harmonics is one of the subject where we deal with the transformers also. So in utilities, we'll find that there are transformers, distribution transformers, and the failure of these transformers has increased in recent past. And the reasons, I don't know, they do some root cause analysis and find some reasons. Maybe the protections did not operate, or the maintenance was not there, or earthing was not there, or something like that they find out. But one of the major reasons which is overlooked and nobody talks about that is the effect of harmonics on these transformers. These transformers, besides taking the normal load, they are taking the harmonic currents also. More than 70% harmonics, the loads are having non-linear loads are there, and they all generate harmonics. And there are no norms as such today, no regulations today to control the harmonics within IEEE 519 limits, except for Tamil Nadu, which started these things. And then Maharashtra also is thinking to implement that. But so far, everybody is free and they are not controlling the harmonics. So all these harmonics, they go back to the grid and they become a load on the distribution transformers. And these transformers have been failing. And this is one of the major reasons. So I thought, let me talk about the transformer. One of this point I thought I should raise. Then we use some special transformers also. Mostly, you must be familiar with the transformers which are connected for the load. But we are having transformers, we don't connect any load on that. We have transformers. Recently, we gave two 6 MVA transformers, 3 winding transformers. Secondary was 440 volt and the primary was 33 kV. And only capacitors we connect on that. We do it for only reactive power compensation. Because when we have to do compensation on HT side, and we can use HT capacitors, automation HT, but that is in bulk. Automation is there, but we don't have small banks. The fine control is available on LT side. So what we do is we connect the system on LT side, and then we do the correction on LT, and effect is available throughout the system. So that is one use of the special transformers we are having, and we optimize the cost by using 3 windings, 1 primary and 2 secondaries, or we can have even 3 secondaries also, and we can use on the secondary whatever we want. We can use even STATCOM on that, one of the windings. We can use APFC systems, RTPFC, whatever we want. So that is one use which we are doing for the transformers. And even there is another use, we are using transformers for harmonic mitigation also. Transformer is not doing the harmonic mitigation. In fact, transformer as it is doing some mitigation. Because suppose harmonics are generating on low voltage side, there are some harmonics and they get to some extent mitigated when we see on the HT side. Transformer also acts as a damping item and the harmonics get reduced. But what we do is, especially suppose the harmonics are there on the HT side and we don't have maybe proper solution on HT. HT, the active filters are still not available. Active filters we have got on the LT side, 440 volt up to 480 we have. So what we do is we make a transformer, special transformer. It is not a regular transformer. The size is almost twice for the same capacity or even could be more. Because what we do is we design for a very, very low impedance. Instead of 6 or 7%, we design it for 1% impedance so that the harmonics are allowed to pass through it. It doesn't hamper the flow of harmonics to the HT side. Because we generate anti-harmonic currents. We generate currents which are 180 degree out of phase with the harmonic currents, and then we inject into the system and then we cancel out the harmonics. So that is another use we have for the transformers. And we have given such transformers also at some places. Now there is another new application coming. There are at the fag end of the, you can say, feeders in the grids. The voltages are very, very low. And transformers as such, even if you put a OLTC, it doesn't help because OLTC is not a reactive power source. It only just transforms the voltage from one to the other level, and it only redirects the reactive power flow. It doesn't generate any reactive power flow. So it is having a very limited application. But here we have now a transformer which has come out, which is a very, very, again, low impedance transformer, and that is used at that end, and that helps out in maintaining the voltage levels. So this is still in only experimental stage in India, although overseas some people have been using it. So this is all I thought. First I talked about the transformers. And secondly, now I will talk about the subject which I wanted to talk on this platform, although it was not the relevant platform. But I was told there is no problem. I thought it is emerging technology, means emerging technologies in all the fields, not only on the transformers, but basically this event is mainly for the transformers. So I thought maybe it may not be relevant, but I was told, okay, I can talk about that also. In fact, I will like interactions, some questions from the audience, from the stage and everybody on the reactive power and power quality, harmonics and power factor. If there are any questions, let it be an interactive. I don't want to be on the one side speaking only. And this I will welcome. And I won't take much time also. It is just for a few minutes. I thought I will interact. And then there is another thing. Now I'll come to my subject where there is a challenge today of reactive power, the renewable power generation, integration with the grid. Because earlier we used to have very small renewable power systems. Now they are coming in maybe 100 megawatt, 200 megawatts in that range. And they are overtaking the conventional generating systems like coal and hydel and all. So this thing, addition is going on, but the challenge is nobody has properly felt earlier, and now they are facing, and it is one of the problem is the reactive power control on that. The reactive power support is required whenever we have a renewable plant connected to the grid. Whenever we are adding such big capacities, the voltage control in the grid is very important. The conventional plant, they have good inertia, they have synchronous condensers available, and they have even the generation also. There is a lot of inertia, and even the fields also they can feed to some extent, they can meet the requirements of reactive power voltage control requirements with that. But this renewable generation, they don't have any inbuilt reactive power support. The inverters which are available, they can supply reactive power, but they are designed only for supplying the active power. So what is happening is in last 1 year, there were about 28 isolations of renewable plants. About more than 1,000 megawatt capacity was lost because of this thing. And it happened mainly because the reactive power support required was not available at the right time. And what the people who are concerned with this thing at the ground level, who are doing this integration of renewable with the grid, that is power grid people are there. They in their another division is their Grid India, and then there is the CTUIL, Central Transmission Utility of India Limited. So they conducted some studies, and they found that if the STATCOM is put, the static compensation, maybe that will take care of this problem, because we have conditions like LVRT and HVRT we call. That is low voltage right through and HV high voltage right through. Whenever the capacity power is required, there is a low voltage, and STATCOM can supply instantly within milliseconds. And even the high voltage right through also, when the voltage goes up, you need inductive power. It can supply both inductive as well as capacitive power. So it was thought that maybe we can have a STATCOM and that will solve the problem. But it was a very, very myopic view. It doesn't, in practice, solve the issue. The basic issue, they also found that in one place where there was STATCOM available, but it did not take care of the problem. So what is happening is these conditions arise only when there is a fault in the grid somewhere. And we have to see that the fault is cleared in time. And for that, we have to feed the fault so that we clear it immediately. The relays should operate. So these STATCOMs, they don't have
तो समझ में नहीं आ रहा है, नेटवर्क हमारे पीछे पड़े हैं आज, पहले से शुरू से नेटवर्क ग्लिच होते जाता है.
Hello. Yes. I have connected again. Yes. Sorry. There was a disconnection of the system. Am I audible now?
Yes, sir, you are audible. You are audible.
Okay, so I can restart then. Because I don't know, there was a disruption in the connection. Okay. So I was talking about this thing, that this problem, there are many reasons. I don't think this is the right forum to tell in so depth about this thing. So we had a meeting, because I am also representing EMA Power Quality Division. So I had a meeting with CA who had made this thing mandatory. And we convinced them that this is not the right solution, but it is still not true. People are still finding ways to sort of come out of the issue. Because there is another problem, because when there is a fault condition, the STATCOM itself disconnects. So there is no question of its feeding the system with the required reactive power in time. And it itself is not available during that condition. And the grids at some places which are very weak. And all these disruptions have taken place at the point where the grid is very weak. And the grid weak means the inertia is not there. The conventional plants are far away, maybe 20, 30, 40 kilometers away. And they are not able to take care of the situation. And that is why the problem is coming. So what we need to do is we have to make the grid strong. And suppose we have found a problem at a weak grid location, the same solution cannot work everywhere. At weak grid location, whether it is a capacitor, switch capacitor bank, switch shunt reactor or STATCOM, everything is equally bad. Nothing works there. And if the grid is strong, everything is okay. So the basic thing is that we have to see that the grid strength we have to increase wherever it is weak. And the grid strength, when we are having this renewable generation, the grid strength or the inertia can be increased by having the battery storage. So that is what is now slowly coming into force. We have to have the inverters which are backed up by the batteries. And they can take care of the problem like coal plants and hydel plants and all. So the basic issue we have to look into that is that we have to make the grid strong by battery backup. Or we have to install synchronous condensers. Or the another thing is we have many coal plants where they are not in operation condition. They are, you can say, just stopped because of there are some issues or something. And they are lying idle. So those can be used as synchronous condensers. The part of the system can be used as synchronous condenser. So this is one of the, you can say, easiest solution available. And that's what we have talked to these people also. And we don't have any standard solution. Even if we put, suppose synchronous condensers can be put at these locations and they can solve the problem. But again, these are not the universal solution. We don't need synchronous condensers when the system is already strong, the grid is already strong. There we can have switch capacitor. So we have to find from case to case basis, the things have to be done, and no blanket solution. Nobody, no other country has any blanket regulations like that, that you put STATCOM only. So this was something very odd happening. So I had written article on that, which is there. Maybe it is shared in the platform also. And all of you can go into that. And we have to correct the earlier anomalies also. What has happened is initially nobody was having any enforcement of the reactive power support with these renewable plants. People were putting renewable plants and nobody was having any reactive power in-house support. And there are requirements specified by all the utilities, but no utility was enforcing anything. So we have earlier plants available without any support. So that is the backlog available. We have to clear that backlog also. I had written an article about 7-8 years back that why we are allowing these plants without this reactive power support. So this is one thing that they have to see, that if the system is already very weak, the reactive power, even the conventional is not available in the system, it is going to affect the working. And then even when we are having these new renewable plants, they have also some harmonic generation with them. So those things also we have to design along with the systems, whether it is passive or active. So those solutions have to be given. So basic purpose of this article was that we have to see that we go for a right solution. And we have many large plants already available for connection. They are not being allowed. The capacity is lying idle because the regulations have been made for putting STATCOM. STATCOM, there is not a 0% capability of manufacturing STATCOM at 33 kV level. So everything has to be imported. The cost is enormous. That is another reason. But if it is really going to solve the problem, we can incur that cost. But the problem is that it is neither a solution, and still we are asking people to go for it, and we have to import it. And when we talk of imports, there are solutions available. These systems are available from Europe. They are available from China also. But what will come into India is only the Chinese systems will come because of their competitive cost. The European systems cost maybe 3-4 times of the Chinese systems. So that is another thing, that we will be depending only on the imports. And again, there is no capability available for servicing, maintenance, or anything. So these are certain things because I told I write only on the relevant issues which are coming. So this was one of the very, very important thing which had come. And so I wrote on that. I'm still talking about this with the CA as well as, and I'm going to have a webinar with the CA people. And they will be inviting renewable developers as well as Grid India, Power Grid, and all those people. And we'll have an open discussion. And we'll try to find out from them why they are going for a solution which is not actually a solution. So now I will request, this is all I had written about the article. Maybe you can read it in detail. I have not gone through the each and every sentence. And in reactive power means power factor correction, the tariff structures, or the harmonic mitigation. If there is anything, I will be glad to discuss that.
Okay, so thank you, Baldevji. It was really interesting kind of things, because some of the way people were of a different dimension, they were listening from morning. And right now it was relating to the renewable energy, and which is really interesting, but they are not getting support to you because of their mind is not up in that tune. So definitely it was interesting kind of things. And my small request is there, please put a paper relating to these two in the electrical mirror, so that these things will be reaching to them very perfectly. So with this, our sincere thanks for you. And we are running away actually another 35 minutes away. So we are going and shifting to other session. In between actually this session we just interrupted and gone with you.
Thank you for giving me an opportunity. And I wanted to be very, very brief, but still I think I have taken some time.
No, it happened. Those are the real orator, no? They cannot exactly control themselves, because they will be thinking of that it is something is missing, means they will be thinking that should have to be spelled. Okay, thank you, sir. We will be going for the next session.
Okay, thank you, sir.
Okay. Thank you, sir. Thank you, sir. Thanks a lot.
Okay.
So the last paper with Altonova. So please come. We will be having the greater kind of discussion. Definitely, again, all people will be again to the tune. Don't worry.
Good afternoon, everyone. My name is Fazal Masood from Dover Altonova. My topic is, the topic of today's presentation is different from the transformers, but considering that transformers are integral part of the GIS substation, so it makes some sense to discuss on GIS monitoring and health assessments. Can I have the PPT, please? Okay. So this is the outline of my presentation. So I will be discussing about the GIS testing and monitoring, and then some challenges in the testing and monitoring of the GIS, a few case studies, and what we offer in the case of monitoring of different assets. Like GIS. Now, I will make some references to the transformers monitoring also. So when we talk about the GIS system, there are three major things we we monitor usually. That is the PD activities, the circuit breaker monitoring, the circuit breaker operation monitoring, then the gas density monitoring or gas pressure. I will be focusing on the partial discharge. So there are a few defects related to the electrical assets which are going to be installed at the substation. Those defects are two types of defects. So one defect which can be detected during the commissioning or in the factory test, and they can be rectified also. They can be rectified. The defected part or component can be replaced at the site during the site acceptance test. Then there are a few defects like the gas leakages in case of GIS or circuit breaker malfunctioning or the insulation degradation which are related to the operation of the electrical asset. So this is not just related to the GIS, but in any electrical equipment which is in operation. So there are a few partial discharge sources in the GIS like free moving particles, like a protrusion on the conductors which can be detected during the commissioning test. But a free moving particle may happen during the operation because of the operation of the circuit breaker or earthing switches. So these are the few defects like with the operation we may have the loose electrode or floating electrode also, or somebody during the operation may open the cap of the PD sensors. There are some embedded PD sensors in the GIS. So to detect those defects or to keep monitoring of, to keep a record of the defects or how the value changes with the time, we need to have some trend. So to get those kind of trends, we need to test it periodically, or maybe we have to monitor it temporarily, or maybe a continuous monitoring system is required. So these are the three ways to monitor. This is a condition monitoring system which we can implement or which we can install in different assets like the GIS or transformers. So the objective is to get the trend of those the different parameters over time, and then it will help the asset managers to take the preventive and predictive maintenance or condition-based maintenance instead of going for the time-based maintenance. So this is just a representation of how partial discharge patterns, phase resolved partial discharge patterns changing with some tests which were done during like every 6 months. So you can see the intensity, you can see the value, it is increasing. So if we increase the frequency, or if we increase the frequency of this test, then we will be aware about how the behavior of the PD is changing between two period, like two time. So if we are going for every 6 months or every annually, we are going to test some assets, like transformer or GIS. Then instead, we can go for a temporary monitoring system or a continuous monitoring system. Then we will be having the health index or health status of the electrical equipment on which we have installed the monitoring system. So this is just to, because when you go for the spot testing or spot measurement during the energized condition, then you will have the data of that day only or that time only. You will not know what happened in the last 6 months, how the PD was, partial discharge was, what was its behavior. So just to get more insight in which is related to the behavior of the PD happening, or maybe any parameter, like when it comes to the transformer, we have the capacitance and tan delta, we have the online monitoring also. So then the asset managers will come to know that how the parameters are changing with time. So there are two case studies. One is related to the online PDMS, which was installed on the system, and it was a 400 kV GIS. The system was able to detect the free moving particles during the commissioning test, and the same was detected by the GIS supplier also using their portable equipment. So this shows that during the commissioning test, both the portable and continuous monitoring system are equally of the same status. But after the GIS was energized on a certain date, then the continuous monitoring system was picking up some patterns which was related to floating electrode, like there is something inside which is loose. So after like a week of data, we gave the report to the end users that there is something which is giving the pattern different. There are different sources and they have the different specific PRPD patterns. So but they were not continuous. So when this PD phenomena is continuous, then they have they are dangerous. When they are sporadic, they are not that much dangerous. But when it becomes sporadic, it becomes continuous, then it becomes dangerous. So, but since the usual approach for the utility is to, if there is some PD detectable level, so it has to be rectified. So they asked the GIS supplier to test it. They tested with their portable system and they could not identify it. Means they could not detect it. So again, after a week, we gave them the report that there is some PD which is sporadic in nature, but it is there. So the end user insisted the GIS supplier to go for the high pot test of the particular bay. And during the high pot, the voltage is usually higher than the rated voltage, and they detected the phenomena, they rectified it. So after that, the trend, this is the historical trend of the magnitude of the PD. I'm showing it to you on the slide. So the trend was, then initially it was there. After the high pot test was conducted and the problem was rectified, the PD was no more there. So this shows the importance of a continuous monitoring system instead of using a portable PD equipment. So another case study was related to GIS again, about I think it was 400 kV in the Middle East region, and there was the GIS was an old GIS with no monitoring system installed, and there was a particular bay which was not energized. It was a spare bay. It was energized after, let's say, 12 years. And before that, there was some maintenance work, maybe 2-3 months back. So there was some high electrical noises were coming. They were detected by the acoustic sensors, and they confirmed that with the equipment, it was confirmed that there is some PD inside it, and we detected it with our portable equipment also. And the magnitude was very high, near to the center of the circuit breaker compartment. And guess what we found? So it looks like a moon, but it is, of course, it is not a moon. It was something like 1 foot long torch inside the energized condition. It was giving us PD. And here again, there was no continuous monitoring system, and this problem could have been identified in the very initial days when there would have been an online PDMS system, partial discharge monitoring system. So this was a 2 case study just to show you that why an online PD monitoring system, continuous monitoring system, is important when we compare with a portable system. Now the challenges in the GIS monitoring, the very common problem what we have experienced from the utilities, which they told us that they tell us that there are many PD alarms, false PD alarms related to the switching operations or maybe some sporadic events. Then, so one time there is a false alarm. The operator will go check. Okay, it was a false alarm. Second time, fourth time, but not on fifth time. They will just consider it as a false alarm, even if it is a real alarm. So we can relate this to our story in our childhood, that the boy who cried wolf. So a real PD alarm was considered as false alarm, and then again there is an alarm. It will be considered as a false alarm, and then there will be an eventual failure of the insulation system, and it will be leading to the catastrophic failures. So another challenge is the non-availability of the embedded PD sensors in the old GIS. Nowadays, the GIS, I think it is mandatory now that the GIS manufacturer should be providing the utilities with the embedded UHF sensors. And in India, usually the monitoring, PD monitoring system is not recommended for 220 kV GIS and below. Only a few utilities are going for the monitoring of like 66 kV, even the lower voltage like Adani Transmission is going for lower voltages monitoring of the lower voltages GIS system. Threshold values. So there is no reference on the threshold values. There is no standard in the online monitoring system. The objective is to just monitor the behavior of the PD, whether it is showing an exponential trending or linear trending, or maybe it remains steady. So based on that, the asset managers can always plan their maintenance based on the condition of or based on those trend of the PD, partial discharge behaviors inside the GIS system. So what we offer, what Alternova Double is offering, we have a patented time frequency technology, which is a kind of denoising technique. Many researchers are aware about it. It's based on the first Fourier transformation. So it automatically, so in our system, it doesn't take the, it helps in rejecting the sporadic phenomena, rejecting the lower electrical background noise also, based on the shape of the discharges or the, and then it identifies automatically after a few acquisitions that these are the confirmed phenomena which is persisting in many acquisitions, and hence based on those phenomena, it raises alarm when the value is compared with the threshold values. So just a few minutes. This is a PRPD pattern, phase resolved partial discharge pattern. So it is unique to an internal discharge or surface or corona or whatever discharge is inside a GIS or a transformer. So, but it may also have some disturbances also, some electrical background noise also. So that is Fourier transformed into a time frequency map, and based on those clusters, because each cluster is a different source of PD or maybe noise. So we segregate those pattern, which is the entire pattern nobody knows or the system cannot identify. So this, with the help of this time frequency map, we are exploiting this, and then the system is like identifying those different phenomena based on the time frequency map and the shape of the discharges. So here is some a snapshot of the HMI of the system, and you see that one phenomena is like continuously appearing in field acquisition, then it is confirmed. Then at the top you can see the alarm. Alarm is raised based on only confirmed phenomena. So it helps in the rejection of the noise. It helps in the rejection of the sporadic phenomena. And when a PD is confirmed, only then it will evaluate it and compare it with the threshold value and give us the alarm. So it is minimizing the false alarm. So it is not giving, so in most of the cases, more than 95%, it is not giving you the false alarm, so that the operator can rely on the system which is installed. So that's all for. So this is the same. So regardless of the asset, the monitoring system is same for all the assets. So it is applicable on the cables, generators, motors, transformers, and the GIS or medium voltage switchgear. Thank you. So there's just a conclusion. I've already told you about instead of going for the temporary monitoring, if there is the utilities are having budget, they can go for the continuous monitoring system also. So because the data is always reliable and it helps in the preventing the sudden failure, and which in turn is causing revenue loss to the utilities. So trend is the key. So even if you are going for the spot testing, so the frequency can be reduced from like 1 year to 6 months or maybe 3 months. So thank you very much.
Yeah, actually it was again the nice kind of presentation having of different choice and test. Definitely this session itself is of a combination of few different choices. So before to go to the question answer session, if any queries are there from the house, you can directly ask. If nothing like query is there, already ready recon query is already there, so we can have the discussion before to conclude. So any query is there to our distinguished speakers, please. Just. Yeah, pass him.
He has opened a transformer which got failed, and eventually you might have seen that the winding was completely disintegrated. So what we have is that in your auto transformers, the tap winding will be the most critical winding, which is tend to fail more. So that winding is the external winding. And suppose if you say that fault has happened in the internal winding also, means the winding which is the most inside, you can't trap the arc, you can't trap the light. That is the idea behind it. And in recently last year, one transformer got saved with by the arc sensor, where the fault has happened in the LV winding, and the complete disintegration was actually prevented by the arc sensor. Sorry, sir. Yes. Sir, yes. Yes. So, sir, as we have got it tested, or we have the historic data from all the utilities regarding operation of differential relay. It may take up to 150 millisecond, from 50 millisecond to 150 millisecond. So for differential relay, what data we have is that the historic performance of all the utilities as far as differential and other relays are concerned, it was from 50 milliseconds to 150 millisecond. That is the time when differential relay has created the trip command. Whereas in case of arc sensor, 1 millisecond, the light which will come from the arc, it will activate the arc sensor in 1 millisecond, and within 15 millisecond to 16 milliseconds, our my arc relay will convert that particular signal to break, and it will be given to the master circuit breaker. So within 15 to 16 millisecond, your trip command will be processed, which is even faster than differential relay.
So in case of
Sir, you take microphone closer to your mouth. Make it on, make it on.
Hello.
Yes, sir.
So total isolation time of the ICT or transformer, 400 or 220 kV, that is around 50 to 60 millisecond.
Yes, sir.
In case of any fault, internal fault.
That is inclusive, including the breaker time, or excluding the breaker time? Sorry?
Including the breaker time.
Okay.
And if, say, I use your arc sensor in the operation of NIPS or for direct tripping, so how much is the time saving? Suppose
Sir,
direct tripping command goes from your arc sensor to the circuit breaker. Even that circuit breaker, it will take own time. Any relay, master relay or whatever it is, it will take its own time. So total isolation time will be, how much it will be reduced? Whether it will come to the 20 or 30 millisecond, or what will be the?
It will be like आपका जो ब्रेकर का ओपनिंग टाइम या ओपनिंग टाइम जो है, अगर मैं उसको 25 मिलीसेकंड कंसीडर कर सकता हूँ, 25 मिलीसेकंड, तो आपकी डिफरेंशियल रिले 25 मिलीसेकंड में ट्रिप कमांड दे रही है, जनरेट कर रही है, और अगले 25 मिलीसेकंड्स में वो ओपन हो जा रहा है. तो दैट मींस 50 मिलीसेकंड पकड़ लेते हैं.
Okay.
तो अब हमारा जो सिस्टम है वो आपको 10 मिलीसेकंड और एडवांस प्रोटेक्शन दे रहा है. वी आर ऑपरेटिंग इन 15 मिलीसेकंड. जो ट्रिप कमांड आपको डिफरेंशियल रिले 25 मिली सेकेंड में दे रही थी, वो अब आपके पास 15 मिली सेकेंड में होगी.
What is the experience? How many utilities are using this?
Sir, all
new
the
technology?
utilities are using, NTPC is using, all the utilities.
All the utilities GTL is not using. So you cannot include all the utilities.
Sir, should I start from the north? Rajasthan, UP, Madhya Pradesh, Telangana, your Andhra, Kerala, Tamil Nadu, what else? Gujarat, then your Arunachal we have supplied, and Himachal we have supplied, Assam we have supplied.
What is the experience?
Sir, see, this is a capital good, and
Because-
we are
because-
still there from last 5 years.
Because I am worried because it was there was a discussion on this arc sensing devices to be used on CA also. All the utilities were there.
Yes, sir.
So that's why to use any new technology,
So that's what CA has CA has given you wings now. Now you can use it. Initially, your hands were tight-fisted, na sir. That you cannot go beyond CBIP recommendation. Then what CA has said? CA has says who is CBIP to decide it? What logic need to be implemented? So now you have the full liberty, sir.
Sir, CBIP ने तो अपना U-turn ले लिया. Okay, let CA should decide or let utility should decide.
Yes, sir.
So what is the final verdict of CA?
CA ने तो CA का फाइनल वर्डिक्ट तो उससे MOM में है ना सर, कि अब आप लोगों को डिसाइड करना है आपको क्या परचेज करना है.
Okay. Thank you. Thank you.
No, actually, I wanted to come in between you. Basically, what happens whenever CA and CBIP we are talking about, basically, I think CA, CBIP are not particular about the logic. We are not discussing about the logic. Logic, they have not told anything. Only they kind of capacity, what sort of capacity transformer should have, in which NIPS system will be implemented. That is the things actually it is there in CA and CBIP. So logic yet not been considered because might be with ESN-MR having of different logic and some other group might be of different logic. They are uncomfortable with their logic. They are also exactly just convincing the utilities of their customers also. On that practices they are working. But anyway, this is a point-to-point kind of discussion.
Yes.
You can have also those things. But to you, okay, thank you, sir.
And one question more.
Yeah.
We are facing the problem, not the question. Actually, in the DTL, we are using 220 kV cables. Of course, reactive power problem is there. So in one incident, we energized about 3 substations without isolating the transformers. Cable, they were connected. Say, for example, Shalimar Bagh, Wazirpur, Piragadi, and 400 kV substations. That 3 substations were switched on directly without isolating the transformer. So there were, I think, 3-4 transformers connected. What happened in one transformer that was tripped on differential relay. So transformer was working, okay, it tripped on differential relay. Some different type of harmonics were there in the DR. At first we could not know what happened to the transformer. It was due to harmonics. Again, after thinking for a few minutes, again, I saw the DR, what happened to the transformer. Actually on differential relay, tripping on the differential relay, running transformer, that was a serious method. It took 1 day. So after minutely enlarging the DR, there was a 3rd, 7th, odd harmonics were there. A very good graph was there after enlarging the DR. And 2 small peaks and in between a large peak due to odd harmonics. So in future I am worried this may happen because we are using reactor also. So this all was with long capacitor cables and there were oscillations between the transformer and the cable. So we are going to practice like that. In case of failure of supply, switch off the transformer and then energize the cable one by one. Otherwise, we may face this problem again. So this is just sharing of the experience.
No, actually the one which you told, I will not take, half a minute I will take. Actually the one which he experienced, it was really
I will share the DR to you also.
Yeah. Actually, I know the kind of things. Very particularly, I do repeat over here, whenever any kind of reactive equipment is there in the system and you are idly charging those reactive equipments, obvious, it is of a very academia kind of things. It is to get connected the reactive, or just like an example, at your house, you are just to make switch on your heater, the old kind of heaters were there. What sort of it is? You will be finding that particular 15 ampere switch, it will be resulting a good spark. It is a very simple kind of things, because RL circuit, whenever you do get it switch on, that will be switching source. We are not going to take those academia kind of things, but it is a nice experience, as you told. And at this point of time, there are a number of technology have come up in the relaying technology. They already know that these are the things which may happen, for which second harmonic kind of things, then odd harmonic, how it is to take the way. So these are already solutions are there. So anyway, thanks for very good interaction and also the experience.
The solution may be inside the differential relay. We will see in detail.
Yeah, it is there in the relay. Okay.
Thank
so
you.
actually, I'm not going to take much time because we are running short of. And your query is there? Okay, please.
Sir, my query is to Nitinji. In your presentation, you have mentioned regarding this using the light-sensitive semiconductors like LDR for sensing the light, right? And we have mentioned about it has tested for 155 degrees Celsius.
Yes.
Right. There are many technical documents and papers in the public domain, even published by the University of Hanover by many professors, that the semiconductors maximum working temperature is not more than 75 degrees Celsius.
Yes, sir.
So this is just then how you are also using the semiconductors.
Yes.
And it has been tested for 155 degrees Celsius.
Yes.
Yeah.
There is a, sir, I would just like to take you through an example.
Yeah.
If I'm standing and a firefighter is standing, who can pass through the fire?
Yeah.
Obviously the firefighter.
Yeah.
Why? Because he's wearing a fire suit, which is isolating his body from that extreme heat, so that he's able to pass out. Whereas my withstand capacity of fire and his is same. So that is the same concept, sir. We have encapsulated that particular semiconductor. We have encapsulated it so that we can increase the withstand capacity. And whereas, for a clarification, I'll just give you a clarification. All the utility people are here. None of the transformer crosses 75 degrees. Even in even in the peak summer, if it crosses 75 degrees, the operator runs and calls everyone that transformer is crossing 75 degree, what to do. Even I have seen in one of the utility board, they have installed coolers so that the temperature should not go beyond 70 degrees. So that is the care what our people used to take. So we have taken it as a another step, that this particular arc sensor should sustain the arc, and that much of temperature it should able to sustain.
Yeah, but
that was the
as
difference.
per, of course, you are talking you are encapsulated. But the fact is that as per the IC, transformer ICs, it should not be 75 degrees. It should be more than that, right?
I didn't got your point, sir.
Yeah, as per the IC, it is more than 100 or 120 degrees. It should be
Sir, किस ट्रांसफॉर्मर का आप बता रहे हैं कि 100 या 100?
All as
नहीं,
per IC
कौन सा
transformer,
सर DTL के बैठे हुए हैं?
Yeah.
सर आपकी कितने ट्रांसफॉर्मर 100 डिग्री से ऊपर पे चल रहे हैं? अरे सर बताइए
It is
सर.
not talking about the
सर पूरे
set
भारत
temperature. It
हाँ
is
सर.
talking about the regular IC standard for the transformers. Yeah.
नहीं जी जी बिल्कुल सर जी जी exactly sir. So that is the reason.
So
That is
as
the
per
reason.
the standard, okay, we set at 50, somebody said 60, somebody setting at 100. But as per the IC standard, it is not 75 degrees. It is more than that. Any component.
Sir,
and you are encapsulating in enclosure, but what is the effect of your calibration of the lux? When you are your LDR or that semiconductor, it is inside the one enclosure. So what is the effect of your calibration.
So is it good enough that the first supply, first installation which we have carried out in the year 2017, July. Recently, last month, we have carried out a calibration test and it activated on 100 lux. The first time we have installed it for the rating of 100 lux. Yes, last month it was recalibrated, it is bound our duty that we should go and check. And again, it was checked in front of customer and it got activated in 100 lux.
So it can be calibrated at site or tested
Yes,
at site.
it is calibrable at site.
Yeah. Another aspect you mentioned regarding the 1 millisecond.
Yes.
That 1 millisecond plus the breaker time or master relay time.
Yes.
The response time. But you know, the sequence of the shown is fault, then arc, then light, right? And then your arc relay time.
Yes.
Right? So I think the differential protection is operating during the fault.
Sir, now I will tell you.
Set is, you know,
There is an operating setting for the transformer and there is a fault setting.
Yes.
So in between there is a gray area where nothing will operate. If suppose the transformer is for HV side, the maximum normal current is 600 amps and the fault current is set at 800 amps or suppose 700 amps. So between 600 and 700 nothing will operate. No protection circuit will operate.
No,
that is where the fault
the
starts.
of the fault.
Sir?
The sequence of the operation.
Yes, sir.
You see, we are zero from that point when the your sensor or any protection is operating.
Yes, sir.
You have given the example of the differential.
Mm-hmm.
That the arc sensor is faster than the differential.
I'm sorry. Actually, I have to come in between because there are whenever I just been to the house and many of the people are waiting for to interact. I'm sorry. We can have point to point interact.
Sure.
Okay. Sure. Because Sir is also waiting. We have not given the real justice to our chairman also. So because we know delegates are definitely to be given the higher preference. As I told you in the session itself, concept was of delegate best. That's why we are giving. But we are extremely sorry. Just have one-to-one. Anyone? I think you were talking about something. And I think एगोस जी पहले कंप्लीट कर दीजिए. क्रिप्स बोला.
The installation which we did we have done number of transformers installations on the transformers pan-India, and what we found that they are on an average the loading the transformer on government utilities, if you consider a small range transformer, obviously I found it has gone above 100%, and and if you go for some of the private utilities, what we found majorly this transformers loading is up to 50%. And even in majorly in wind, majorly if you consider for summer season, what I found majorly it was loading was around 50 to 60%. I was surprised. I thought some of the utilities have even installed the fan on ONNF type on distribution transformers. So I thought the transformer must be loaded during summertime. It must be loaded around 100 above near to 100%. But later down we found that it was loaded up to 50%. Yeah, obviously what we found in some of the this is a case which we found in private utilities. But if you honestly, if we speak about the government utilities, we have found that the loading of transformer is more than 100%. Yes. We can do the calculation basically based on if we monitor if any transformer is having energy meter on HV side or any CTPD is available, so we can put the energy meters. We obviously we have done this case study in one of the private.
Actually, we are running out of the time. Okay, you can take it also point to point. But right now, actually, there is no question from Shyam Ravindranji. That's why I will be from organizing team. I do prefer that there will be some questions to Ravindranji. So one question is that are we ready in the Indian context for EV and PV quality measurement? This is the first question. Second question, if you have emphasized in this slide, in your slide, but how it is related to inverter transformer used for RE?
Yeah. I'll give with an example, sir. A couple of months before, I attended a EV association meeting in which the ministers from all over India, couple of ministers from all over India were present, along with some EV vehicle manufacturing companies also. To be very frank to you, in that meeting, one of our minister pointed out that our EV deployment numbers are being hampered once when we hear the fire accidents. And he also narrated a fire accident during the session that in Andhra Pradesh there was one important fire accident, and he even emphasized this point. Then he told because of this fire accident we had a slowdown on the policy implementation. This was told by the minister in the forum itself, and this was actually acknowledged by the manufacturers. In my presentation, I wanted to present my answer in a way not to take a suggestion from an individual or a company. We have a set of rules and regulations that is guided by CEA. If we go to CEA website under regulations, you will be very well able to find when something is connected to the grid, what are the points to ensure. In that there is a clear guideline what a EV manufacturer shall follow. I think it's a very important point because after that we visited EV manufacturers also. So here is a scenario. There is a EV manufacturer who designs the product, which is very good. There is a charger manufacturing companies who are designing their product, which is absolutely good. Then there is a utility who buys the charger So these are all three different entities. But the CA guideline starts like this. The applicant shall ensure proper disconnection. And you know what? Who is the applicant? Let's say we wanted to have a charging station as a business tomorrow. You buy a charging station from XYZ company, and then we connect it to any utility. All the regulation is applied to the applicant, not to the vehicle manufacturer. If we read the regulation well, it says applicant. Then the second point it says if there is any kind of, that is the first point. The second point says if there is any type of a fault, it must disconnect from the supply. It should not affect the grid. Did we follow? To my knowledge, I'm finding it difficult to see that. The third, fourth, fifth point, it all mentions about monitoring of power quality parameters continuously, sir. There goes to your second question. You are asking about virtual testing also. I wanted to combine all the session together in one point. The testing is different, monitoring is different. So here the guideline is saying you have to go for a continuous monitoring, power quality monitoring continuously because you are connecting it to the grid. Any manufacturer connecting something to the grid must be continuously monitored. This is not my statement, this is CEA's guidelines.
Yeah, fantastic. Actually, the one which CEA just gone for and considering the things, it was really thinking of that these are the things may happen in the Indian context. That is why those points are being considered. But interpretation is the most important point, what you mean to say so. And in that aspect, actually, some of the few people just taking away from the responsibility. For which these three, the sensitive point he told, the triangle kind of things, everyone is just going away because this is not my lookout. But anyway, this is one of the very good way. Now in this we are going to, you wanted to add something? Please.
It is very important. Hello? It has nothing to do with the EV charging or fire. It has to do with three parameters. Fundamentally, there are three parameters to be monitoring. The first parameter is the voltage, second the current, third is the frequency. When there is some problem with the voltage and your insulation deteriorates, one thing is going to happen, that is the fire. And second is the current. When it increases because of heat and the presence of oxygen, again the fire starts. Third is the frequency. Frequency means when you are using the EV charger, there is one thing is bound to happen, that is the electronics. The use of electronics creates harmonics, and there in India there is no control of harmonic generation by any gadgets. When these three mingle together, become the cause of fire, and that can be addressed by loop impedance measurement in case there is no proper disconnection of relay. At least the loop impedance and use of RCCB can save that system at all. That is the only solution we have.
The one what he told, that is also the crunch of, Ravindranji paper also, regarding the room impedance. He was explaining very correctly. So with this, we are just going to conclude. Before to that, we'll ask our chairman, sir, Kanti Prasad, sir. Please just summarize, because I'm sorry of...
Thank you very much. First of all, my thanks to the various speakers and authors of this session. Very lively and very interactive presentations they have made. And my thanks are to the patient audience as well. This kind of sessions which have been organized, perhaps in my career life, for the first one of the most interactive session I have come across, I have participated. My compliments to Mr. Patnaik for two things. Number one, that he has been a very dynamic player in this interactive sessions altogether, making it very live and very objective from the point of view of both from the utility, from the technical sides also. And secondly, you know, the spark, which is, you know, it is very wonderful forum by itself. I am, you know, getting so many WhatsApp, hundreds of that. And my daily routine is that the first number one, I must go through the Spark, which is very educative, and the things which has been displayed here itself. Now, during these discussions, it's very, you know, important subjects have been discussed and brought forward from the point of view of the, you know, utility. And the challenges, to my mind, there are on mainly, number one, on for the designers who have to see how best they design the equipment, taking the feedback into account from the field and the utility. Metal, that is the core material, is one of the most, you know, is a concern aspect. And new material are being, you know, now coming into focus from the point of view of the efficiency of the transformer, efficiency and longevity also. And most of these materials, you know, core material particularly, they are imported materials. So we have to find the best possible materials in which, you know, indigenous part is also there. Similarly, on the other side, on the field side, there are a lot of challenges. The challenges particularly which, you know, overloading that has been addressed, and generation of harmonics that has been addressed, and it is a focal point for most of the, utilities and everybody, distribution side also. And another point which sometime it is very dear to Dr. Rajesh is the earthing, that is the inadequate earthing at the field. Quite often find the problems on account of that also. Some time before also I have heard that part, and it is a very vital. Then safety aspect has been also discussed in detail, that is fire safety of the transformer, and the innovations, R&D, which have been carried out, particularly spot monitoring of the heating, that has been also discussed. Another for the, because my background is implementation of the power stations, substation, transmission also. So at site, particularly when problem comes, that even the transportability of the transformers, when there is a problem and to replace it or to repair it, is really a big issue. I don't know how the utility, sometimes, because it is not an emergency always, but like, testing problems, another thing, it doesn't come into monitoring, but it happens. And then when it happens, then it has got a catastrophic effect on particularly bringing back that, generating station into, again, in operation, connecting to the grid, and a very adverse effect on the grid monitoring also. So transformers now, technology, smart technology, and smart transformers are also being talked. So with this, it is a very enlightening, I think, session. And I must thank all and everybody, all participants, and my compliments to
Thank you. Right now, we'll go for felicitation. Now, over to Hardeep.
It was truly an insightful, knowledge-filled keynote discussion. Can we have again a huge round of applause for all our esteemed speakers? And now, ladies and gentlemen, it's time for the felicitation ceremony. For that, I would like to request Kanti Prasad sir to come forward and please extend our warmest greetings and congratulations to our esteemed speakers. Could we give a resounding applause to him? Now I would request Mr. Subhash sir to please come on stage to extend our warmest greetings to Kanti Prasad sir.
This actually, I request all the panelists, please come up the dais. First of all, I will take the name of Dr. Rajesh Arora. Please take a little bit pen for us, Dr. Arora. So next, Yogesh Sood sir, please come to the dais. I think Dr. Om Prakash Gupta left anyway. So Gupta sir, JK Gupta sir, please come to the dais. Pathak sir is there? Ishan Pathak? Ishan Pathak sir, please come to the dais. So finally, I wanted to sensitize the dais. That's why I did not ask to our friend Prakash ji to come. So that's why finally, with a great kind of applause to please R. Prakash, please come to the dais. You can feel the difference. Once he comes to the dais हिल जाएगा. इसलिए he will be just on the dais. R. Prakash, please. Actually, right now, in this regard, we'll go for very quickly. Some of the few question answer session will be there. I mean, rapporteur, I being the rapporteur. So it will be the open forum discussion. So so actually today morning we are discussing about this category like transformer design connectivity, transformer protection design, transformer conditioning and health indexing, transformer protection measurement and all. So we'll take only a few discussions relating to this. First of all, I'm going for transformer design connectivity. So transformer design connectivity, whenever we feel if everything is okay, transformer itself, connectivity is not proper, then automatically things will be otherwise. In morning, you might have heard also the number of papers we got relating to this transformer design connectivity. Now, I'm asking a very simple question. In this way, I can ask to, it will be better to ask transmission guru, Dr. Rajesh here. Right now, I'm asking a very simple question. Whenever we go for the transmission transformers, basically, it is been found because of arrangement sometimes the transformer HB side comes directly get connected and also the LV side directly get connected. But because of the gantry arrangement, the kind of arrangement what it is put on the face of the transformer, not been proper, in Indian sector we go for the Jugaad technology. So in this regard, definitely we will be just lighting some of the few points. What should be the factor? I mean to say, how like? I mean, that should have a very strong point connectivity in that regard. So how it is to be addressed and how it is getting done in the Indian sector relating to the transmission way, we will be listening from him. Please.
So far connection of power transformer is concerned and transmission utility is concerned, I don't find any utility who are making the jugaad arrangement at all. It is always appropriate and as per the regulations, because what I believe, the transformer being the costliest equipment and no utility can tolerate bear any outage because of that jugaad technology. And we have to abide by the rules and regulations at all. There is no jugaad at all.
Yeah, that's a very fantastic thing. Purposefully I kept it because I am from also transmission sector. That means it is been indicative and also one message is going to the total house that there must not be the word jugaad in the Indian context. And basically in every technical session, wherever you go, any national forum you go, definitely this jugaad kind of things, the word will be there and people used to discuss over it. So my sincere advice, I just do say so, don't go for any kind of jugaad. Next to coming for Ishanji, morning also he has already explained. Basically the design, if I just consider acceptance relating to the amorphous, the one design factor we consider. There are two kinds of amorphous you have explained in your paper. One is of a MADC and all. So how do you feel, is it required as per the MADC to be required for in Indian sector? Because in Indian sector, the loss measurement is the most important factor. So MADC, particularly right now, it is Indian sector is matured to accept that particular MADC kind of design?
Sir, presently at BIS loss level 1, there are different states who are following different losses level. BIS loss level 1, BIS loss level 2, new, is the most prevalent right now. So in amorphous, there are only 3 grades right now: SA1, HB1M and MADC. I particularly feel with SA1 grade only, that is 0.2 watt per kg, there is a huge acceptance for BIS loss level 1 and 2. Now, when you talk about higher loss grade, BEE star 5, star 4, star 3, whenever India is going to be moving for next star rating, that is going to be a time where MADC should come into picture. Because as transform manufacturer, whoever transform manufacturer is sitting would be knowing the commercial impact of that. So as of now, MADC may take some time to enter into the market because of the commercial aspect, but as a development aspect, where the huge focus is government is giving on like schemes like RDSS, government pushing in for new star rating. Future is like products like MADC is going to come into India. But for complete next to 2 to 3 years or 5 years, HB1M and SA1 grade of amorphous, or for that say 0.7 grade or 0.85 grade of CRGO, which was unheard of in India, like they will be coming in big way, will come in big way in next 5 years. But for amorphous particularly, HB1M, SA1 is the future for next 5 years. Maybe next 10 years, MADC.
Okay, so that's fine, the kind of things which you have presented very correctly. And if I just speak in that line, that MADC yet to come and acceptance not the way, in the reality commercialization in real field of Indian sector, yet to come. Not
Yes,
that
because,
in full-fledged.
yes, because if you are getting sufficed with BIS loss level 2, let's say Madhya Pradesh and Punjab, BIS loss level 2, your losses are getting sufficed. It's very indifferent for people to use MADC because it's going to be more DISCOM focused.
Yes.
Private, anyone can go for it in private utility, but the quantity is going to be very less. So when I say big numbers, 80,000 numbers, 1 lakh numbers of transformers, MADC will take time. SA1 is going to be, if last 2 years, if I'm going to give you data of states like Rajasthan, Punjab, Haryana, Chhattisgarh, Gujarat, you will be happy to know, amazed to know that SA1 amorphous transformers have been supplied up to 70% of the total quantity.
Yeah.
The only reason was the losses were getting achieved with a much better commercial realization.
Yeah, actually, I'll be coming to the one question to the house also. Basically, some utilities are there and the transformer manufacturers are there. You can just recall, whenever it was of a star rating transformer came, during that time, like ERDA and like CPRA and all, they were with of a very, the kind of things, managing the things and stamping was a big trouble. So similar kind of things right now it is not there, what I hope so. Basically the transformer manufacturers, if anyone is there, they can answer of it. Suppose whenever we go for the star rating transformer to get it stamped, and the correct way to get all these things from the ERDA testing bench and all these things, is there any kind of problem is there of getting those things? I think Kaul Saab can, right now it is of everything set right. But initial time whenever star rating was there, it was a huge, it was a huge kind of things. Anyway, good symptom, and everyone is just cooperating, also coping all these things. So next we'll come to the transformer protection design. Okay, our gurus are there, 3 gurus are there. They will be now discussing about this transformer protection. Protection transformer, we basically right now, as per today's session and today total conference is concerned, we are talking about the fire protection. Maximum part we are getting about the fire protections. So in that aspect, I will be coming questions to Prakash ji. Right now, I do say so that arc sensor, and which is of a very quicker way, and the claims for that to get it cleared within of 15 to 20 millisecond. It's a very new, innovative way we can say to get it out everything of a 20 millisecond and all. Now, in that aspect, I will ask a very simple questions because everywhere in every forum it is also going on regarding the logic of NIFPS. So, our friend Mr. Prakash also will be talking about. It is a very, of course, it is a one-sided kind of questions. This is a inside discussion, in a forum discussion kind of questions. Do you feel that the NIFPS logic should have to be standardized? Please.
First of all, good afternoon to all of you. The fundamental part is, ideally, if you ask 95% of the transformer designer, who would always have the opinion that if we take care of the designs, we don't need any fire protection. While I agree in principle with them, but there are three factors which is unfortunately playing in card. One is the competitive pricing, leading to a lot of cutting of corners. Second, the nature of loading itself is changing. The loading application is changing. Whatever the application we did not see today, what we are seeing today, we did not see 10, 12 years back. Third is the maintenance focus, because the number of transformers and everything is increasing. So the fire prevention or protection become necessity. I naturally would not like to getting into the comparison of which method better, which method is faster. All I am saying that standardizing, this is the whole transformers. If I take universe of 100, only 1% of the transformer is protected for fire or prevented for fire. Mechanisms are available for fire, automatic mechanisms. So if it is in a very nascent stage, so it is unwise to standardize on anything, because this is developing. Gradually, one technology over other technology is coming. So it is only we start standardizing only when the technology is getting matured. So better let newer technology come, so that we will be able to see them and use them and progress it. Once it matures, then we do standardization logic. Till that moment, let all the logic, all the methods grow together. This is my point.
Yeah. Actually, it is a very diplomatic way you just answered. I'm sorry to go into your answer, but I can say it is a diplomatic kind of things, because it's true. I'm not taking anyone's way, but thing is that all the technology, what it is there, let that to evolve out. But sometimes whenever the regulatory comes into picture, definitely regulatory one day will say so that it has to be standardized. Because we cannot exactly think that this methodology we have to go for, this methodology we should not. If it happens like that, there will be the competition, we do agree. But there will be the way that we will be saying so that because of that we could not, because of that we could not.
No, sir, I am only answering to the logic part.
Yes,
of
I'm
course, as
talking
a
about logic
product
part.
and as a technology like nitrogen fire injection technology, I would advise that we also wrote to the government, standardize on that. How the mechanism have to operate, there only I am saying increased number of sensors. There only saying keep it open for the R&D activity to grow. That's
good. Actually, whenever to get into the kind of things and what is the procedure to be maintained, that nothing to say. But the way out that everything should have to come with a new technology, and it should be open up so that the new people, new thoughts, new brain also will be coming to work upon it. So with this, actually, I'll be asking the query to Gupta sir, though it is not of your subject, but still also I will not be asking the query to the subject. I'm asking
nothing out of subject for him.
That's right. So I'm just going to give a query to Gupta sir and also Kanti Prasad sir is there. Should I just take a kind of concept, a slogan to the Indian context as per the distribution transformer is concerned, fit it and forget it? Why not the Indian concept, we can go for the transformer manufacturing to go for this slogan that fit it and forget it? So we'll be listening from Gupta sir, whether we should have the transformer as far as distribution is concerned. Because an example point of view.
Either distribution or even power transformers. I will just give you an example. Then I will say what means fit and forget. I was using mobile phone, maybe let's say Y2K came. Capacity of that phone was maybe 200 KB or 1 MB maximum. Today the same size of phone, capacity is 250 GB. In 20 years, it has grown like that. So there has been technological advances in terms of process, in terms of materials, in terms of the designing. Unfortunately, transformer has remained as it was in World War I. Because major change in transformer happened when HR was converted to CR. That was a major change. After that, it were only adoptions. M4, M3, M2, M4, MOH, ये सब थोड़ा चलता गया. It is only major, it is not. So it means we have to really, because all of our electrical design engineers think a little bit more big. Can we reduce the size of transformers? Can we impart more power, more kilowatts per kg of transformers? Today, bigger the size, bigger the MVA, everybody is happy. No, it should not be that. Transformer should be smaller, MVA should be bigger. And when you want to fit and forget, then you have to look these aspects. Because today, what we really, okay, somehow the system has become like this: more the failure, more the better. Because so many people get business out of failure. So, and nobody worries about the customer. As a bank, मैं जब बैंक को लोन लेने जाता हूँ, बैंक मुझे 14% चार्ज करती है. बैंक को जब मैं फिक्स डिपॉजिट करता हूँ, मुझे 6% देती है. तो 8% तो बैंक खा गई. सिमिलरली आप इलेक्ट्रिकल इंडस्ट्री का देखिए.
वेरी फैंटास्टिक एक्चुअली.
तो जब यूटिलिटी बोर्ड वाले जब बिजली खरीदते हैं, वो ₹1 ₹1.5 किलोवाट होती है. जब बेचते हैं तो ₹8 किलोवाट होती है. तो आप 5 गुना क्या वैल्यूएशन किया आपने उसमें? What is the 5 times you are charging than your buying price? So what is the value addition you did? So it is not no value. So because they are building inefficiency into the system. 315 रुपये का सब्सिडी बनाएंगे, एक की जगह 2 ट्रांसफॉर्मर रखें. अरे क्यों रखेंगे भाई? You have no confidence on transformer. Everywhere there is a one spare transformer. Why it is a one spare transformer? So it is basically the, I must, okay. Sorry, I am a mechanical engineer, but I must tell all my electrical friends that something is not right in transformers. Design practices, manufacturing practices, this has become a grand old technology, remain the grand old technology. It is not moving with the time. No automation is happening. You cannot have a transformer which is fit and form, because it has become a artmanship, craftsmanship. वो वर्कर जो बनाता है वो कॉइल बन जाती है. What is automation? What is automation in manufacturing? No automation, no standardization. It all depends upon the Shyamlal and Ramlal. Shyamlal की कॉइल सही है तो सही है, Ramlal की कॉइल सही है तो सही है. So let us try to evolve the technologies. Let us try to do, and unfortunately, a lot of our young engineers, they don't want to come to design to transformers or electric engineering per se. Because हाथ गंदे करने पड़ते हैं, काले करने पड़ते हैं. ट्रांसफॉर्मर वो कंप्यूटर अच्छा है ना, वहाँ पे टिक 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 करना है. तो माय रिक्वेस्ट,
व्हाइट कलर जॉब है,
व्हाइट कलर जॉब है, एसी में बैठने को मिलेगा, सब कुछ होगा. यहाँ तो दिन का नहीं पता, रात का नहीं पता. वो ट्रांसफॉर्मर बल्ब, तो अपने को ट्रांसफॉर्मर को अगर फिट एंड फॉरवर्ड कंसेप्ट में लेके आना है, तो मेजर चेंज इज नीडेड इन डिजाइनिंग, इन मैन्युफैक्चरिंग, in every aspect.
Fantastic.
In every aspect.
Fantastic.
Otherwise, it's not possible. We will be talking like this.
Yes. So actually, we'll be listening also. I'll be coming to you, sir. We'll be listening also the vast experience of Kanti Prasad sir, because in this regard, he will be having also something wish list. He might be having some wish list for the Indian transformers. Sure. Please add some. Just please hand over the microphone to sir. I think he's having a vast experience. We must be listening him.
See, I briefly mentioned during my this small talk, the whole on whatever problems we have, whatever we are talking, ultimately it goes towards to the designer. And the design of transformer or any product for that sake, he has to take into account. And he has to identify, evaluate all the feedbacks. Unfortunately, transformers is such a utility product that, it's very difficult control over it, particularly on its utilization, I must say, particularly the load side. How you control the load? Very difficult. Generation of harmonics and all that is a result of that. With the result, it is a very, very complex situation, which ultimately the mind in the design office it has to work it out. That is my feeling.
Yeah, absolutely. People have to actually note it down and accordingly to work upon, because these are the vast experience you may not be getting in anywhere. Like we people to talk each other and just up over. I mean, we go for discussing in a normal sec, but is vast experience.
The feedback is more important for
Yes.
everything.
Actually, we'll be coming to Sood Saab, basically talking about this transformer conditioning and health indexing. Fine. Your paper was of that way to go and have the taking this online drawing system and all. Now, health indexing sometimes also becomes the buzzword. If you think about the old timer like we people, we were not thinking the health indexing once upon a time, because the situation was of a totally disciplined situation. We were using of incandescent lamps, kind of harmonics were not there. Right now we are using all passive elements, so those are of containing these harmonics, swelling, these that. These wordings were actually right now we get it, during those days we were getting in the academia. But right now we are realizing those things. So in this aspect, the health indexing part, it comes. How do you see, should we go for that, this particular kind of health indexing should have to be a must for every utility?
It is evolving and new standards are also coming up. IEC standard also is TC 123 is working committee is working on that. But as from my presentation what I told, if you see any of the CA report also 220 kV substation and transformer failure whatsoever they do the after analysis of that, the moisture is the number one thing in that. It deteriorates everything in the transformer when moisture is there. So I just want to quote one analogy from SD Myers. If there is a marathon runner, international marathon runner, and you put a 100 kg bag on that, he's not going to complete the race within the specified time what is there in that. Similar is the case with the transformer. Its life is defined, design life is defined as 50 plus years. Operatable life should be 35 years. Same thing, if moisture is there and this paper gets eaten up, then definitely we are not going to have that much of life like that. And to correlate all that things, that health indexing is definitely, I think, it should, what I would suggest it should be standardized slowly in all the utilities.
Yeah. Actually, I'll be asking also, I think BOLA was one of the presentation. I'll be asking also one of the point here. In BOLA, it has been considered those things to take the action and in the manual mode. If I take, those are being considered in the manual mode. Something gone wrong, then someone is to go for and take it out, all those things. Whenever in this point of time, everything is to be connected, and we are having also digital connections with for this from here with SCADA connected and to get control of all those things. So have you thought such processes it is to be getting adopted in your BOLA and asking all the customers to go for in that line? Yeah.
Obviously, coming to your questions, we obviously some of the parameters which we are monitoring right now, and any abnormalities comes in the transformers, and obviously it is going to pop up to the software which they are monitoring, and which has been pop up which is indicated on the front page of the software, and obviously this will act. Even we have made a development in some of the utilities where we have done a pilot project where we can remotely do the controlling of the transformer. Okay, so any kind of such abnormalities comes up, so it is not like just we have to do the manually or go over there and do the manual disconnecting the transformer. So but it comes as a security part of way where it is a question like whether we have to implement it in a large scale, considering of the utility transformers. So, but obviously we have done a development where we can able to where not only manual intervention of tripping the transformer is required, but obviously that question comes in the security level part also. But that development
we are not that way getting acquaintance with us that to go for that level and to interfere, and that could be also authoritative interference. because some of the premises are there and those transformers are going out and they are able to manage those things within of that adverse situations, you mean to say so that we should not take away the transformer? You mean to say so?
Correct. Yeah.
But that is exactly going the safety aspects. Suppose the particular transformer is an adverse way, and if I take out, then maximum area will be of blackout and all. So if it is plunging to blackout, rather than to allow them and to get for some of the few period, which has already been in the impending manner, like it is right now in this condition, and it may cause problem. So that particular cushion we are planning to manage of putting the people into the connectivity. That you mean to say so. Anyway, it's a good kind of things. So with this actually we are, because we have got a lot of discussions and all, hope so if any special kind of address you wanted to keep, basically Prakash Shah was talking about something, we can go for 2 minutes or 1 minute, please. You are about to talk something.
All I said, transformer has 5 functions. Panchabhuta of transformers, I always call it as. It has a transmission, voltage transmission. You have a regulation, voltage regulation like tap changers. Internal diagnosing, because you have to ensure that continuously you have internal diagnosing monitoring system like DGA, what Rajesh sir said. Protection and monitoring. And if due care is taken in a regular interval, transformer will work for 40 years. So all we have to only give a little attention. It is not fit and forget it. No. Fit and remember for some time, continuously. That's all needed for that.
Means a continuance with of fit, it is you are advocating for you have to be continuous in fit.
And the time is not very far away. We are moving from an independent transformer to the completely connected transformer. So this is not too far away. Once this is online, naturally the monitoring, everything will go online, more diagnostic systems, artificial intelligence, everything comes and takes place. Transformer will be in safe place.
Yeah, actually I'll tell you one thing, sometimes also it is been taken in different WhatsApp group also, the age is a number, is not it? That means what sir says, even if the one which is like 21 years old, if he is not fit and fine, then automatically it will be dealt that he is out of the track. But a person with 80 years old, if he is managing and fit and fine, then it has to be there. So you are advocating that everyone should have to be fit.
Yes.
Forget is different kind of things. Everyone has to be fit. We have to make all the transformer fit first of all. To cater the things, whatever the age is there. And I mean to say, whenever dying, it should have to go for Nirban. Today morning I was talking about, it should have to go for Nirban. So we have to go for like that. Okay, final conclusion to be taken up by Dr. Arora, please.
We have talked much about transformer, but I am going to give you the final takeaway of the session. It is applicable for every equipment you purchase. You have to keep in mind the 7 C's. Everything starts with correct specification of the utility. Then correct design. When correct design is there, correct commissioning. Then comes the correct connection with your ground. Then comes the contamination free. There should not be ingress of any water, moisture. Then comes the correct coordination of protection system. 7th point is the correct clearances you have to maintain. Last but not the least, correct designing everything to ensure the safety. And it can be summarized in a line: defeat the defeat before that defeat defeats you. This is a big challenge. Thank you.
Yeah, really it was very kind of inspiring talk, we can say. And this particular one, ATES 2023, we are about to close, but ATES 2024, there was a session to consider about the ATES 2024. So please keep the one, what should be the ATES 2024, but our ATES is always will be there, only theme will be changed. So as ATES 2023 starts with a theme being transformer technology now and next. So please keep in your mind, we will be deciding during the time of a concluding session regarding the ATES 2024. So you are our support. keep in your mind what should be the attest 2024. Not now. Right now we are concluding, and I will be asking to come forward. So I am the moderator.
I only have one word, sir, before we all close. One, there are two people deserve a very good appreciation. One, the great electrical mirror team. They really worked for that. They deserve a big round of applause from all of us. All of them has worked day and night for this, to make this program for success. This is their first program, and none of us will realize that. They really made a fantastic show. Second, the great P.K. Patnaik. P.K. means Power King. So that P.K. Patnaik deserves a huge round of applause for keeping the tempo from time zero to time infinity. His contribution to the industry is well known, and this program was super success thanks to this P.K. Patnaik, sir. Thank you very much.
Will be there, so please be here. Just only 1 minute. So please.
Wow, I must say that the panel discussion was truly enlightening and filled with valuable insights and knowledge. Thank you to our esteemed speakers. Well, now it's time for the felicitation ceremony again, and for that, I would like to call Mr. P.K. Patnaik, sir, to come forward and please extend our warmest greetings to the speakers.
Now two passion kings meet each other. Click this photo, put it in headlines tomorrow. This photo is like a Modi Biden photo today.
And now I would request R. Prakash sir to please present the award to Patnaik sir.
This is with Hardeep because it will be of award-winning
Sir,
session.
I have one request for electrical mirror team. The next ET is ES. Please have it in south of India.
South of India means you mean to say so, because he is planning to take it out from north, taking to south. Okay, definitely this consideration will be taken by this electrical mirror wing. Over to Hardeep, please.
Now I would like to take a moment to announce that we'll be taking a short tea break and
After completion of this award-winning session, we'll go.
Okay. So what else do I?
फिर हम टी आराम से बैठ के टी पियेंगे फिर आते हुए अवार्ड मिलेंगे पूरा पेश कर Now, ladies and gentlemen, and esteemed guests, with great excitement, I'll be announcing the award winners. We have two major awards today. The first one is Best Technical Paper Award, and the second one is Best Invited Experts cum Sponsors Discussion Award. For presenting the awards, I would request Subhash Chandra sir to please come on stage. Could we give a resounding applause to him? The Best Paper Award. Do you guys have any guesses? Anyone wants to guess their favorite ones? Any guesses? Your favorite ones? Alright, we are already running short of time. But the Best Technical Paper Award goes to Mr. Tanveer Adil for cost-effective and quality control during in-house transformer repairing. We have one more winner for this category. That Best Technical Paper Award goes to Mr. Yogesh Sood for online transformer moisture removal system for unattended substations. Moving on, the second category is Best Invited Experts cum Sponsors Discussion Award. And the first winner is Dr. Rajesh Arora, DTL for Evolution of DGA Testing and Overview.
winner for this category as well. Another one is Team Eason and MR ATC for ATC sensing a powerful way to save transformers from fire floods. Now we will be presenting award to all the speakers of technical session 1. The first one goes to Mr. Thukaram K. Please come on stage, sir. Followed by Dr. Hari Om Gupta, sir. Next one is Mr. Tanveer Adil, sir. Followed by Mr. Srinivas Shripat. Next up we have Mr. Yogesh Sood. Followed by Mr. J.K. Gupta. Next up we have Mr. Nabarun Banerjee. Followed by Miss Manjusha. Next up we have Mr. B&D Bhomik. Next up we have Dr. Rajesh Arora. Followed by Dr. Anil Khopkar. now we are basically presenting the certificates for invited experts cum sponsors discussion category. Next up we have Team SN and MR. Followed by Mr. Shyam Ravichandran. Mr. Pranay Karjavkar. From Team Altanova. Presenting the trophies to our sponsors. The Platinum Trophy goes to Altanova. trophy goes to Izin MR. Next one goes to Sonal Instruments India Private Limited. And the next one goes to KRYFS Technologies Private Limited. Followed by Shripat Tech Innovation Corporation. And to conclude with its new god. Now I would like to present the awards to our dedicated authors for the magazine. The first one goes to Mr. Harshal Malwar.
Actually, I wanted to get you know what exactly for which Harsalji is now getting awarded here. He is the regular writer of electrical mirror. Whenever Hardeep just declared, it was not clear. That's why I just interfered. And he is the regular writer and always writing for electrical mirror. You might have seen also the electrical mirror, and Harsal is there always. So with Harsal,
followed by Dr. Rajesh Arora, sir. And now we have one more dedicated author with us. For that, I would like to request Subhash sir for presenting the award to Engineer Patnaik sir. Now, as we mentioned that a lucky draw will be conducted at the conclusion of the conference. So I hope everyone has got their chits. No one has missed it, right? Okay, so right now we'll be keeping a bowl over here and there will be 5 chits in it. So all the lucky drawers who will get that will be our winners for today.
So actually, it will take a bit time. That's why we have got the ATES 2024. What should be the theme? Already a place been declared by sir. Prakash sir already place been declared. It will be towards south side. So that has been, that may be considered. I am not the person to take decision, but the electrical team, they will be taking the decision out of it. Now we'll be going for the one ATES 2024. Okay, what should be the theme? From this side, I'm not talking that the total title, only the kind of subject which will be taking. Thereafter, we will be giving one catchy title. We will be giving the catchy title, don't worry. जैसे कि हमारा ट्रांसफार्मर था, हम लोग catchy title दे दिया, ट्रांसफार्मर टेक्नोलॉजी नाउ एंड नेक्स्ट TTN. So ये साइड में हम लोग अभी will be asking for what should be any guess, sorry, any kind of choices from your side, please. Yeah, make India free of accidents. Okay, one of the choices is coming. Sir, please. Electrical safety means safety. This is the one is coming from safety. Anybody else? Transformer for new applications. Electrical safety now and then. Okay. Yes. Yes. Fit and fine. What fit and fine? The person concerned to be fit and fine? Transformer technology. Again, transformer. Okay. Grid security. Okay. transformer-less network. I mean to say very good kind of things. Anyway, any others? Sir, please.
Condition monitoring of electrical equipment.
Condition monitoring of electrical equipment. Yes. Electrifying nation. Anybody? Any guess? Or any kind of suggestions?
Transformers for global market.
Transformer for global market. Okay. Impact of EVs on power sector. Good. Health indexing on electrical network. Umesh ji. Yes, okay, technology for prevention of electrical faults. Renewable energy, also the kind of things being considered. Transforming nation to technology, means emerging technology now and next, kind of things. Emerging technology now and next. Yes. If I now go for the kind of topic what exactly you told, at the end actually I took a point, which is the combination of all. Okay. So we can go for, it was actually the things of transformer technology now and next. Thereafter we will be going for emerging technology now and next, ETNN. So whenever we go for ETNN, it's my actually kind of thing. So it covers up everything. And in that, we'll be trying to put a catchy word relating to the safety. Because ETNN also may be focusing towards safety, but we will be developing such a kind of things where safety also to be included. Condition monitoring is being there in the emerging technology. Okay. Of course, electrical terminology is not there. We'll add it because emerging technology now and next means there might be paper coming from also some other corner like IT sector paper will be there, which is not associated, may not be associated, may be associated also electrical system. So emerging technology now and next, if we keep with that, we'll be using two words. The catchy word we'll keep it. One is the electrical terminology or the power system terminology. We'll keep it in between, and also the safety. If everything is fine, then should I go for that particular one as the theme for ATS 2024? Everything is okay? I will be adding everything. We will be adding everything, but your concept is to be taken, considered like safety also will be as one of the subject. Yes, yes. Now we'll keep it in that particular word. There will be one safety word will be there and the electrical terminology word will be there. But whereas emerging technology, kind of a new concepts what it has come up, because the new chaps those are coming, those are doing any kind of new things, so they must be also engaged to do the new things. That's why the emerging technology kind of things we'll be keeping in mind. Hope so. We'll be keeping the catchy word. So you will be getting to know ATS 2024 in that way, something like in this manner. If I am correct, then we can go for the last hour session. Very quickly we'll go for. So please tell, is it yes? Yes. Okay. So no worry. The catchy word, everything we will keep it here. So I think we are ready already.
So before that, among us, we have one special guest who have contributed immensely. Can we have a huge round of applause for Mr. A.K. Kaul, sir? We are extremely grateful for his invaluable contributions. So now I would request Mr. Patnaik sir to please pick 5 chits from the board. Yes.
Is it a single digit or double digit? In which manner you need to have? Double digit. You need not to have single digit. I think single digit have gone away, I think. Oh, okay. Something close to 50. Yeah, please guess. Something close to 50, might be above to 50 also. Okay. Yes. Really, it is a great kind of things. The choice which has come up from that side, that is of 47, 47. It is huge. Fantastic. 47. Please come to the rest, please. Lucky. Not getting this gift, but lucky of him actually. So lucky. Where is the gift? This is really interesting. Yeah, 47. That's why you have clearly told from that side that is the 47. Thank you. Okay, someone else you come. Monica, you come. Okay, again, single digit or double digit? Again, double. Oh, it is very close to 30. Very close to 30. Might be 32 also. Might be 30 itself also. Yes? 27. Should I declare 27? Is it yours 27? It is 27. Who's 27? But it is not 27, it is 25. 25, please. 25. Not there. So the number was not getting, voiced, no. The 25 is not there. I think Monica is unlucky. Okay. Hardik, you come. Left corner. Okay. Now it is again close to 50. Yes. 45. Any guess? 46. Never be 47 once again. Yes. 49. 52. 30. 31. It is 54. I think it's not there. Okay, once again, you are also unlucky. Subhash, you please come. Yeah, it is close to 300. You can't believe. I think 300 have not come. It is close to 100. 96. Yours 96? Oh, great. Anyone? Anyone else? 102. No? Anyone? No one. I think this is also not there, what I felt. Because no one is shouting in that regard. So this is 94. You are there, ma'am. Please come. Oh, great. Come, ma'am, come. Your seat first of all? Where is your seat? Is there? Correct. Thank you, ma'am. Thank you. Yeah. That one, which already came out. This one. Yes. Again, close to 25. 22. Make it bit closer. Make it big closer once again. Yeah, it is correct. 26. Who's 26? Not there, 26. So this particular cheat how like came out, the person concerned also gone out. No, we cannot make it 92. It is ulta ho jayega. Come on. Okay, I am taking up my own. Yeah, definitely I will take a good number. The person concerned shall be there, should be there. It is close to 15. 15, close to 15. 13. Make it bit closer. Beat it closer again. 15, beat it closer. Yeah, absolutely correct. 16. Who's 16? Oh, great. Exactly. I was expecting that from you. Make it 91. You once told that side, no, make it 91. So right now 16 को ऐसे उल्टा कर देने से 19 हो जाते हैं. Oh, please stop. We'll have because of this mistake we will have 2 awards. 91 and also yes. But thereafter if 91 comes, that will be forfeited. Come. Yeah. He is having also 16. You are having also 16. You are also 16. He is the past 16. Okay. ये actually एक lesson मिला. Here also 16. How come 91, 16? दो 91, दो 16. Okay. Come on. I think only another. Make it 2. Another one. One more. Another 2. Ready? मैं अंदर जाऊंगा, यहाँ डिक्लेयर करूंगा, सरदार जी से लेंगे, अपने का होने से नहीं देंगे. Okay, so right now it is close to 47. 45, 48. Anyone is there? 48? Please. Come. 48. अभी ये तो 84 नहीं होगा, जैसे भी उल्टा लेने से वो 84 नहीं होगा. थैंक यू. दिखा लीजिए. So, last delegate award. Luckiest chap. Let's see who. My number is not there. देखते हैं who really passionate of getting a award. Please tell. I will declare that name. You? What is your number? 35. Okay. So let's see. Your passionate counts or not. भगवान सुनते हैं कि नहीं देखते हैं. ये सेम डिजिट है. 1 1 2 2 3 3 4 4 96 कब बोले एसएम 5 5 9 9 who's 9 9 it is now 9 9 okay, don't worry. 7 7 yours sir 7 7 okay, so which one is left out? He is the winner. Which one is left out? Please come to the dais. Which one is left out? Please come to the dais. Please come to the dais. Please come to the dais. Which one is left out? Which one is left out? अरे 22 बोल दिया. मैंने नहीं बोला. 8 8 88. Come on, 88. 88. Oh, great. 88. कौन सा क्लाम पे जुड़ेंगे आप?
Maybe a Smarty, temperature sensor integrated connectors.
So he is asking that 88 clamp से जोड़ेंगे. वो है actually Smarty. So Smarty में जोड़ेंगे 88. Smarty is for 88. So we will be remaining. And in the address 2024, definitely we will be expecting to you with Smarty. So thank you all, and I will be requesting, it is a final kind of request, please come to the dais. We will be having a group photo. We can have, please come to the dais, please. please come to the dais. We'll go for high tea. Please come. राजेश जी आ जाइए 1 मिनट. आ जाइए 1 मिनट. प्लीज आ जाइए प्लीज. ये फोटोग्राफ रह जाएगा.
All of you please come on stage.
सर को बुला लीजिए. सर with folded hand we say please 1 minute. Please come. high tea, and we request all the electrical mirror team to come to the dais to have this snapshot session. Electrical mirror team, please.
I would request the entire electrical mirror team to be on stage, please. So now I would like to take a moment to announce that we are having a short tea break right now. So make sure everyone... What? I hope the entire electrical team is here on stage.